Now I request Shri H. Ramlianji to start the session with his opening mic remix.
Thank you. Welcome everyone to this session. In this session, we'll be having 4 presenters on different paper.
So we have some more presenters. Sorry for the interruption, sir.
Okay.
We have some more presenter over there. Can we have Dr. Dulal Chandra Shah, Managing Director, Inspector Design Consultant Private Limited, and Dr. Sanjeevani D. Nigadesha Shah, Executive Engineer, PWD Maharashtra. Namaskar and welcome, sir. Can we have Dr. S.K. Bagu and Ms. Atashi Das, AVP, GR Infra Project Limited? Requesting our chair of the session to please begin. Sir, we can start the session with your opening mic. Thank you so much, sir.
Thank you once again, and I welcome you all. Today's technical session will be having 4 presenters. And the first one will be IITR BBM, an innovative tools to produce durable bituminous mixture by Dr. Nikhil Sahu, Sri Dhiraj Mehta, Sri Aniva Sharma, Sri Rajit Kumar, IIT Roorkee, and that is paper number 737. And paper number 739, use of cost-effective stone matrix asphalt, SMA, layer in place of bituminous surface course in low volume roads by Sri Tarun Gupta, Assistant Engineer, PMGSY, Jammu and Kashmir. And paper number 744, contractual and technical implication of authority, prepare feasibility studies and DPR in EPC HAM road project by Dr. Dwal Chandra. And the last paper, but not the least, paper number 745, case study of falling weight deflectometers and application of machine learning model by Dr. S.K. Bagu and MS Atashi Das, AVP GR Infra Project Limited. So each presenter will have 15 minutes, and from floor there can be an intervention of 5 minutes. And I hope everybody will gain some enjoying knowledge out of this, because road construction with bituminous concrete or open graded or bituminous macadam is essential, even though nowadays we have white topping, we call it concrete pavement, PQC. But we cannot afford by everyone. So hope everybody gains some knowledge out of this. And now, shall we start with the presentation? Because I think we are getting delayed. 15 minutes, if we take 15 minutes by every presenter, we are going to exceed our time, which may affect the second session. So now I'll call upon, the first paper is available, IIT? Huh? Okay, we'll start with the second paper. Now we'll call upon Tarun Gupta, Sri Tarun Gupta, Assistant Engineer, PMGSY, Jammu and Kashmir. All the best. Thank you.
बड़ा कर दो, ये हटा देना। Good morning to all of you. I am Tarun Gupta, currently working as an assistant engineer in PMGSY Jammu. Now, my such research work is use of cost-effective stone matrix asphalt layer in place of bituminous surface in low volume road. Then this is a whole methodology of that paper. Firstly, as we know that the rural road has been designed for, as per IRC SP 72 2015. No, for traffic category T9 category, when the ES equivalent standard axial load is equal to 1.5 to 2 MSA, the thickness of the bitumen surface course consists of 50 mm BM, then 20 mm OGPC. Now, in this paper, we have to replace 70 mm thickness is replaced. This paper has been detailed in 70 mm thickness is replaced with 40 mm stone matrix asphalt layer.
I think we will shift our chair so that you can see the full screen.
Okay.
No, it's okay.
Okay.
I think you can.
Huh. Now proceed on this 70 mm layer, 50 mm BM plus 20 mm OGPC can be replaced with 40 mm stone matrix asphalt layer. Basically, the stone matrix asphalt layer is a gap graded mix in which the load can transfer from stone to stone contact. For 40 mm stone matrix asphalt layer, we have two criteria. First criteria is stone to stone contact, and then second criteria is the drawdown test. The first stone to stone contact mean the stone to stone contact mean the void in the coarse aggregate in the mix will be less than the void in coarse aggregate in the dry roaded condition. If that condition is satisfied in the later on, then this is a stone to stone contact. And the second is the drain down test is mandatory because as per IRC SP 73-2023, it is recommend the bitumen content in the stone matrix asphalt layer may be minimum as 6.25, 6.5 up to 7%. Due to high bitumen content, there will be a drainage. This will be a condition from drainage of bitumen. Because during laying compaction, there is a drainage of bitumen. To prevent that condition, we have to use core fiber. Core fiber does not impart any strength to the mix, but it only prevents the drainage of bitumen. If that condition is satisfied, then this is okay for stone matrix asphalt. If it is not so, we have to change, we have to increase the core fiber in the moisture stability test. If both the conditions are satisfied, drain down and stone to stone contact, then it is for the analysis of the payment. This 70 mm is replaced by 40 mm. Is it possible or not? Is it possible or not? For that, we have to analysis of payment as per IRC 37-2018. We have two criteria. Further, we have two criteria. First is the rating criteria, and then second is the fatigue criteria for 80% reliability equation because this is a low volume road. For national highway, we have to use 90% reliability equation, but in our case, we have to use 80% reliability equation. If both the condition are satisfied, then it is a cost analysis. If just as assume if the fatigue criteria is not followed, means not satisfied means the calculation of the strain by IIT-PF software is less if increased than the permissible value, then we have to increase the thickness of SMA layer. In the further study, we have discussed in full detail for analysis of payment. If both the conditions are satisfied, then we have to last step cost analysis, if it is cost effective or not. Is that 40 mm SMA layer is cost effective or not? Then it is a whole methodology of that paper. No, as per the chart for T9 category, we have to see that this 200 mm GSB, 225 WBM, WMM, and 70 mm, 50 mm BM plus 20 mm OGPC for T9 category when the subgrade CBR of the subgrade is 5 to 6%. As per the IRC 2015, the traffic category, T9 category, in some of the cases in the J&K region, the snow-bound region, most probably this 60 to 70% region is snow-bound region. And NRDA is directly recommend the thickness of the bitumen surface course is 50 mm BM plus 20 mm OGBC. Whether the traffic category is T4, T5, T6 up to T9 tak. But it is directly recommended this is a 50 mm BM plus 20 mm OGBC. Now in this study we investigate the application of SMA in place of BM plus OGBC. Basically, the stone matrix asphalt is a gap-graded mix, consists of two parts. First is the coarse aggregate, and second is the rich bitumen content. Basically, the gradation of the stone matrix asphalt will be the 90 mm. The 90 mm is the upper sieve, and the bottom is 75 mm. But there is a break point sieve that is a 4.75 mm. Means the particle up to the 80% will be retained on 4.75. Because this is a stone-to-stone contact, passes from 19 mm, then retain 80 to 85% should be 4.75 mm sieve. In the condition of the stone-to-stone contact, means the point add with the void in the coarse aggregate in the compacted mix of SMA should be the less than the in the dry eroded condition. On the other hand, the bitumen and the filler content in the SMA minimum for IRC SP 73 2023 will be the minimum bitumen content is 6% and 8% for the filler, up to the 8% for the filler content to prevent the binder drainage to bottom in the truck during transportation of the mix. And this is the material use. The aggregate use in the locally material use in the Jammu region. The nominal size of the aggregate is 13 mm was placed in SMA with different bitumen content start from 6%, 6.25, 6.5 up to 7%. And the grade of the bitumen used in the mix is VG30 grade. And the filler material that is used in this mix is the coir fiber, and the dosage is the coir fiber 0.3% by weight of the total mix. And this is an experimental investigation for the gradation of the 40 mm SMA. In see the gradation, the 4.75 sieve is the breakpoint sieve, in which 20 to 28% should be retained up to 4.75 mm sieve. And this is the combined gradation from stone matrix asphalt layer for during the gradation by IIT Roorkee software developed by the IIT Roorkee. And the experiment investigation, the moisture stability test is to be carried on with 1200 gram of sample should be taken with addition of 6.255 from the bitumen content, vary from the bitumen content, and 0.3% by coir fiber is added to the mixture. After the mixing, this is the most important part. After the mixing of mixture, this mixture is placed on the oven 140 to 150 degrees Celsius for short-term aging or conditioning. Because we have to absorb the bitumen on the surface of the aggregate during transportation. Yeah, sometimes it also called as the short-term aging or that is a conditioning of the mixture. After the short term, this mixture is transferred from the mold, moisture stability mode, and the 50 number of, this is the most important part, this is 50 number of blows on each of the face. In DBM, BC we have to use 75, but in SMA we have to use 50 mm number of blows on each of the side of the face of sample. Then this is the moisture stability test result. In this in this table we have at the 4% air void, the bitumen, their corresponding bitumen content is 6.25. And at the 6.25 bitumen content, and all the properties should be satisfied for VMA, VFA, and the flow value of the mixture. And this is the first, we have two criteria. First is drain down, and second is stone-to-stone contact. The drain down condition, for drain we have to use coir fiber. In that we have to take the test ASTM D36390, consists of sample is placed in wire basket. The wire basket is the force for 165 to 170 degrees Celsius. And during the calculation, the drain down value should be equal to, comes to be out 0.4145%. But which is, and as per the IS code, we have recommended the maximum value 0.3%. And the second criteria, that is the stone-to-stone contact. To satisfy that condition, there will be a volumetric analysis of the mixture. The calculation of the stone volumetric, we have to satisfy that condition. That is the void in the coarse aggregate in the compacted SMA mix should be less than the void in the dry eroded condition. This is the whole calculation in this slide, and the whole calculation is always present in the paper as in journal. And the same as the determination of voids in the dry roading condition. In this condition, we have to satisfy VMA void in mineral aggregate should be greater than 17%, and VC dry should be greater than VC mix. And this is the whole calculation is given in the paper. This is another parameter, that is a bitumen film thickness. This is the most important parameter. For the calculation of the bitumen film thickness is related to the bitumen content absorption characteristic of aggregate, gradation of aggregate. The bitumen film thickness is calculated in the paper, is a whole calculation is done in the paper, is equal to, the comes to be 12.59 micron meter at 6.25 bitumen content. But as per the IRC SP 135 2022, the thickness should be at least 6 to 8%. 6 to 8 micron meter is related for the mixture is durable and stable. Basically the thickness, between film thickness, increase between film thickness, reduce the stripping effect. Reducing the stripping effect, that is the breaking of the adhesive bond between the aggregate and bitumen in the presence of moisture, should be reduced during monsoon season. And the other parameter, that is the statistical indirect tensile strength and moisture susceptibility. During in the ITS test should be performed in that mixture. And without fiber, we have to calculate, that is 79.16% TSR value. But with the addition of 0.3% of coarse fiber, that is, then the TSR value should be increased from 79 to 91%. And this is the first part, that is the SMA. The second part, this is conventional method, that is the BM 50 mm BM plus OGPC. And this is the bitumen macadam with OGPC with seal coat. Basically, the bitumen macadam is open gradient mix and high permeable mix, having the void as high as 20 to 25%. So, and the OGPC, the aggregate is two single size aggregate, 22.4 mm and retain 11.2 mm, and passes 13.2 mm and retain 5.5. Moreover, the high void content in the mix, this is a permeable mix. BM, basically this is a permeable mix and causing the stripping of bitumen from aggregate. If there is a patch during running season, in most of the failure of the payment during the monsoon season, if there is a stagnation of water on the surface of the road, there will be stripping of the bitumen is caused. To optimum bitumen content in BM is 3.5% by beta total as per IRC. We have to calculate in the paper 27 2009. And this is the whole calculation for the whole calculation of both the layers for OGPC plus seal coat. The total combined bitumen content is 4.14%. Then we have to replace 70 mm with 40 mm. Is it possible or not? For that we have to analysis of design. This is analysis done with the help of the code IRC 37 2018. And this is a mechanical empirical method, performance based on the parameter stress and deflection calculated by linear elastic theory. We have the two criteria. First is the vertical strain at the top of the subgrade soil, and the second is the horizontal strain at the bottom of the bitumen surface course. Now we have two equations, the rating equation and the fatigue equation. For 80% reliability equation, that is the rating equation and the fatigue. And in the last table, we have seen that the horizontal strain and the vertical strain calculated by the IIT PF software, it is a 4.79 10 raised to minus 4 and 7.35 8.12 into 10 raised to minus 4. And on the other hand, where the permissible stresses in horizontal and vertical, which has to be calculated as per the IRC 37, is 5.25 and 9.60. And it is calculated the IIT PF software. It is calculated that the strain calculation during IITPF is less than the permissible values. And this is a diagram for we have to calculate the strain and this cross section of the payment design. And then the last step is the cost analysis. This is the most important part. Cost optimization and cost effective. This is the most important part in that portion. So we have to design a section for 1 kilometer for width of 3.7 meter. We have to design a payment. Then that is a BM with prime coat, tag coat, and the seal coat. We have to calculate the cost for 1 kilometer 27 lakh. For T9 category, and the subgrade soil is 2 to 15%. And I should earlier be said that this for snowboard region, we have an idea directly recommend for 70 mm, whether the traffic is T4, T5 or T6 category. As per the analysis, as per the data of JK SOR 2023-24 from ruler of PMGSY road of J&K. And on the other hand, the estimate for stone matrix asphalt for section length of 1 kilometer and the width is 3.75. On the other hand, we have to calculate this is the cost is 19.61 lakh. This is in the observe that there is a saving of material. There is a saving of material and saving of cost optimized 7.39 lakh per kilometer at the rate 27.37% per kilometer only in the bituminous course. That makes the cost effective. And the analysis, main part is the analysis of the that rate of SMA in the in next slide, the last slide we have to discuss. That is that rate is a 453 meter per meter cube. That rate analysis in explain in next slide. Then this is a conclusion. The whole conclusion, the master calculated master stability value 13,1395 kg at the air wide content 4% and optimum bitumen content is 6.25. That makes a mixture high density and more strength, high performance than their conventional mix. This high bitumen content contribute to longevity of the payment. And the most important part is over the 90% of the SMA project, as per the NOPA condition as a National Asphalt Payment Association, it will publish that 90% of the SMA project have rating measurement less than 4 mm and 25% of the project that could not measurable rating, that has no measurable rating, and SMA has 3 to 5% greater resistance to fatigue cracking as compared to the dense graded hot mix asphalt, just as a DBM and BC. So then as per IRC 135 2023, I also calculated the bitumen film thickness of BC is less than the that is the SMA layer. Then due to the high bitumen content in SMA, the thick between film layer around the aggregate, that reducing the stripping effect, that is a adhesive bond between the breaking of adhesive bond between the aggregate and bitumen in the presence of moisture and reducing its durability, and it also increases their durability. And this is the most important part in PMGSY, Pradhan Mantri Gram Sadak Yojana. SMA may also be used as a renewable code overlay payment. After the defective liability period is our 5-year defective liability period is completed, then we have to use as a overlay design for SMA layer. It is observed that there is saving of material 7.3 lakh per kilometer. For that analysis, SMA layer in place of BM and OGPC, we have to use 37 IRC code. The computed horizontal strain calculated from IIT PSR should be less than the allowable horizontal tensile strain and same as the vertical strain. And this is the last slide for the rate analysis of 40 mm SMA layer as per JK SOR 2023 and 24. This is the whole analysis that makes a cost effective layer, and the cost of 1 meter cube, that is a SMA layer 453. Thank you.
Thank you, Sri Tarun Gupta, giving us a new idea for PMGSY road pavement, and it is quite inspirational. Now we'll call upon Mr. Dr. Dulal Chandra Saha to give a contractual and technical implication of authority, prepare feasibility study and DPR in EPC HAM Road project. Welcome. Thank you.
Respected Chair, respected Co-Chair, other dignitary on the dais, respected delegates, my colleagues and friends, a very good morning to everybody. Right? My name is Dulal Saha, and the name of my topic for today's discussion is Contextual and Technical Implications of Authority Prepared Feasibility Study and DPR in EPC and HAM road projects. At this outset, I would like to convey my sincere thanks to IRC for publishing this paper in IRC Journal and also selecting it for today's presentation and discussion. During this presentation, we'd like to explain how authority prepared DPR reduces efficiency of EPC and HAM projects by undermining risk allocation of this type of projects and thereby fueling disputes. Okay. The sequence of my presentation is actually in two parts. In first part, in one single slide, I'd like to give the summary of the total presentation and subsequently a little brief. And the summary is like this. At present, it is prevalent in India that project authority prepares DPR before tendering. Project authority prepares DPR before tendering, and the supervising agency, that is authority engineer and IE, enforces the DPR detail during implementation. Whereas, as we know, that for EPC and HAM project, design responsibility completely lies with the execution agency, that is the EPC contractor or the concessionaire. And here lies the fundamental risk-sharing disturbance of authority-prepared DPR. And the consequence of this creates severe contractual ambiguities, design conflicts, time and cost overrun, and it also restrains innovation. As an evidence, this analysis will be supported by various contractual clauses of NHI and HAM, NHI and MORTS, EPC and HAM projects, and some real-life case studies. As a solution to this paper, some actionable mitigation strategies, including some model contractual clauses, will be presented. Now, as I said, the detailed part is this. The first one is the ideal model versus Indian reality. The ideal model of EPC and HAM projects is this. The authority needs to prepare an accurate DPR based on correct investigation data. The objective of the DPR feasibility study is to define the projects very clearly. There should not be any ambiguity in the scope. And also to define the performance parameter. What is expected, how the various requirements and facilities are expected to perform during its design life. And the contractors accordingly will carry out the detailed design, prepare the working drawing in compliance with Schedule D. The single point responsibility of design incorporating value engineering site and site constraint will actually lie on the contractor. This is the actually ideal model. But what actually happens is a little different. Here, as I said, actual situation is different. Along with the feasibility study, the authority prepares DPRs also. And once the DPR is prepared, during execution, its supervising agency, that is AE and IE, will insist on implementing the DPR details, right? And this disturbs the fundamental risk-sharing principles of EPC and HAM contract. This creates parallel design narratives and a fundamental conflict from the day one. Contractors' mandate to innovate clashes with authorities' rigid and preconceived solution. The objective was, in risk-sharing objective was to give the contractor for design flexibility, but in this, if the DPR is prepared, it actually restrains that. The second aspect is how the contractual intent versus on-ground practice. What the contracts say. As I said that we have two types of contracts. One is EPC, another is HAM. In EPC, the contractors bears the full design risk post-tender. And it is defined by the key clauses like no review or observation by authorities engineer shall relieve the contractor of its obligation. If there is any error, that should be corrected by contractor at its own cost. Similarly, in case of HAM, the concessionaire submits the detailed design to the independent engineer for compliance check. I'm stressing on the word compliance check with respect to the Schedule D, not approval actually. And here the key clause is the concessionaire remains fully liable for its design obligation, irrespective of IE's review. Say for example, IE has reviewed and did not give any adverse effect, but the design does not work. So here I is not responsible. Responsibility lies with the HAM concessionaire. So from both these things, what we see is the design responsibility purely lies with the contract agency. Whereas if the DPR is prepared, then and I and A insist on implementing the DPR details, then actually it is a conflict. That is my main point. So on ground, what is happening? And what is happening is actually the deviation. Authorities, having invested so much of money in DPR preparation, naturally insist on its enforcement. And its agencies like IE and authority engineer rejects concessionaire's design or contractor's design if there is any deviation from the DPR, even though it satisfies the Schedule D, that is performance parameter. This undermines the contractual risk allocation. So this is actually the conflict, and that is why, as per my understanding, authorities should not prepare DPR before tendering. They should restrict themselves to prepare the feasibility study only based on detailed and accurate site investigation. And there are some key complications because of this thing. The first key complication is deemed approval trap. In the contract, we have seen that IE or AE needs to review the design within 15 days or 30 days of submission of design. And if they fail to do that, then the design should be deemed to be approved. All of we know that this does not happen. So it is actually a trap. As a case study, I'll mention that in one project in Rajasthan, the contractor proposed cost-effective and eco-friendly fly ash stabilizer as per Schedule D provision. The I has rejected it, mentioning that in DPR something else is there. Though the contractor's provision was in full compliance of Schedule D, but as it is deviated from the authorities' pre-tender DPR, it was rejected. Not only it was rejected, it was kept on pending for a very long period of time. Forget about 15 days or 30 days expired contract. And that is why I am saying that this is a conflict. And the second complication I would say is again as per FIDIC clause. I mean, FIDIC is the mother document from which the DPC and HAM contract provisions has been taken care of. Here the employers provide site data, all site data, be it geotechnical engineering, utility surveys, and utility relocation plan thereby, land acquisition and all other things. They should give the data, and the contractor should rely on that data, and their job will only be interpret that and submit their bid accordingly. Now what we see is that the basic data many times are at fault. Geotechnical investigation, we see a lot of mistakes are there, based on which contractor has prepared his bid. Then when execution, they found after detailed site investigation that it is completely mismatching. So I am saying here the conflict is authority probably instead of spending time and money in preparing DPR, they should probably spend money and time more on preparing the correct feasibility and also taking responsibility of their investigation data, which are the basic data for preparing the bid. Now, as a case study for this complication 2, I will mention two. I will cite two examples. One is recently completed Mumbai-Nagpur Expressway. Here, as per DPR data, rock was assumed at 3 meter depth, 3 meters from the surface. But after detailed site investigation by the contractor, it was found that rock is available more than 15 meters below. So the complete details of foundation system has changed from shallow foundation to deep foundation. That has raised to the cost. There is disruption and it is in litigation. Similarly, another case study is in one of the national highway projects in MP, where in DPR's detail, there was no mention of any major utility along the proposed corridor, proposed alignment. But at the time of execution, what is found is for several kilometers, 7 to 8 kilometers to be precise, huge, very large dia water pipelines were there. And it was not possible to construct the road over that water pipeline for various reasons. So what was done is, it was decided to realign, change the alignment. And because of that, the whole thing restarted, starting from survey, land acquisition, design, review, approval, and all other things. So I am saying that they have gone to, to the extent of preparing the DPR. Instead of that, had they probably spent more time and money in understanding the base data, then probably these complications could have been avoided at the time of execution. Now, for key complication number 3, I would say that by this time, all the bidders knows that value engineering and optimization probably will be resisted during reviews and all other things. So they generally factor cost in anticipated delays, conflicts, and legal fees. And what happens, and this is precisely called rigidity risk premium. So what is the outcome of that? Less competitive bidding, higher cost of the project, and wasted public fund. And we can also see that majority of the inflation, cost reasons for inflation is actually delay in design approval. If we see, delay in design approval actually causes cost inflation because it takes time and money from them. So now I would like to go for a few recommendations. The first recommendation is actually limit the tender deliverables. I mean, authority need not to do any DPR. They should focus on preparing an accurate feasibility study, defining the scope of the project, that is Schedule B and C. Okay? And invest a little more time and money for establishing baseline, accurate, and if possible, independently audited geotechnical and all other surveys, topographic survey, utility surveys, and all other things during the feasibility phase itself, so that the post-award surprises can be reduced. Now, recommendation number 2 is, I said that for this type of project, risks are allocated differently. Some risks are associated with the authority, some risks are associated with the contractor. Now, as we have seen, the design risks are associated with the contractor. It should be ensured. The contractor should be given the free hand to design to satisfy the performance parameter following Schedule D. It may be different from pre-tender DPR even if it is prepared. The second one is the deemed approval clause should be strengthened. As it is mentioned in contract that review time is 15 days or 30 days by authority engineer or the IE. So if there is any delay, the contractor probably should get automatic time extension and cost compensation to compensate this idle charge for delay. And recommendation number 3 is, there are 3. Dispute review board shall be constituted from the very beginning so that any dispute can be taken up and quickly addressed to. And there should be some specific mechanism for rapid resolution of design conflicts. As I said, that you submit something, neither it is approved nor it is disallowed, it keeps on pending for perpetual time. So it affects the whole thing. That's why there should be some specific mechanism so that it can be addressed in time-bound matter. And then the third one probably is a little complex, but it should be there. DBR, Dispute Review Board, for the determination of any dispute, shall rely solely on contractual provision, that is Schedule D. And they should not rely on authority-prepared DPR because it is non-contractual actually. Now, as conclusion, I would say that current practice of authority-prepared DPR and its enforcement, automatically it is enforced by either authority or its supervising agency, is a major contractual flow for undermining, and that undermines the core benefits of EPC and HAM project. It creates an adversarial environment, fuels dispute, discourages innovation, inflates cost and time, and that leads to the inefficiencies of this type of contract. And the solution should be a collective shift. And what are those shifts? Authority should focus on preparing output-oriented and collect feasibility study. Contractor should focus on using its complete expertise to create efficient, economical DPR, satisfying the performance parameter as specified in Schedule D. And the contract must include clear clauses to protect the intended risk allocation. And this alignment of global practice is an operational economic necessity for achieving India's ambitious infrastructure goal. Thank you very much. Thank you very much. And if there is any question, probably we can address that.
Thank you, Dr. Dulal Chandra Saha, for such a good presentation for EPC oblique ham contract. And there'll be time to react from the audience as well as from the chair. Now, if the presenter is available for the next paper, paper number 737, IIT Rookie BBM.
Sure.
Yeah, we can call upon him.
Okay, so one more presenter, Ms. Dr. Nikhil Sabu has
Okay,
just
Dr.
arrived.
Nikhil Sahu. And we have to go a little fast, I request. Okay, thank you so much.
Thank you very much.
Sure. All right, we have one more presenter has just arrived right here. We have Ms. Atashi Das, Madam AVP, GR Infra Project Limited. Would like to welcome ma'am onto the dais.
Hello, hello. Okay. A very. Should we start, sir? Should we start, sir? Okay. A very good morning to all of you. Yeah. So, very sorry for the late arrival. I request the chair and co-chair not to cut our marks for the same. So, the topic which I am going to present today is a tool which we have developed recently related to a production of a balanced bituminous mix using some framework which I'll be talking about. So I would like to thank all the co-authors. Mr. Ranjit is present here today, but other co-authors are not here, including Dr. Dheeraj Mehta and also Colonel Avnish Kumar. So coming to the mix design, most of the audience, I mean most of the people are aware that a successful mix design in the bituminous mix is one of the starting point to ensure that the flexible pavement will perform well. Now, typically India follows Marshall mix design as per MS2 guidelines. And these are the two brief steps involved in the mix design process. One is proportioning of aggregates, where we have stockpiles of different aggregate sizes, which we have to blend in certain proportions so that we are within a given gradation band which is specified by the highway agency. In our case, it is Ministry of Road Transport and Highways. Similarly, the next step involves selection of the optimum binder content. So once we have selected the aggregate gradation which we want to use, then we will make the mix using different binder contents, evaluate the volumetrics, do Marshall stability and flow test, and based on certain parameters, we calculate what is the optimum binder content corresponding to typically 3 to 5% air void content. Now, one of the criticalities involved in this process, the first step is that since the gradation itself is a empirical step, we always tend to follow the mid gradation band. So gradation is basically controlled by control points, number of sieve sizes involved, and we intend to follow the mid gradation typically when we are doing the trial and error method. However, a lot of studies, in fact our laboratory studies have also proved that mid gradation may not be the best gradation for the considered aggregate stockpile. So this is one problem statement which remains unanswered. Similarly, a lot of variability is observed typically when we look at the volumetrics in the mix design. If you measure the theoretical maximum specific gravity, the bulk density of the mix, a lot of variability is involved. That creates a lot of variability in the air voids, in voids in mineral aggregates, voids filled with bitumen, and therefore the entire mix design. So, and we also have to see that does this use of the standard volumetrics, are they actually linked with the performance in the bituminous mix? So worldwide, people are slowly shifting towards something which is called as balanced mix design approach, or we also call as performance mix design approach. So our problem statement started when we started to exercise that what we desire in a mix. If you look at the mix, mineral aggregates, they form about 80 to 85% of the total volume of the mix. And for a given set of stockpiles, multiple solutions can be there when we talk about proportioning. So let us look at this example. Let us say you have 3 stockpiles, S1, S2, S3, and you are trying to produce a bituminous concrete 1 gradation or mix out of this using these stockpiles. So you have done the sieve size analysis in the lab, and now we want to blend S1, S2 and S3 such that we are within the gradation band of the upper limit and lower limit specified by the agency. So the first question is, in how many ways, mathematically, in how many ways can we blend these stockpiles to achieve the desired gradation? Now this is again a first question which we need to answer. Actually, there can be multiple solutions. So we initially developed another tool which we call a simple tool for aggregate blending, wherein once you input all the data of the stockpile, it will give you the total number of solutions. In this case, there are 199 possible ways you can mix S1, S2 and S3. So the next question is, out of these 199 possibilities which I have now evaluated, which is the best blend? So as again I said, people try to use a trial and error approach. Visually they try to fit a line in between the gradation band and they try to follow the mid gradation. So our argument to this process is that mid gradation may not be the best gradation. So what is the best solution then? So the best solution is a gradation which will assure that your mix performs well. When we talk about performance, we are talking about resistance towards rutting, fatigue cracking and moisture damage. So let us see what do we need in a bituminous mix. One, strong aggregate skeleton so that we can ensure rutting resistance in the mix, right amount of binder to ensure durability, and a balance in the mix structure so that it also ensures a good workability and constructability in the field. So we developed an approach wherein we took all the 3 key components and we try to optimize the aggregate gradation. So how do we do that? So first is selecting the strong aggregate skeleton, wherein we followed the traditional approach of maximum density line, which was given by Fuller and Thompson. Actually, the Fuller and Thompson equation is the one which is the basis of all the gradation people have been using worldwide. So our first key is that the aggregate gradation, which is closer to the maximum density line, will ensure a dense structure. But of course, I cannot densify the mix and reduce the air voids because I want to have sufficient space for bitumen as well as sufficient space for air voids. So the next component is right amount of binder. Here we use the idea of bitumen film thickness. Now, a lot of debate you will see in the literature that how to calculate bitumen film thickness, does bitumen film thickness actually exist or not? So a lot of debate is there. Of course, we have read a lot of literature, but here our idea is not to prove, not to claim that there is something called as bitumen film thickness. Why we are using this approach? Because it will give you that for a given aggregate gradation, what is the requirement of the mix to assure a minimum binder content. So use of film thickness indirectly ensures the use of a minimum bitumen content in the entire mix. So we use the process of aggregate asphalt film thickness or the bitumen film thickness so that the mix has at least a film thickness of more than 8 microns based on the surface area distribution of the aggregate profile. Now touching upon the next key comes the balanced mix in the structure. What is a balanced mix? We want to ensure we have right amount of larger particle sizes, right amount of mid-size aggregate particle sizes and right amount of finer particle sizes, so there is a balance in the mix. So here we use the Bailey's approach, which is again a very prominent approach used worldwide. So to understand the Bailey's approach, let us just divide our mix into certain key sieve sizes. We call it as nominal maximum particle size, half size, primary control sieve, secondary control sieve and the last sieve. For example, if you take a 20 mm nominal maximum particle size, so for the same 10 mm will be the half sieve, 4.75 mm will be the primary control sieve, 1.18 mm will be the secondary control sieve and of course the last sieve is the 75 micron sieve. So the particles between nominal maximum particle size and half size they comprise the larger coarse aggregates. Half size to primary control sieve, they are the interceptors. Primary control sieve to secondary control sieve, they are called as the coarse portion of the fine aggregate. And secondary control sieve to last sieve, we call as fine portion of the fine aggregate. So when we are designing the aggregate structure, we have to ensure that there is a balance between all the components. Then only we can ensure that there is proper stone to stone contact, which will finally perform as a skeleton and give resistance towards rutting. So we use certain ratios which we call as coarse aggregate ratio, fine aggregate coarse ratio, and the volume of fine aggregate to the voids created by the coarse aggregate as our key targets for the optimization process. Now once we blend all the three keys, first maximum density line, second film thickness, and third the balance in the aggregate structure, it can be mathematically combined into a formula which you can optimize using any optimization program. And you can arrive at the best composition of any given stockpile, any given set of stockpile to arrive at the appropriate proportion. Now here is a disclaimer from our side. As I said, we do not claim that there is something called as film thickness. If you see this cross section of the bituminous mix, you will see a lot of distribution of the bitumen in all the mix. Similarly, when we say coarse aggregate particles come together, they create a skeleton, which is not, theoretically it is fine, but practically you do not see it in a mix. You will see all the coarse aggregate particles are separated, and there are mastics which is binding all the coarse and fine aggregate particles. So in real sense, it does not replicate what we are assuming, but it gives us a mathematical approach to develop a balanced aggregate structure. This is what we are trying to do here. So we have already published a lot of work, one being published in IRC, two being published in other journals. You can look into these papers. It will give you the mathematical framework, which I am not trying to discuss in this presentation today, given the time constraint. But this is a freely downloadable software. There is no licensing fee. You can use it, you can just download it in your laptop, in your system, and you can directly use it. So this is called as Simple Tool for Balanced Bituminous Mixtures. We call it STBBM, which was earlier called as IITR BBM. We have renamed it to STBBM now. And using this tool, you can blend the stockpile. It will give you the proportions. It will also give you the right amount of binder you have to use to produce the mix. For example, I will give you a simple practical example. This is based on a real project which was executed in the field. We had 4 stockpiles. We wanted to produce a bituminous concrete 1 mix using these 4 stockpiles. So based on the results of the simple tool for aggregate blending, we evaluated that these aggregates S1, S2 and S3, there are 922 possible ways of blending them so that you arrive at the bituminous concrete 1 gradation. So again my question is, out of these 922 possibilities, which is the best? So if you look at the mid gradation, if you try to follow the mid gradation, it will tell you, you use 40% of S1, 17% S2, 41% S3, 2% S4. So if you use this proportion, it will give you a gradation which is closest to the mid gradation. Now let us look whether this mid gradation is actually a desirable gradation ensuring the performance of the mix or not. So an important question, as I said, which remains unanswered is that out of the 922 possible solution, which gives me the best performance. So this is the result of the mid gradation, closest to the mid gradation. So here we found that the coarse aggregate ratio is not within the desirable range, which means if you target the mid gradation, it may not give you a desirable blend, at least for the aggregates which we used in our study. So when we use STBBM, it showed that instead of the mid gradation, if you blend 38% of S1, 24% of S2, 38% of S3 and 0% S4, it will give you an optimum blend. And the tool also told us that for the mix, you use a binder content of 5.4%. This will ensure an average film thickness of around 9.5 micron in the mix. So when we tested the same mix, our laboratory results were very successful. It showed that in comparison to the conventional traditional approach, if we use STBBM as a tool, our performance get enhanced because there is more balance in the mix and the right amount of binder has been incorporated. So this data is available in the paper which we have just published in IRC. We have evaluated the volumetric parameters, including air voids, VMA and VFB. We have also evaluated the performance parameters using a dynamic creep test, and we have also used a cracking index test which we call as ideal CT. So all the results indicate that in comparison to the conventional mix, the mix produced using this tool gives better performance. We also got a chance, thanks to Ranjit ji, one of the co-authors, that we got a chance to produce or to replicate our idea in the field in one of the live projects, where we compared that how the mix produced using STBBM compares with the conventional approach. So this is the data which we used. One of the section comprised of DBM with VG30. There was another section, again DBM VG40, and there was a third section where they used BC using CRMB. So using the conventional approach, when the construction was done, we compared the compactability in the mix, we compared the surface characteristic, how the compaction appeared, and also the volumetric parameters. So the results are shown here, but what I need to point out is the type of mix you look. So on the left-hand side, you see the conventional mix where we found more segregation, and on the right-hand side, a mix which was produced using STBBM, it showed more uniformity in the mix. Similarly, we have few more photos to show, which compares how the mix looks like when you compact it using a conventional approach and when you have a mix which is produced using the derived tool. And this framework is again published in an ASC paper. We do not again claim that this is developed by us. You should ask us before you use it. In fact, you can develop this tool using a simple Excel sheet. There is no propriety involved here. So this is the framework which even if you follow, you will be able to do all the calculations and arrive at the optimum gradation in the mix and optimum binder content. So what is the advantage? If you come to the closing remarks, we understand that aggregate gradation, it plays a predominant role, but what we have observed over a period of years, that it is one of the most underrated parameters and it is often ignored because people always try to use a trial and error approach. There is no science involved in selecting the gradation, especially related to the bituminous mix. Now, the trending performance-based mix design which is used worldwide, our idea is very different from what they are doing because the performance-based mix design approaches, they are also silent when they are choosing the right gradation. So here, STBBM fills the available gap in the literature. Now, mix proportioning and the right amount of binder content can be evaluated. The best part of this tool is you do not even have to go to the laboratory. You just need the gradation, input the gradation, get the blend, and do some minimum trials in the lab. So it saves time, reduces the amount of samples you need to prepare, and it gives you an optimal blend ready to prepare the mix. And we have seen in the laboratory as well as in the field that mixes produced using STBBM, it shows encouraging results, especially related to the performance characteristics. Now, what is the future? One thing which we could not incorporate till now was the shape characteristics. Our tool is still silent when it comes to shape, which is again a variable. So we are presently working on linking shape characteristics within the present framework so that tomorrow, using your flakiness and elongation index for the coarse aggregate and fine aggregate angularity for the fine aggregate, you can further optimize the mix characteristics, which will include the shape parameters in the given framework. So with this, I would like to conclude. I hope I am on time. Thank you.
Thank you, Dr. Nikhil Sabu. Now we'll call upon paper number 745, Ms. Atashi Das from GR Infra Project Limited to give a presentation.
Good morning, everyone. The paper is on case study of falling weight deflectometer and application of machine learning models, and it has been published in the IRC Indian Highways in this October. The latest issue, October issue, it has already been published. And well, we are like, as we heard our Minister Saab yesterday, that we are building like kilometers and thousands, millions of kilometers of roadways. And what it mandates that we have to collect, the FWD data from all these project corridors like every 6 months. And it's huge. I mean, it builds up the data like hugely. I mean, what to do with the data? Can we use it to use for our predicting purpose? Like what predicting model, like how our roads will behave in the future? Can we build up something with that FWD data? That is the paper about. And also, there are so many types of pavement that we are having in India, the flexible pavement, composite pavement, combination of rigid, flexible. Then under rigid and flexible also, there are so many types of pavement besides the conventional one, including geogrids, then including foam bitumen, then recycle mixes, and then perpetual pavement. And even in rigid pavement, we have short panel concrete pavement, precast pavement, two lift pavement, and rigid over flexible, flexible over rigid. And on all these types of pavements, we have to do FWD regularly. How to process the data? Can we come up with something which helps us in a predictive model? And also in terms of endeavor for sustainability, these rehabilitations are also many. I mean, so many types of pavement, we are shifting from the conventional thing day in and day out. And are the mechanism of analyzing the FWD data at par with all the pavement types? No. I mean, and these are the upgradation in pavement technologies, but we are still using IRC 115 from 2014, the use of falling weight deflectometer to do the deflection analysis on all these pavements, what the flexible pavements I'm talking about. And we need to move forward. Though work is going on updating IRC 111, but we have to go a long way in terms of analysis. So this is a little bit of futuristic paper that we tried to bring about, that understanding the sensor layout and key structural indices, can we go a step forward and introduce something that gives a predictive model which currently IRC 115 is not having. So come up with some deflection data, generate predictive deflection data, and generate E-values, the futuristic E-values, so that we can know that in the next 10 years and 15 years, if we can do something, what will be the overlay required for those pavements. As we know, falling weight deflectometer gives the deflection values at different sensor locations. Now we are introducing some terminologies. Surface curvature index, and it is derived from the surface deflections, which comes out from the D0 value. And then base damage index, BDI, which quantifies the damage in the base layer by interpreting the sensor deflection patterns. Then base curvature index, which measures the curvature in the base layer to give the overall integrity of the structural performance of the pavement of the granular layers. Middle layer index evaluates the deflection behavior of the intermediate pavement layers between base and subgrade, which the current codal provisions doesn't give us anything specifically. It's all empirical. Lower layer index indicates condition of the subbase and subgrade based on deep deflection responses detected by the sensor. So what are the limitations? As I already mentioned, it evaluates the condition of it doesn't evaluate the individual pavement layer condition. It's a 3-layer system, but our pavement has gone up to 5-layer system, 6-layer system, and many. The analysis of the present paper, I mean, this paper only talks about the flexible. We haven't studied for the rigid yet. So comprehensive understanding we have to have for the functional and structural conditions, so that because these days what is happening due to under the life cycle cost analysis, we are doing lower investment in the initial construction, and then maintenance is coming as huge. So it is like how we can plan our maintenance. Required combination of technologies like FWD and methodologies such as 3-point rating system, which I'm coming. So these are the sensor locations that we have, and as I already indicated, like D0, D300, D12, these are the items we need for the deflection basin factors for the determination of the structural condition of the individual pavement layers we can have from our current FWD data only. So Horak et al. Has given, in terms of FWD deflection basin parameters, threshold development, where we can get the values of D0, BLI, MLI, LLI, and then these are how we can designate the pavement in a sound, warning, or severe condition. So what are these BLI, MLI, and the LLI? These are simple indices. And these are the values, like BLI or the SCI, this is only D0 minus 300, MLI is D300 minus D600, and LLI is D600 minus D900. Now coming back to the classifications and the threshold parameters given by Horak et al. So we can designate our pavement accordingly, the condition with this threshold ranges. So coming up to the given by Chang et al. So this is a five classification criteria which may prove to be expensive for us. So what is simplified for us? So let us go with Horak et al., which is just 3-point rating criteria. So we are going with the 3-point rating criteria instead of the 5-point rating criteria given by Chang et al. So and these are these indices that we are taking. So now let us introduce the machine learning in pavement engineering, how we can process the FWD data so that the prediction is beyond the traditional FWD testing. What will happen? It reduces time and resource demands. We may not need to do like every 6 months FWD need not be done. We can have some predictive models. Effectively process large, complex, non-linear data sets for accurate pavement evaluation. As I said, we have so many types of pavement these days, like semi-rigid, flexible, introducing the GeoGrid, because currently the FWD data, like the KGP-backed software, is unable to handle 1 layer or 2 layer of GeoGrids, what we are introducing in our pavement these days. It enables quicker structural parameter predictions, minimizing the need for frequent physical tests, where FWD tests can sometimes prove to be very expensive. It improves the accuracy, and it is cost effective by reducing equipment use and personal requirements. So objective and scope of the paper is like conducting, we have taken a case study, FWD test is done as per the way we do, and then analyze the FWD data using different ML models and find the best suitable model to come up with a predictive model. Perform statistical analysis and determine the strength parameters and determine overlay thickness, which can be predictive. It is not necessarily for the 5 years, but which can be 10 years, 15 years. We can go long term also. The ML models which have been done, machine learning models for FWD analysis, are linear regression, exponential model, artificial neural network, then k-nearest neighbors, XGBoost. These are all details given in the paper. And I won't go through all these details, what are the intricacies. To run these, we have used Python, and we have used Gemini, ChatGPT, because those are the general handy things, because we wanted to go with handy things rather than going with anything sophisticated software or anything. And these have been run on the FWD data that's collected. To assess the ML algorithm, a training data set has to be prepared. And the training data set for the metrics evaluated were coefficient, and the metrics for the training data set, a coefficient of determination are R-square, and the mean square error. For the data processing, which are required as data cleansing, like getting the outliers, we can go for box plot or something for data cleansing. Then database consolidation, training the data set, and temporals, forming the temporal series, and then feature engineering. Say, for example, we have a data set of 1,000 data. Out of that, 70% or 700 we will use for validation. Then training data set we will form out 20%, and then we will do the cross-validation for the rest. So these are the steps which are detailed in the paper. The categorical features are the nonlinear ML regression, the algorithms, and these are, say, surface curvature index. We fed some like values to get the data cleansing done. Then base damage index, base curvature index, what it cannot have and or something. The limits have been put while doing the data cleansing part. Performance prediction models are, as I said, R-square and mean square error has been done. Tested algorithms are SVM, RF, and KNN. Those I have already mentioned here. And then the hyperparameter selections are also done, and the grid search are done. These are all part of the back-end analysis that have been done, as I said, with the programs and just Gemini and ChatGPT and Google. So for the case study, these are the locations of the sensors. It is a road 150 kilometer in MP. And then constructed 8 years ago, overlay done after the 5th year. FWD has been done, and the sections encountered are good, fair, and poor condition. And these are the way the data, as I said, that we went for the 3-point rating. As we see the maximum deflection for D0, we are seeing that only 6% is coming under reconstruction, 31% is having overlay. And for the individual layers, we find that only 1% is going for reconstruction for base layer. Sub-base layer, again, reconstruction is 24%, and subgrade, it is 9%. So these are the one that we get only from the 3-point rating. We are getting an initial outcome from that. And then we do the predictive models. And under the predictive models, we do the analysis with the actual versus predicted. And then the perfect prediction also, which as we see is the straight line. And these are how our data lies of the actual versus predicted data from all the parameters like SCI, then the BDI, and for each of the models, KNN model, SVR model, and all that. And doing the R-square and mean square error, what we find that KNN model having the least R-square, it is having the 0.64 R-square value, the maximum value, and the least MSE value. And to plot, we have plotted all these MSE in R-square in a radar plot to get the visual comparative performance of the different models. Then in current case, as we see, R-square 0.64, we may say that it is not close to 1, but again, the data that we studies is only like 850 values. If we had plotted like 5,000 values or something, it would have tended towards 1. So as 847 numbers, it's studied. FWD is conducted once here, like as I mentioned, during the DLP period. So time series of FWD data may be conducted and future prediction of FWD analysis can be carried out to trigger the overlay when we get the overlay. Heat map and confusion matrix have been done with the predicted values and the actual values. As we see the color shift of the orange and red, I mean, that is the best correlation we get from the predicted values and the actual values. As we shift towards the blue value, there we get the least correlation. So it gives a visual idea that how our predicted values and actual values are behaving. And so D0 to D01 to D04 are having the best correlation, and towards the D6 and D7, the correlations are reducing. And we get a confusion matrix also, which is similar to like the OD matrix and all. Same thing, we are getting the things done for BCI. Here we have done the individual sensor locations heat map, and the confusion matrix is done for the parameters of the BCI, SCI, BDI, our parameters of interest of D0 minus D300, D300 minus D600. Analysis and strength prediction. Based on the D01 characteristic deflection, we are getting the mean deflection from the homogeneous section. For each homogeneous section, we get a value. And then this value has to be, because what we are doing these days, I mean, we can have as per Ostrodes, it is given that we should aim for the 85 percentile deflections of all sensors for the analysis, instead of the 15% E value that is given, evaluation given for the in IRC 115. But we should give the percentile selection for the deflection values instead of the E value. So how to determine? It is E value is determined based on the 85 percentile deflection value, and it is giving the surface deflection of the sensor location. So we feed in that data using in the IIT PAY for a single wheel load, and from there we try to do the deflection bowl matching. The deflection bowl matching, and then we come up with the E value, and using the E value, which gives the sum of R-square values, least value, we go back and select the deflection value. It is back and forth method for iterative method that can be done easily. Deflections at centers at D01 to D04 or D07 has been found to match exactly with the FWD field deflections when we do this concept of deflection matching. And then clustering, we have introduced clustering also, how the unsupervised learning method is assigning observations into different groups or clusters, that whatever predictive values are done, can we cluster them into something. Goal is to attribute multidimensional observations to different clusters such that the points with the cluster are similar or differ from points in the different clusters. And For the clustering method, some of the common distance the measures are the Euclidean distance, Manhattan distance, and Hamming distance. Some of these have been introduced, but these programs have not been done by us. Software engineers have helped us. So I won't be able to give much details about this because the Python running and all has been done by the software engineers. In current case, D01 values measured for very poor to excellent road conditions. It has been found a wide variation. Hence, D01 values divided in 5 clusters, similar to the 1 to 5 rating system. As I said, 2 rating systems are there, 3-point rating system or 5-point rating system. We have to select what is suitable for us. So these are some of the cluster plots for SC, the I and D01, and we have done the box plots also to see the outliers also, and some methods that are used for comparison are the elbow method for optimal K for SCI and all. Various methods under the machine learning process, deep learning method have been used to come up with the data, but these are all back-end analyses done instead of going to the field every time. The correlation factors are found, mean and coefficient of variation for SCI and mean and coefficient variation for D01 have been found, which is found less than 0.25, and it's very satisfactory for the 5 clusters that we have divided our data into. The elbow method is, as I said, it's a K means clustering. Optimal number of clustering comes from this method. And because we need to know how many clusters also we should come out of it. And it is a valuable tool for determining the optimal number of clusters and in terms of K-means clustering, and gives a good balance. And then coming to the actual versus, the actual corrected E versus predicted E value, we form a regression equation and compare these, that whatever we have predicted through the machine learning and deep learning processes, how is it? The R-square value that came up is 0.987, and the same methodology has been used for 10 projects, and the values are very close. Now coming how we can evaluate this to determine our overlay and all. So the correlation, the FWD tests, practical use FWD tests are conducted. We get the values. Correlation matrix, heat map, confusion matrix is prepared. Subsequently, regression equations are formed. These are the regression equations coming. R-square value is found between 0.9 and 0.99 using this methodology, and which is very good. So D01 increasing with decreasing value of BDI, BCI, and SCI. So increasing D01 implies the deterioration of the pavement. As we know, the surface deflection, the increases means it needs overlay thickness or reconstruction. So these, again, if we go with the OS roads, it is saying that now we need to know what is the futuristic E. Because we are talking about futuristic. Say after without doing any studies, like after 5 years or 10 years, of how much our E will be, that we can determine, that we can be determined also. E value is, it reduces suitably with time, though it reduces to half in about 10 years due to pavement distresses like rut, crack, gravel, as given in the ORIDE guideline of 201. And from there, we have the equation given is E1 into M log x plus C. We can have the M and C parameters when we run E1 in the lab from the different, we can develop this curve ourselves by running in the laboratory tests. Now for different cycles, we compare the E value and then run the regression equation to get the MC parameters, and then we can be predictive. We can predict our E value, where will it be in the future. So the conclusions from the study are that we analyze the data, then train the data, and get the surface curvature index, base damage index, and base curvature index to get the individual values of the individual layer analysis to get the E values using different machine learning techniques, find the suitable model, and then because we found that the KNN model is the best model, and in terms of the radar plot with the R-square value, other models give relatively lower performance. Cross-validation was employed also, that whatever we have done using the other techniques that I've already mentioned, clustering and all. So cross-validation is needed, whatever we are adopting is suited for our predictive analysis or not. So the regression equations are developed to predict the E value also, the futuristic E value. So the method is proposed here to determine the E value of asphalt mix. which may be useful to determine the choosing the e-value for stage analysis, as I said, in the next overlay e-value, whether it will be in the next 5 years. Then integration of artificial intelligence and machine learning with the falling wedge deflectometer technology. So it will help us, if we have 5-6 years of historical data, it represents a transformative advancement over the conventional methods outlined in IRC 115. And this current guideline provides this methodology provides a robust framework for structural evaluation. So we are pretty confident the methodology, the step-by-step analysis should be there. I know it's missing in this current presentation, but we are coming out with more papers, more technical papers, where each of these step-by-step calculations will be implemented, what has been presented in this paper.
Thank you, Ms. Atasidas. Now we'll invite floor intervention, and it is being given 5 minutes. If somebody can give a microphone to the floor people.
I request the persons raising their hands to come forward so that the mic can be transferred easily.
And our request is we have to brief because we have started late and
The
we
seats
have
are vacant in the
already
front
exceeded
seat.
our time.
Please come over.
Okay.
Hello. My question is to the first presenter on stone matrix asphalt. Whether any test reach has been executed, just I wanted to know in Jammu and Kashmir.
Can
And
you
also-
speak a little closer?
Just I wanted to know, you have explained about the benefit of using SMA for low volume roads also. Just I wanted to know whether any test reach has been executed in Jammu and Kashmir. If yes, and
Hello. So, there is not field required, but later on, within 2 or 3 months, field wise is also applied. The only testing.
sir,
Laboratory testing.
just
Laboratory testing.
The problem is
Field testing has not been done. It is a laboratory testing. That is a
Only
big
laboratory.
just one more question.
Yes, sir, yes, sir.
Since SMA involves mixed design and also proper use of the cellulose fibers
Yes, sir, yes,
in the mixes, you are supposed to be very careful in the execution of. Therefore, whether the contractors involved in the execution of low volume roads are exposed to mixed design and also use of fibers in the mixes and all. Otherwise, it may lead to segregation and all that. That's the my doubt.
Core 5.
Thank you. Somebody else raising hand?
Sir, if I can add to gentleman's query. Mr.
Good morning. I am Hitesh Sardesai, Shrikande Consultant, Mumbai. I would like to ask Mr. Shah on DPR point. Yesterday also, Minister Saab pointed out about the Can I ask? Yeah.
Yes, please.
Yesterday also Minister Saab pointed out the COS, DPR deficiencies, all these things. What is your point of view if you allot the more time to the EPC contractor, since the EPC contractor he is responsible for engineering, procurement and execution part. So if you allow more time to the contractor, can this problem can be solved as the COS and all these things? That is my question. Thank you.
Sir, this contract, EPC and HAM, as we know that it has come from FIDIC. And in this FIDIC, the risks are allotted amongst different parties. A risk is allocated amongst different parties. Now, say for example, I say two parties. One is the authority, another is the execution agency. Now, for your case, if it is EPC contract, now the question is, if we allow so much of flexibility with the EPC contractor, what is going to happen? Now, say for example, we do not do that. I go do it on the other way around. Where are we going back? Are we going back to the DPR procurement model, where we do everything, prepare the drawing and give it for execution? Here the objective was to get the complete expertise of both the parties. Like for there can be two reasons why we do not want to give so much of flexibility to the agency. One might be we do not have trust about their technical credibility. The second one might be, I would say, that procedural inertia, because earlier the authority used to check and the other party used to follow. Here it is not the case. There are certain things where authority is the authority. There are certain cases where the execution agency is the authority. Like for design, the complete flexibility if you do not give, then the basic objective of this type of model, like getting innovation, introducing innovation, reducing costs, these things may not come, sir. What we can do is, whatever you have said, to ensure that we define the performance parameter. Say for example, if it is a pavement, like 2-3 pavements related presentations were here, we define what should be the performance parameter. If it does not perform that way, in any case, he is going to be responsible. So this way, probably we can take care of this situation.
Okay, thank you. I think it's...
Hello? If you allow the contractor to design and the authority to finalize the design consultant and all these things, those are going to be appointed by the contracting agency, and the same can be proof checked properly, not proof check as a I or A. It is to be proof checked by the other consultant who has the capability of doing all such things. So then the COS and all these things can be avoided. That is my point. If it is okay.
No, the only way the COS can be avoided is by following two methods. Number one, the authority prepares the DPR feasibility report correctly. Secondly, they define the scope clearly so that there is no ambiguity. And third, the scope is based on accurate investigation data. If these three things are done, chance of COS will be genuine only. Say for example, you did not include any specific things in the scope, you have understood it later, maybe by local representation or something like that. The COS will be coming for that purpose only. Now, how we are getting COS? Because feasibility report is not that correct. Feasibility report is not that correct. Information based on which feasibility report is prepared, that is investigation data, it has got faults in it. And the third thing is that the scope, that is schedule B and C, is not properly defined. Now, if these three things are done, which is the basic requirement from the authority in this type of contract, then my understanding and understanding of FIDIC
I think we should be fast. Other people may like to...
Thank you.
Because one-to-one is not allowed. Okay? Thank you.
Queries may be focused on other papers also.
So my question is Mr. Tarun Gupta regarding using SMA layer for optimizing the cost in low volume road.
Yes, sir.
Yeah, actually I just want to know, because SMA by itself is having around 20-25% extra bitumen, and for low volume road, you showed the cost comparison also, but I really find it difficult. Having some thickness less and how it is more economical compared to that. That is one part. Second aspect, with PMGSY work, even for national highway work, which is high value, high volume, high quantity, large contractors are there. They struggle to get the good quality for SMA work. So we have a lot of failure in NH also. For SMA, which are very low value, smaller contractor comparatively, it will be really challenge for anybody to get the quality. So this is my view. Maybe you can explain.
Sir, for PMJS road, firstly thickness that is a 70 mm. For BM plus OGPC, it should be reduced by 40 mm. The thickness should be reduced. And aggregate, the testing that we in the Jammu, the aggregate will be available locally available. For available that 19 mm to 4.75 is easily available for that. We have to take the rate analysis.
Finally, like you said, for BC with VG40 is 8,000.
VG40, there will be two criteria. That is the bitumen film thickness for the SML is more than the BC layer. And IRC also recommended when the traffic category 20-30 ms, we have to use SMA. So that is SMA should be used in the BC also used. लेकिन वही बात आ गई कि bitumen film thickness की बात आ गई कि और फिलर टू बाइडर कंटेंट की भी बात आ गई कि BC में काम है तो इस BC में जो है ये सेटिस्फाई कर रहा है सर एज पर IRC 135 2022 में सर.
Fine, thank you. And I want to congratulate Dr. Nikhil Sabu for very practical solution to grading of bitumen, which is for the practicing engineers a big challenge. So I have no question, just I want to say thank you. And also Miss Atashi Das, she did a practical problem for all the practicing engineers. That's going to be, maybe it is just learning, maybe we can utilize further to make it better and better. Thank you, thanks.
One more interaction from the floor will be taken.
My question is to the madam. Actually, are you able to hear me, madam? Yes.
Yeah. Carry on. It's coming.
Madam, actually for the predictive model for the payment structure, under data cleansing, you mentioned parameter value errors. What parameters are considered and how these errors are, how these errors are worked out?
You are talking about the parameters that have been used?
Yes. And how these errors have been worked out, how these have been quantified.
Yes, that's what I said. No, we are coming up with an example, and so that it will be much easier to understand how it has starting from deflection data analysis to overlay computation, how we did it. It will be an extended example, because some of the models are run. You have to run Python and all. So without running those, the predictive models won't come out.
No, what parameters are considered exactly?
The parameters are the deflection values, no? The D0, SCI, BLI that I said, D0 minus D300, D300 minus D600. It's the deflection values only, nothing else. Only working with the deflection values coming out of the individual sensors.
Thank you, ma'am.
I may consider this as the last question because you got another session lined up. Though we started late, my speakers did cover up in good time. And I would like to thank my chairman, sir, Shri Zoram Liana, sir, engineer in charge from Mizoram. I am PJ Mishra from Gujarat government. And like we too have become rain surplus this year in Gujarat, but that has taken a heavy toll on our roads. And I would like to congratulate the presenters. There were three presentation which were more iterative based, and one was a practical example which Dr. Saha had talked about the implication of the EPC and the HAM projects. So it was very informative, very vigorous, and I would like to hand the mic to my chairperson, sir.
Thank you to all the presenters. I will not mention their names because we have been mentioning. And it was quite an interesting presentations like IIT R and BBM innovative tools produce durable bituminous mixture. Bituminous mix has been very complicated, time dependent, temperature dependent, and environmental dependent. So all these things, weather also, and the same thing, this stone matrix asphalt, they are more or less similar in a way. And I can see that they are going on a coarser and better coating of bituminous surface. I have been experienced and I have been working on this bituminous concrete for quite a long time. I have developed bituminous arithmetical method of bituminous mix design, computer program as well for my own use. So I found these two papers very interesting because when you use a coarser aggregate, bituminous coating is better. And bituminous contents depend on your water absorption because if it is a coal mix, there's a little absorption by the aggregate. If it is a hot mix, being bituminous thinner, aggregate absorbs, so it requires more bitumen. So in this case, they are working on a coarser aggregate, and which reduces the surface area of the mix. So bituminous is more economically or efficiently used to coat. And for low volume traffic, in fact, damage of road occurs due to rain, due to temperature, due to oxidation. So all these things are avoided and it lasts longer, in fact. That, with my experience on road for more than 30 years, I've seen this. And this, for the authority engineer, I think if you are there in the inaugural function, our chief guest, Honorable MORTH Minister, has given one mathematical example of a square plus b square is equal to a plus b square. But if you take the whole thing square, you get 2ab, a square plus b square plus 2ab. So working together with the contractor is beneficial for the government, for the public. So from the employer side, if you are a government employee or if you are a corporate, you will feel that the paper might be a little one side, blaming the authority or the authority engineer. But being, I have been an authority engineer, I have been authority, so we are trying to rely on our design because we have been preparing DPR, which we feel is the best. But being an engineer, authority or authority engineer, we have to be a little flexible, as well as the consultant also, they have to be a little flexible and we have to have a consensus. That's my comment on the EPC contract and HAM contract. And I have seen lots of dispute arises between contractor and employer is mainly a small misunderstanding, which has created lots of money for arbitration. I have faced so many arbitration, and I have been winning 4 or 5 arbitrations. If employer attends properly and record properly, the contractor always want to claim, and we always to prevent our side. But we have been making lots of understanding before we go longer. Because one of our arbitration case started in 2005 and still it's going on till today. So this is a very expensive. Who is benefited? Our arbitration lawyers. So all these things can be avoided through understanding. That's my feeling. And there's a lot to talk about on that. And as for the falling case study on falling weight deflectometer, we recently have done about 100 kilometer FWD with CRRI. And we have done our airport pavement with CRRI. We engaged the CRRI people. I have seen this FWD has been a useful tool. And the work of Ms. Atashida's GR Infra project is appreciable, and it's a very interesting present. And with that, I will conclude our concluding remark from the chair and co-chairman, and I would like to thank all the presenters and co-chairman, Mr. Mishra. We have been knowing each other, and today, luckily, we sit together on this stage. This is a very fortunate for us, and we also thanks to the IRC officials for giving us this chance. And thank you to all of you.
Sure. Thank you so much, sir. Requesting everyone to please stay back with us for a few more minutes. Now I request Chair of the Station, Shri H. Juramyanan ji, to give a moment to Dr. Nikhil Sabu, Shri Dheeraj Mehta, Shri Avnish Sharma, Shri Ranjit Kumar from IIT Roorkee, requesting Dr. Nikhil Sabu to please step forward. Next, would like to request for receiving the memento Shri Tarun Gupta, Assistant Engineer, PMG SY, Jammu and Kashmir. Now I request co-chair of the session, Sri Patanjali Mishraji, to give memento to Dr. Dulal Chandra Shah, Managing Director, Infrastructure Design Consultant Private Limited, and Dr. Sanjeevani D. Nigadesha, Executive Engineer, PWD Maharashtra. Well, requesting Ms. Atashi Das, AVP GR Infra Project Limited, to kindly step forward and receiving the memento. And now, last but not the least, most important, would like to request Sri Narendra Kumar Ghadaichi, Superintending Engineer, Work Department, Government of Orissa, to please come on the dais and felicitate the chairman of the station and the co-chairman of the station. Thank you so much, Sri H. Joramialanji. Thank you so much for all the words, for all the time. We are very glad, sir. Thank you so much, the co-chair of the session, Sri Patanjali Mishraji, for your valuable time. Thank you so much, Narendra Kumar Ghadai, sir. And here we are ending the technical session 6. Thank you so much, ladies and gentlemen. Thank you. And it's an announcement. We'll shortly start the next technical session within 30 minutes. So it's time for a 30 minutes of tea break. So requesting everyone, please. Requesting everyone to please come back here within 30 minutes. Thank you so much.
ସେଇଥିପାଇଁ ଏତିକି ହାଇଟ୍ର ଥିଲା ତାକୁ କାଟି ଦେଇଛି ଆଉ ତଳୁ ଏତିକି ହାଇଟ୍ ଥିଲା ତାକୁ ବି କାଟି ଦେଇଛି ଯଦି ପଚାର ସେଇଟା ନହେଲେ ମୁଁ ପୁରା କାଢ଼ି ଦେଇଛି ତଳୁ ଦେଖିଲେ ଦେଖାଯାଉଛି
कोई बात नहीं, अभी सारे जो फोनर्स आएंगे सब लंबे लंबे हैं। एक कुछ छोड़ के
जो
बस
पद्मा सर बोल रहे हैं उसको पूरा निकाल
हटाई दो बाद ओके
सब बोल बस ऊपर से ठीक है सुनो ठीक अच्छे कौन कौच काढ़ी ना थी
Sure. Namaskar, everyone. Welcome to the technical session 8, presentation by international organization and multilateral agencies. So requesting everyone before we begin, kindly sit down, kindly settle down. It's a kind request to everybody. And now let me take the honor and welcome and introduce the chairman of the session, Shri Jitendra Prasad, ADGBR, Eastern Sector BRO. Let's give a big hand and let's welcome Shri Jitendra Prasad, sir, on the dais. Namaskar and welcome, sir. And now, let me welcome the co-chair of the session to the dais, Shri Ravindra Kumar, Chief Scientist, CRRI. Let's give a big hand and let's welcome our respected co-chair to the dais. Namaskar and welcome, sir. And to welcome our respected chair of the session and co-chair of the session, would like to welcome on stage Srimati Mamta Padhi Madam, Senior Engineer, Works Department, Odisha. She's going to welcome our co-chair and chairperson with the flower bouquet. Thank you so much, Mamta Padhi Madam. Thank you. And now, would like to welcome to the dais to all our respected presenters over there. So first of all, let me welcome Miss Cecilia Fabian Cadeja, Transport Specialist and currently serving on the IRC H7 committee. Let's welcome her to the dais with a big round of applause. And also requesting Srimati Mamta Padhi Madam is going to welcome Miss Cecilia with the flower bouquet. Can we have our next presenter, Mr. Junmo Seong, KEC long-term expert to NHAI, Korea Express Corporation, KEC. Let's give a big hand and let's welcome sir to the dais. Welcome, sir. Also requesting Mamta Padhi Madam is going to give a bouquet and welcome Mr. Junmo Seong. Next presenter, I would like to welcome Mr. Michiya Kitayama, Director Representative in India, Enexo India Private Limited. Let's give a big hand and let's welcome him. Namaskar and welcome, sir. Our next presenter, would like to welcome him, Mr. Richard Wex, National Technical Leader, Infrastructure Measurement, NTRO. Namaskar and welcome, sir. And also requesting Srimati Mamta Padhi Madam to give bouquet and let's do a beautiful swagat. Our next presenter I would like to call on the dais Dr. John Lauren from Canada. Let's give a big hand and let's welcome him. Would like to welcome Mr. John Laurent. All right, now I request our chairman of the session, Sri Jitendra Prasad sir, to start the session with his open mic remix.
Hello. Very good afternoon. Namaskar and Jai Jagannath to all of you. This session is going to be quite interesting because we are going to have quite a good international exposure. So audience should have themselves keep occupied in this session, I hope. And of course, the major challenge would be for the speakers to, keep the audience awake because we are needing to, to the lunch session. So that is also one of the big challenge the speakers would have. Well, despite all this, we have the time constraints. So 12 to 30 minutes would be max. The time would be for the speakers. Of course, it is quite injustice to them because keeping in mind the content and material of the paper, but still we have to bear with the time constraints. So that is one thing, and we'll keep the question answers in the last. And so without wasting time, let me give the first exposure to the topic, that is World Bank's engagement in India, road safety initiatives and success stories by Ms. Cecilia Fabian Careja, transport specialist and currently serving on the ILC S7 committee. So before we could start, I would request my co-chair to give a brief account of her bio so that we come to know about her.
Thank you, sir. It's a privilege to speak short CV of Dr. Cecilia Fabian. She is the transport specialist at World Bank and serves as the road safety focal point for India and a member of Road Safety Design S7 Committee of Indian Road Congress. Originally from the Tanzania, she holds PhD in transportation engineering from Florida International University. Her research focus on traffic operations, safety analysis, innovation operations to improve the transportation system with several publications. Cecilia has extensive global experience, having worked on the transportation project across Africa, USA, Europe, South Asia, and her work include capacity building, designing. So let's give her the big applause. So I request Cecilia to present her paper on road safety initiative and success story.
Good afternoon, everyone. I'm honored to be here and I represent the World Bank. I'm going to present some of the World Bank engagements in India in road safety initiatives and some of the success stories that we've had so far. The World Bank, through our IBRD and IDA arms, has played a significant role in advancing road safety in India. And some of the work that we do are collaborative efforts between government agencies and private sector, and we've worked with a number of people, including our co-chair today. We've worked with him in several projects at the World Bank. So since 2001, the World Bank has been actively engaged in road safety in India, and we've supported development with upwards of 250 million on road safety in a big portfolio of upwards of 1 billion investments in India. And the engagements have evolved from pure infrastructure to more holistic road safety initiatives, including campaigns, capacity building, and emphasizing on network level safety, and also prioritizing construction safety as well, because a lot of our projects involve construction of infrastructure in the country. So at a national level, we have, I think, yeah. So I'm displaying a number of projects that are either in a pipeline or ongoing or recently completed projects. We've covered a wide range of states. I'm very much involved in the northeast part of Assam and Meghalaya. We have 2 projects in the pipeline, and also we have 2 projects that are under implementation right now in the region. And all our projects have a component of road safety. So we have either an infrastructure improvement component, capacity building or management, or strengthening the institutional capacity of the clients in these different states. So at a national level, we also have the Green National Highway Project, which is almost ending now, and it has a lot of components in road safety auditing, and also speed management. So a big portion of our effort in road safety are first covered under projects, and second under technical advisory through different mediums. Just to summarize, at the country level, we've been involved in advocating towards the National Road Safety Policy and Vision. We are also looking at the road safety action plans for nationwide. At state level, we improved the overall policy institution and monitoring the financial framework and integrating road safety standards in our projects. So from the project inception design, from during the construction period and after construction, to involve all aspects of road safety, and also multi-sectoral road safety demonstration. For example, corridor approach, we have had projects, for example, in Rajasthan, we recently developed a road safety action plan, which is now being implemented, and we are looking at other states. For example, in Assam, we have a road safety action plan, and it's going to be implemented. In other states like Meghalaya, also they are developing a road safety action plan, and so these are some of the things that will be implemented for it, not just the road action plan for documentation, but also to follow up through implementation and improve road safety in these states. But we also collaborate with other partners. For example, the Bloomberg Initiative, we've done some city-level projects. For example, in Mumbai, we improved about 200 kilometers of roads. In Chennai, and we also provide technical and support capacity building at city levels. So just to summarize on what areas of engagement that the World Bank is involved at a national level, at a very high level in policy. So you look at governance schemes, policies, management capacity, and also capacity building at management level. Our global unit provides training for road safety management at high levels of government, for example, with the national, the MOTH, and other private sectors. Also at legislation, for example, the Motor Vehicle Act that was enacted. Also vision and accountability for the legislation also support. And institutional capacity has been an integral part of our engagement. For example, we've done at different level, national level, state level, and city level to improve the institutional capacity on different areas of road safety. Another area is codes, guideline, and research. So funding for research work, research audit, road safety audit and accreditation, and I see that the IRC has provided a curriculum for 15 days of training for these auditors, which will be offered by different institutions. And we've been engaged in supporting those auditors in our projects to have accredited auditors who are going to work in the projects and also post-projects in the country. Also in updating the enforcement and codes. Currently we have one, we are updating the IRC SP 41, and that is, I believe it's with the committee in revision, and that will be adopted for intersection safety, but we also collaborate with research institution and academia. We've worked with IIT, Delhi, Guwahati, and other institutions to deliver either capacity building or to improve guidelines, research work, and we work also with CRI to develop different guidelines in climate, resilience, road safety, and improvement of capacity building for different institutions. In operations, which is mainly where most of our fundings go, we work with, during construction phase, to ensure that our projects are built according to the standards. So for example, work zone following the IRCSP 55, and also to have the contractors be responsible for following the codes. Enhancement of contractual conditions, for example, what are the penalties if the contractors fail to implement certain measures in our operations, and also to implement work zone safety or labor safety in the projects. Another area where we we are exploring and we are going to focus more is the private sector engagement. So working with concessionaires who are on our highway projects, or private sectors who are monitoring and operating our roadways, and to just impose different KPIs that will improve safety and resilience of the roadways. So this is the guideline for design of at-grade intersections in rural and urban areas, IRCSP 41, which is under revision, and it was supported by the World Bank. But we've done a number of capacity building initiatives. For example, last year in Assam, we delivered training to more than 1,000 government and police officers who were trained on post-crash care. We were trained on investigation of crashes and also in work zone safety. And this has been done in Assam, but in also other states under the Green National Highway Project. OHS trainings have been consistently done throughout our projects, and we are continuing to do that throughout our project durations, and to enhance the capacity of the institutions and the implementing units, even once the World Bank has left or other projects like IDB projects come, they can easily manage the OHS of the projects. So I have limited time, and I will just wrap up there. I'm happy to take any questions. Thank you.
Thank you, Cecilia, firstly, because you finished well in time. So thank you for that, additional point for that. And now the next topic is, it is also a very important topic in today's time, especially for the country like India. The Korean experience of value engineering in road projects by Mr. Jo Seong. He is a KAC long-term expert to NHI, and also is part of Korea Expressway Corporation. So now I'll request my co-chair, Dr. Ravindra Kumar, to give a brief.
Thank you, sir. It's my pleasure to introduce Mr. Jomo Seong. He's a highway and transport expert, currently serving at National Highway Authority of India in New Delhi, under official collaboration between NHI and Korean Expressway Corporation, KEC. As a long-term expert, he facilitates joint initiatives that strengthen cooperation and knowledge sharing between two government agencies in road transport sector. With over 20 years of professional experience, Mr. Seong has been extensively involved in numerous overseas infrastructure projects encompassing project development, design, construction, supervision, and project management across various developing countries. In particular, he has been experienced in official development assistance project, supports ongoing effort to explore avenue for Korean technical assistance to Government of India in highway value engineering. He holds MSc in Transport Planning and Engineering from University of Leeds, UK, and BSc in Civil and Environmental Engineering from Korea. So let's give him the big applause for Mr. Jomo Seong.
respected sirs and madams. Namaste. Namaste. I'm deeply honored to be here at the 81st annual session of IRC in Bhubaneswar in Odisha. What I'm going to talk about today is about value engineering of road projects in South Korea. Due to time constraint, I'd like to present mainly about the overall process of value engineering rather than the deep diving into individual cases. Okay, let me get started. These are my contents of presentation. Before we touch today's topic, let me briefly introduce Korea Expressway Corporation. KC is a sole national government agency of expressways in South Korea and has the history of more than half century. You can see KC is quite similar to NHAI in India in terms of roles and responsibilities under the ministry. South Korea has about 5,000 kilometer expressway network across the country, and out of that, the KC is covering 4,300 kilometers expressway network except PPP-based expressways. Every year, total revenue of more than 27,000 crore rupees is collected from the entire expressway network of KC. Following the Honorable Prime Minister's state visit to Korea in 2019, KC made a memorandum of cooperation with NHAI for the purpose of sharing knowledge and experiences in the field of road transport and highways. Thereby, I could stand here today. Okay, let me get into the value engineering. Value engineering is a systematic approach to literally improve the value of goods, services, or projects by enhancing their functionality as well as minimizing the life cycle costs. It can be carried out throughout the whole life of expressway projects from planning to maintenance stage. The value is the ratio of function to cost. There are 4 types of value increases cases, as shown in the screen. However, the last one, the function emphasis case, is hardly acceptable from an employer's perspective. This is because as an employer, it's quite difficult to accept the cost increase in the project. As you can see from the graph on the right-hand side, the impact of value engineering is the greatest at the early stage of design. This is because a variety of design alternatives can be drawn at the beginning of the design stage, but as time goes on, there will be very limited options to choose at the end of design. In order to minimize the waste and inefficiency in the government-funded project, Korea Ministry of Land, Infrastructure and Transport added some value engineering provisions to Presidential Decree of the Construction Technology Promotion Act in 2000. On this legal basis, the ministry made guidelines for economic design as well as standard manual for value engineering for all its implementation agencies like KC. KC accordingly, they added the design value engineering provisions to its internal regulations for construction management and established work standards for value engineering in 2002. Subsequently, published a handbook for engineers to thoroughly follow the statutory duties given by the ministry. let's take a look at which kind of projects are supposed to go through the value engineering process. According to the presidential decree, KC has specified the projects that are subject to value engineering. In principle, all expressway projects with the total construction cost of not less than 63 crore rupees are mandatorily subject to value engineering. In certain special cases, such as additions or significant changes of critical elements or structure like tunnels and bridges beyond a certain level of grades, ongoing project also be subject to value engineering. In the event of design change resulting in a cost increase of 10% or more, the project may be selected for value engineering as per the decision by the concerned division. I have brought this opportunity curve from the guidelines for value engineering by FHWA in America. We can see value engineering should be performed as early as possible so that accepted value engineering recommendation can be implemented without delaying the progress of the project. By proper timing and planning, the value engineering facilitator can ensure the value engineering studies can be accomplished without conflicting with the project schedule. In fact, the earlier value engineering applied, the greater the potential for savings. We can say it like that. Now let us see when value engineering is performed in a project in Korea. The flow chart on the left-hand side shows each stage of the expressway project in Korea. Zooming in the design stage, there are 8 number of milestones. The first value engineering study is conducted just before the road alignment and interchange type are decided. The second value engineering study is carried out to determine the types and locations of bridges. The last value engineering study in the design stage is performed just after the preparation of deliverables to verify the entire design works. KC does 3 times of value engineering studies just during the design stage so that the impact of value engineering is maximized in a project. During the construction stage, we do encourage the contractors to propose as many proposals as possible in the form of VECP, Value Engineering Change Proposal, by allowing them to get incentives of 70% of the savings from value engineering. This slide shows the various steps of conducting a value engineering study that applies to expressway projects. The value engineering process is divided into 3 phases: pre-study, V-study, and post-study. In pre-study phase, it is pretty important for the selection of a potential study project to improve the public investment by quality enhancement of life cycle cost savings. In order to utilize the agency resources effectively, the care should be taken to the select project that would benefit the most from value engineering.
Another 2 minutes.
Technical difficulties and complicated functional requirements and external stakeholders challenges all tend to lead to projects with opportunities for the improved value. In this context, KC employs cost model to find the most critical, costly parts that will bring the maximum effect of value engineering. Yeah. Okay. The second phase, the V study, is generally called the V job plan, wherein there are 6 steps. In information step, quality models are established to find out requirements of employer as well as stakeholders and to set out critical criteria for evaluation. In this step, analytic hierarchy process, AHP, is adopted to obtain the weights of performance items, which will later be used in the performance evaluation. This is a matrix of AHP, which is multi-criteria decision-making method. AHP uses pairwise comparisons to evaluate how important different criteria relate relative to each other and how well the alternatives meet those criteria. By doing this, we can obtain weights to be used in the performance evaluation step. Okay. In function analysis step, the V team identifies the elements with the greatest potential for improvement in function by 4-step activities. In idea generation and evaluation step, V team applies creative techniques such as brainstorming and Delphi to come up with alternative ideas. These techniques will generate a large list of potential solutions, and they are briefly evaluated from 3 perspectives such as possibility of realization and functional improvement and economic feasibility. Once the best alternatives are selected, they are fully developed through sketches, cost estimates, validation of test data, and other technical work to determine if any assumptions made during the study are valid.
Mr. Jomo, only 1 minute. Huh?
Okay, yeah. After development step, a performance evaluation is carried out to figure out how much the alternative will increase the project value. Okay, let me skip it. Yeah. Okay. KC has a dedicated value engineering division wherein there are 16 full-time internal experts in 5 key areas, plus external experts available at the request. Once a V project is assigned to the division, a V team is formed by a V leader. The number of V team members is normally 5 to 10, depending on scale and complexity of the project. Okay, KC annually hosts the construction value engineering competition to encourage contractors to propose the innovative V ideas that contribute to the cost reduction. Okay. The last slide. To share the value engineering ideas, the entire construction industry, the ministry established the online platform where everyone can access the information and data of value engineering. Okay. This is all for my presentation.
Thank you.
Thank you.
Hello. Thank you, Mr. Jimo, for giving great insight into the value engineering. In fact, your topic has added great value to this session. Thank you very much. Now the next topic is operation and maintenance of road tunnels by Mr. Michiya Kitayama, Director Representative in India, E-Nexco India Private Limited. Now I'll request my co-chair for a brief CV.
It's my pleasure to introduce Michiya Kitayama. He's having more than 18 years of extensive experience in operation and maintenance, construction management of expressway in Japan. He has worked as JICA long-term expert and short-term expert for technical cooperation project on mountainous highway between India and Japan from 2018 to 2020 and 2023 to 2025. He has worked, he is working in eNexo India Private Limited since 2095. Before that, he has worked in several project Expressway Company Limited in Tokyo. He holds the master degree in science in civil engineering from University of Washington, Seattle. Also, urban and environmental engineering from Kyoto. He is bachelor from Kyoto University. He has got the Katahira Award in REA Road Conference in Malaysia in 2013. So let's give him the big applause. Mikio.
Thank you, Chairman. My name is Kitayama. I'm working for eNexco India as a director. Today, I would like to talk about operation and maintenance of road tunnel, especially focusing on tunnel inspection and also rehabilitation against the deformation caused by landslide. So firstly, I would like to talk about my parent company of East Nippon Expressway Company, eNexco India, eNexco Japan. eNexco Japan operates about 3,900 kilometers of expressways in eastern part of Japan, including Tokyo. Our network extends from mountain to marine and rural to urban area. We conduct a variety of operational maintenance to secure safe, reliable, and comfortable expressway service 24/7. This is just an overview of my eNexco India, based in Gurgaon, and we provide technical service and engineering service to Indian companies. So let me move on to the introduction part. Japan is located in the South Pacific Ring of Fire, so about 70% of Japan is covered by mountain and forests. In the process of expressway development has started from late 1950s, and in the process of expressway development, we constructed many mountain tunnels. Blue bar chart shows a number of mountain tunnels constructed by years from late 1950s to 2020. Now we operate and manages about more than 500 mountainous expressway tunnels. This is just an example of our longest expressway tunnels called Kanes Tunnel, and the length is more than about 11 kilometers. So let me move to the first topic of tunnel inspection. This slide shows a variety of tunnel inspections conducted our company. A detailed inspection in the bottom of this slide shows is a core part of inspection. Detailed inspection we conduct by manually and by moving NSV vehicle. This is just a principle of the tunnel inspection using NSV vehicle. And from the running vehicle, we capture the image of the tunnel lining surface by high-resolution color line sensor camera. And then we capture images of tunnel concrete. From this image, we develop a crack diagram to analyze the deformation caused by several factors. This is just example of the crack diagram we prepared based by the captured image. The reason why we prepare this kind of crack diagram is to understand or analyze what is the what is the factor of the tunnel deformation? Because tunnel is covered by the mountain, so there's a limited space to inspect. Based on our experience, based on the pattern or location or thickness of the crack, there are several possible reasons or factors to cause such damages. This slide shows just an example of the deformation caused by the cavity of the cavity behind the tunnel lining. In this case, there might be critical risk which the tunnel lining collapse and may pose a severe risk to the tunnel users. This is another example. This is a case of landslide movement causing some damages to the tunnel lining. So based on Japanese experience, there are several challenging ground conditions. And next, second topic, I would like to talk about the example or case which slope failure cause severe or critical damage to the tunnel concrete lining. So this is a case of Fumiozan Tunnel in northern Japan on Yamagata Expressway. This tunnel was constructed from 1995 to 1997 and opened to the public 1999, about 25 years ago. Before the DPR stage, we conducted intensive survey and investigations. And left-hand side figure shows the plan view of the expressway. And expressway ran along the water reservoir. And across the expressway, we identified the severe landslide block identified. So based on the survey conducted, we conducted countermeasure work against the landslide block, including deep foundation pile, steel tube pile, and groundwater removal work. Even though in operation maintenance stage, later, after the opening to the public, in 2014, we identified severe displacement occurred inside the tunnel. As you can see, right-hand side and upper part of the picture, there is a severe movement of the tunnel lining. So we conducted additional survey and investigation, and also conducted monitoring, continuous monitoring throughout the years. Based on this investigation, we identified an additional landslide block behind the firstly identified landslide block. In the construction stage in late 1990s, we identified the blue dot dash lined landslide, but in late 2010, during operation and maintenance stage, we identified additional landslide block colored in red line. Based on this information, we also conducted intensive geological geotechnical survey and identify the location and situation of the landslide block. So based on this investigation, we conducted additional countermeasures, including drainage well, horizontal and also horizontal drainage boring. Now, we are monitoring the effectiveness of this countermeasure work, and after confirming these countermeasures is effective and displacement is settled, we will conduct the tunnel repair and strengthening work in the near future. This is the end of my presentation, and thank you very much for your kind attention.
Thank you, Mr. Michiya Kitayama. And this topic was very apt, especially for our country, because we're also having a number of tunnels constructed, and it requires a good, backing of operation and maintenance. So it will come very handy. So thank you very much, and also you have finished well in time. So thank you for that also. Now coming to the next topic, that is calibration and validation of network survey vehicles, best practice plus an introduction to NTRO's next generation payment data collection technology platform by Mr. Richard Wicks, who is a national technical leader, infrastructure measurement NTRO. And so I'll invite Mr. Richard, and now I'll request my co-chair for a brief on him.
Yeah, it's my pleasure to tell about the Richard Wicks. He's the principal technological leader, infrastructure management. He joined ARRB in 1990, has more than 25 years of industry experience. Richard is an internationally recognized expert in payment measurement and management of road network. He joined NTRO, formerly known as Australian Road Research Board, in 1990. Presently holds the position of discipline leaders. During his time of ARRB, Richard has had a strong focus on collections and analysis of functional and structural payment condition data for road management in Australia and New Zealand. Richard has worked closely with each other Australian road agency as well as many international transport organizations. He has been author of many technical papers. He has done his bachelor from Monash University. He has carried out many major projects, especially in Australian standards for payment data collections, implementation of IPAB, through use of 3D technology for crack, roughness, rutting, and texture measurement. Managed IRAP project in Australia, Bangladesh, Chile, Costa, Egypt, India, Malaysia, Vietnam. And of course, he has been working on the quality control of new payments. So with this, let's give him the big applause for Richard Wicks. So now invite Richard Wicks.
Thank you,
Do
Mr.
his
Prasad,
presentation.
Mr. Kumar, and fellow presenters and everyone in the audience today. It's nice to be here in Bhubaneswar in Odisha. A big highlight for me. So I had a really long title for my talk. I've broken it down a little bit. We'll talk about NSV, Network Survey Vehicle Validation, and a bit on data reform and some of the work we're doing. Just to mention, I'm here, I work for the National Transport Research Organisation, formerly the Australian Road Research Board, Melbourne, Australia, and we partner here with the Indian Road Survey and Management as well, so I'm representing them here today too. So what are we going to talk about? We haven't got a lot of time, so I'm going to move through this pretty quickly. I'm going to talk about some basic asset management. When I mean basic, it's going to be basic. We're going to talk a bit about validating these types of equipment, these network survey vehicles, how to certify them, some of the things we do in Australia that we could easily do here too in India, a bit on data reform, and then maybe just few key takeaways for you to think about and happy to discuss. So this is your typical asset management cycle. There's so many different portions to it. We're looking at this flashing one here at the collection of data. So that's the fundamental thing. You need to get the good data to be able to do all these other things, all right? So you pay good money, you engage someone to collect data for you on the condition of your road network. You want to make sure that it's good because it's, data, it's information, it's decisions, but you want to go good data, good information, good decisions. So it's just another version of the old garbage in, garbage out. If you want to get some useful information, and not lose everything and have your whole asset management cycle fall apart, well, you need to have good quality data. So how can we certify things? How can we manage the collection to make sure that the data you pay for is good? All right. So this is what we want to focus on, accuracy of measurement. Does what is measured, what you've asked to be collected, actually represent what the condition of the pavement is? All right, so it's all about accuracy. We're going to talk a bit about precision, because that has a role too, but we want to make sure that our data is an accurate reflection of the condition of our road network. So what do we do in Australia? Well, this is something that our road agencies thought, well, we're getting a lot more people using these automated data collection systems in our country. Well, how do we go about ensuring that what they collect and give us is harmonious and the same and is an accurate reflection? So from the mid-2000s, we've developed a series of test methods that have been built into contracts. And we've got this, you can see here behind me, focusing on roughness, but we have them for texture, we have them for rutting, we have them for cracking, we have them for the iPave, all these things, FWD and deflection. So I just want to focus on roughness today. So we're going to have a look at the two different types of methods. We generally validate or certify things using what we call a reference device method, which we'll talk about, and then we have something called the loop method, and they're kind of tied in together, as you'll see. So let's have a look at, firstly, how to validate things. But before we get onto that, we want to think about what do we use to validate our NSV, all right? So sorry to pick on this. I was at CRRI once, so I got this good picture of an old bump integrator there. So are we going to use this bump integrator, this technology that's pretty old, to actually validate a network survey vehicle? Probably not, right? Because it really should be the other way around. We want to have something that's more accurate as a reference to calibrate something that's less accurate for collecting data. So poor old bump integrator, you know, still got a role, but not as a validation or a certification tool. So what our test method HAZUS does is go out and find some sites, and then we use a reference device, and you see here it's the ARB Systems walking profiler that we use, and we go and select sites that have certain parameters, and you're not going to be able to read this, but it just goes to show we've got 5 sites. They need to be at least 500 metres long, and they have to represent different levels of roughness. So we get a whole range of roughness that you would expect to see on your road network, so we can make sure that when we run our NSV over it, that it's collecting data and being assessed on the type of levels or the level of roughness that you would expect on your network. Now, one thing I'll say about that, this is an expensive process. You know, for each 5 sites, probably takes a week to collect manually. You've got to shut down the road, you've got to collect the data, you've got to run your other vehicles over it. So it's very good, but expensive. And one of the biggest challenges is finding the sites that actually match what the standards tell you to do in the range of roughness or texture or rutting, whatever it is. But at the end of it, you've got your ground truth measurement measured by your reference device, this walking profiler in this case. Then we've run our vehicles over it, and look at that. We get a nice correlation. So we've got this NSV now becomes like a golden vehicle for measuring road roughness for us, for the IRI. So we can have great faith in the results from that device that it's actually measuring the right roughness conditions on the road. So once we've got this vehicle referenced, that's traceable to this standard, well, then what we can do is we can use that device to go out and collect data on other sites. And so as a national organisation, we have numerous test sites or validation loops, we call them, around the country. Here's one that we have in Brisbane, just north of the, in southeast Queensland. Now it's a loop, but it's just both sides of the road. So, you know, we go up one way, cut out the bit where we turn around and come back. So we can survey that with our golden device, and then we can run all our other equipment. Now we've got, you know, 3, 4 iPaves and numerous multi-layer NSVs and the like. So we run it and we can compare them, and we can have some sense of surety that the outputs from them are representative of the road because they agree with each other. So there's our golden vehicle there again. So just talking a bit about repeatability, of course these loops are great because you can do numerous runs. We typically do 5 or 6 runs at a time, and then we can plot them up because we want to see the variation between the runs. But, you know, things can be repeatable, and this is, if you're going to do your statistical analysis here, it's going to be R-squareds of 99 or greater. But the thing is, it can be repeatable and wrong. So we need to focus on that reproducibility too. So we need to see how a different device really relates with our golden device as well to see if it makes the grade. So this is some data from our IPAVE or a TSD. You can see here SCI 200. Again, that's repeatable. So we can use these sites, like I said, for a variety of different parameters that we're measuring. Now, this is the one I was thinking of. So reproducibility, this is 2 separate devices. This is an NSV versus an IPAVE. Just measuring roughness, average roughness on that test site. And you can see pretty much, there's a little bit of variation here and there. But again, statistically, that's pretty good. It meets all the test method specifications for us. So we can be sure that if we've got the IPAVE doing work, or we've got our NSV collecting that data, that what they're reporting is accurate and is the same, and we've got the uniformity of measurement across the state. So what that means, what we also do is we actually certify profilers in Australia, so the state road agency have us as a government body, or semi-government body, in New South Wales and Queensland to set up certification sites, and people actually come to run their profilers against the results from our golden vehicle, and then they get certified for being able to collect data elsewhere in the country. And that's a paid-for service. So it's not much. I think it's a couple of $1,000, $3,000, and you can get your vehicle certified, so you actually have a certificate to say, hey, I passed this test. The data I collect should be okay. And that's all in line with this loop method in this case. So each person who gets certified or vehicle gets a certificate, and you can see the statistical relationship there too. So that's a good way to do things. If you want to really take it next level, what you do is you go and do what the Americans have done in Illinois. They've actually got a dedicated facility for certification. So it's up there on the right side. It's a mile long with all different surfaces. They're talking about extending that by another mile, and everything's baselined, referenced very accurately using the different devices there, and then you go and run your vehicle over it, and again it's a fee for service. There's the ultra urban low-speed profiler, you're doing its paces, and you get a certificate. Okay, so I'm just going to jump track for a second. I think I'm doing okay on time. And just talk a bit about the data reform that we've been collecting data for a long, long time, from the 90s, so pretty much since I started at NGO/AOOB. So we've collected data, and it's interesting that we were looking at things a while ago, a year or two ago, at what are potential areas that we could improve the data collection process with automated vehicles. So, you know, because one was route planning, especially in urban environments. How can I kind of minimise the amount of travel I do to collect the data I need? How can I look at, if I've got all that data, you know, it's happened to us at times. Australia is a big country like India. We could have been surveying 4,000 kilometres from a main centre, and, you know, we've missed a bit of road. It's
Another
a long way
2
to drive.
minutes.
2 minutes, okay. I'm going to be good. So completeness, you can minimise, you want to minimise your quality issues because you don't want to go out and recollect. And then, of course, it's great to get the results quicker than maybe usually. You might have to wait a couple of weeks or more for them. And then you want to be able to provide additional insights. So we've been doing a bit of a trial here in India using this advanced data capture pipeline, where we have actually a route planning tool. We work with TomTom. We have a partnership with them, so we have access to their maps. In the vehicle, it actually instructs the people collecting the data where to drive, automatically uploaded either through the 5G network or using satellites, and then into a database, processed automatically, and then straight into a visualization portal as well. So Here's an example from Hyderabad where we're doing some testing. So we've selected the routes, and then 24 hours later, we're looking at the data in a visualization tool. This is just a very quick snapshot, and then the various camera shots and everything. So that data is ready straight away for you to look at. So just finalizing though, key takeaways today is, we want to, when it comes to collecting data, it's all about accuracy, and we want the precision. We don't just want precision. We need to have accurate data. We've got to think about what we use to validate things. I'm jumping here, but what about validating IPAVE? Do we use the FWD? Well, you can, but you've got to remember that the results are going to be a little bit different because they don't measure things exactly the same way. And then finally, so here, this sums it all up. So I've got a cricket bat. We all have a cricket bat. How well do we use that cricket bat? If I'm Virat Kohli or a Harmanpreet, and congratulations to the Indians women's cricket team for world champions there, imagine how they would use that bat compared to you and I. And the same thing is this man behind me is going to talk about this. Just because I've got a pair of PaveMetrics LCMS 2 sensors, does that mean I'm going to generate exactly the same results as the next person who has a system like that? So that's something to think about. Maybe, John, you can answer that question. Thank you. Yeah, and if you're interested in all this certification and the like, there is a conference in Pittsburgh next year, ARPAG. Come and talk to me about it. It'll talk about all these things. And Danjavad.
Thank you, Mr. Richard. And it was very, very interesting topic because the accuracy of data collection, especially for the payment design, is very important because sometimes we can over-design, sometimes we under-design. So it can save money both ways. If some payment is required to be, still longer, if it is okay. So if data is good, so naturally we can extend its longevity. And in some cases, if the, the payment parameters are not that good, and data is accurate, so we can optimize the design part. So it is very good in that way. Of course, we can take away from this topic and we can do further derivation on this later. Thank you very much. And now the next topic is the road inspection data. The importance of data quality and repeatability for assist management by Dr. John Lauren, Canada. This is the last topic, and it is again on the data collection. So now I'll request my co-chair, Dr. Ravindra Kumar, to highlight his CV.
Thank you.
Hello.
Richard's presentation kind of covered everything I wanted to say. So,
John, yeah, you can just, I will introduce you a little bit, and then you can detail about it. I will introduce you to the audience. Okay. Yeah. So John Laurent is the co-founder of VP Business Development and Technology, PaveMetrics. And PaveMetrics specializes in 3D vision system for automated inspection of transport infrastructures. And it has been used in more than 50 countries around the world to automatically inspect the roads, runways, railways, and tunnels. So with this, I give him a big applause of the round from the audience. And now I request Dr. John to carry over his presentation.
okay, so we don't have a lot of time, so you have my email. If you send me an email, I'll give you a copy of the presentation because there's a lot of details that I won't have time to cover. I'm very happy to be here. We sold the first system to India about 20 years ago, CRRI, an LRMS system. And I think now there's over 20 systems in operation in India for this. Okay, so what I really want to cover is, you see this curve, everybody knows it's the asset management curve. When you build a road, you design it to last, say, 20 years. And as soon as you open the road, it starts to degrade, okay? And it degrades according to this curve. And where you see the point up there, after, say, in this case, 9 years, then you want to rehabilitate the road to make it last longer. You want to avoid getting into the steep part of the curve. But that's the theory. In practice, what happens is You don't know what curve you're on because depending on the initial quality of how the road was built, the materials, the compaction, the extreme weather, the amount of traffic, the load of the trucks and so on. So the road will degrade faster or slower than what you expect. So this is why you do inspections, because you don't know which road, which curve you're following when you start. So say you do an inspection, okay? Well, the inspection will tell you which curve you're on, but if the inspection system itself has variability or inaccuracies in it, then you still have a range of possible solutions that you're not sure which ones you're going on. So this is why you would like to have the most accurate and the most repeatable system to know where you are on the degradation curve and know exactly when you need to rehabilitate your pavement to save it. So pavements are worth billions of dollars for the whole network, so it's important to have the most accurate data in order to maintain it. The solution we developed and that's used widely already in India is a LCMS system. It's two sensors that scan the road in 3D, and so you need very accurate 3D at 100 kilometers per hour. It's millimeter accuracy, sub-millimeter. But after that, you have to process all the data. So from this data, you measure rutting, cracking, roughness, potholes, and seal cracks, geometry, patches, curbs and drop-offs, bleeding, manholes, raveling. Concrete systems, we have detect the joints, the faulting, the misalignments, and so on. So all this information can come out of the system. So this information, of course, if it's repeatable and accurate, it's very useful to follow your asset degradation curves. So the first thing you need to do is, just like Richard did with the IRI data, is validate the accuracy and repeatability of each thing. So this is an example already in 2008. We manually looked at, compared to manual raters, cracking data, and they were, these were the most accurate, was about 96% accurate compared to manual. These are repeatability. So repeatability, this is the amount of cracking per 100 meters. So you see when you do multiple runs, they line up quite well. These were done by Australian road authorities. These again is other tests done for repeatability of cracking. This is on chip seal roads in Australia. So very repeatable data. This was profiler data. These were Massachusetts DOT. They compared LCMS to two other systems, and you see the accuracy and the repeatability of the data is similar. This is a manual rutting compared to over 58 different sections. The average manual rutting data compared to the automatic system. You do several, each time you do 2-3 runs, you compare to a manual, and if all the, like here, if all the lines follow the same graph, then you're repeatable and you're accurate. This was for texture. So this was the ground truth system to measure texture. And when you compare the LCMS to texture, these were done in New Zealand. You see they repeat and they compare perfectly well. The curves are like 97% correlations. Okay. These were done in the Netherlands in 2010. So where they look at raveling of porous asphalt roads. So the LCMS will detect it and you compare to manual. Here's an example where there's no raveling. You see a very low raveling number. There's a lot of raveling, a high. Another lot of raveling, high. Low, very little. High, low. And when you compare three different runs, you see the raveling curves, they follow each other very well. Now, why is it very low at the end over there? It's because they redid the asphalt there, so there was no raveling in that section. So these are all examples of each different feature of the road. You need to verify, is it repeatable and is all the defects that, that the system can detect. Now, that's, so each one is good, but what happens is, if you want to be repeatable, you have to compare runs from year to year. So the driver is never going to take the same road. He can swerve, he will not be the same distance from the lane markings. So with the LCMS, we cover wider than the lane marking. So we use the lane marking as a reference, and we always take the profile, the rutting, the texture from the same distance. So you're always, when you compare from year to year, you're comparing the same data, all right? And this is really important because, like I said, the driver can swerve and be at different distances. So this is a test done in the US where they compared profiler data, and this was the same road, except where you see the divergence is because the profiler was off just by a few centimeters, and you would get 15% differences in repeatability just by being transversely off a few centimeters. So you can look at the study, and it's one of the results. They were very surprised by how much it changes just by not being at the exact position. Another thing that you need to look at is, of course, you're not going to look at in details cracks, rutting, that's too much data. So you look at overall pavement condition indexes, right? So we looked at several pavement condition indexes to see which ones were more repeatable. Because from year to year, when you're comparing data, the GPS is always going to be off by 1 or 2 meters, right? So what is the effect of that on repeatability? So we looked at a few different ones. PSCI is a cracking index, just cracking. Then there's PASER, which has about 4 different defects. It has cracking, rutting, potholes, raveling, and patching, right? And then there's, so that gives you a number from 1 to 10 on the condition of the pavement. And then we also looked at PCI. PCI is 1 to 100, and there's 19 different distress levels. So you have 19 different distresses with 3 different severities for each distress. So we look at that one too to compare. So these are all the list of the 19. I won't go over them, but alligator cracking, bumps, joint reflection, corrugation, lane shoulders, so on. Okay, all these have to be measured. Okay, so then
2
we
minutes.
yeah, how much? 2 minutes? Okay, so we compare 3 different sections: a low IRI, a medium IRI, and a high IRI road section. So good, bye-bye. And we use the same data for each section, 3 different runs, but the runs are misaligned. Okay, and then we see what happens when you calculate the PCI, the PASER, and so on. Okay, so PSCI, this is just cracking. You see it's very repeatable, except it only measures cracking. Then PASER is it's very bad. So it measures many things, but you see the repeatability is not good and the accuracy is not good. But PCI, with 19 different distresses, you can see even when you have differences in several meters between comparing different runs, the overall measurements are very accurate and repeatable. So these are the numbers. You can look at it. So basically that's it. So what you want to do is to start off with an accurate and repeatable data for each of the distresses. And you also want to compensate for transverse position. And also it's good to use road indexes like, for example, PCI, and make sure that the road indexes are also repeatable when you're not exactly aligned from year to year, the different road sections. So thank you.
Thank you, Dr. John, for giving a great insight into the quality of data. In fact, quality of data is very important in the sense that it not only gives us quality asset management, but also it reduces the risk on the highways. So in that way, this will give a lot of insight and a lot of takeaways from your topic. And so thank you for that. And this was the last sessions. So now we'll take on the Q&A, and I'll request the audience, please be precise, and I will start with the first topic with this Cecilia. So if anyone have any question, from the first speaker, Cecilia. So you can speak on and you can ask the question from her. You can raise your hand if somebody wants to speak any question. Yes, anyone out there? So I think mostly people are satisfied. So there's no questions. So thank you very much. Now we come to the next topic, the Korean experience of value engineering in road projects. Any questions to Mr. Jumo? Is there anyone out there? Okay. So I don't think any questions, so they are satisfied. So thank you, Mr. Jumo, for your good presentation. And the third topic is operation and maintenance of road tunnels by Mr. Michiya Kitayama. Yeah, one question out there. Please tell your name.
Myself, Sangram Kesari Das. I am a consultant, design consultant. So I want to know how you manage the cracks. Like it's a safety concern, major safety concern. So how we can manage it and control it?
Based on my understanding, your question is regarding the control of the crack or something. So it's based on my experience, it's difficult to control cracks. So if there is some severe condition based on the crack, we just hammer to remove such portion of the crack. That's the first countermeasures to provide. If the crack develops so severe, we remove some portion of that location, and then we put rebar, and then totally put the concrete on such portion. Am I answering your question?
Hope this satisfies your question. Okay, thank you. Next question, please. Anyone? So thank you. Now coming to the fourth topic, calibration and validation of network survey vehicles to Mr. Richard. Any questions out there? Okay.
Good afternoon, everyone. My name is Amit Munjal. I'm from NHAI. My question to Mr. Richard is, you have talked about validation of IRI, different methods used in Australia. We have also done something similar in India. The IRI in India is matching with different machines, but the real challenge comes in other distresses like cracking, raveling, and some in rutting. So similar to this validation of IRI, do we have same validation of these other distresses in Australia? We have documents, such documents?
Thank you for your question. Yes, we've spent an hour out on the road validating other things like rutting, texture, and roughness we've talked about. But I guess the challenge for us at the moment is still with cracking. That's the big one. But the other ones, there are reference devices that we can get ground truth measurements for. But again, it takes a bit of time. We try to do them all at the same time to minimize costs and time. But yeah, still a challenge for us too. So we've covered some others. Those test methods I mentioned do cover rutting and texture. There is some talk about cracking, but it's not as mature or defined as the other parameters. So it's a challenge for us as well.
Are you okay? Yeah. Okay, next question, please.
Hello. So we have two types of distress measurements. One is from the visual and the other is from the profilometers or the roughness. How would you standardize these two measurements? Like one is from the response side and other is from the visual side. How would you standardize for Indian conditions? Do you have any experience with that?
Okay, I think with us, our road agencies have been willing to just take a step change. So they know that visual rating is maybe, well, let's go back. You know, people used to walk the roads and jot down what they saw, very unsafe. So they used to do it that way. Then they saw with developments in technology, with this 3D systems like John talked about, they just said, hey, we'll do away with the visual. We're just going to go to machine collected data. So there'll be a step change. Sometimes maybe the historical lines up pretty well, but they were just willing to say, all right, we're just going to go with a newer technology, and that's the way forward in the future.
So, so let's say you got some roughness out of the visual ratings.
Sorry, so for us, no roughness out of visual ratings. It's all automated.
All laser-based.
Yeah,
Okay.
yeah.
So how would you design your MNR standards? Let's say I got 40% cracking on one of my segments and 10 mm of raveling on my segments. How would you prioritize the MNR for these two different kind of distresses?
Yeah, I probably don't have an answer off my top
I mean,
of the
not
head for
exact
that.
answer, but the approach to it.
But yeah, and you know, even how do I put it? I think some of these things we're still looking at. The LCMS, for instance, we historically have just used it for like cracking and potholes and transverse profile or rutting. It does a lot more things. So what our road agencies now are actually getting more into that. So some of those things like raveling are still maybe visual, but they're looking at what's available now. So they do have some research projects internally, state by state, that look at these things. And certainly I know raveling in Queensland is something they've been comparing their historical visual with the automated because they want to go automated. So it's a work in progress, but you know, people do want to go that direction. I probably didn't answer your question exactly, but anyway, come and speak to me if you want to talk more. I'm happy to.
Sure, thank you.
Thank you. Next question.
Good afternoon, sir. This is Aman Kashyap. Sir, my doubt is not exactly doubt, it's a query. Because you have an instrument which is traveling at a given speed, say for calibration or even while measurement. So what can be its optimum speed? Or else the second question can be asked, like in a mixed traffic condition where your vehicle cannot run at a constant speed, you have a speed which is varying while you are taking results, how you manage? So first is like optimum speed, and second, if you have a variable speed, how you manage the results?
Okay, so that's a good question. With roughness in particular, for an automated system, you need to be traveling at a certain speed, maybe 10, 15 kilometers for the accelerometer to get enough signal and not be washed out by the noise. So, you know, on the highway system, it's not too bad. Internally, in the urban network, our road agencies are accepting a little bit that there'll be some missing data. But what we usually arrange is, we call them green light runs. So we're actually talking to traffic control. They're giving us full access so we don't have those speed problems. So we'll do that at night rather than during the day. You know, I notice it's very different here with the traffic flow from what I've seen in India. So maybe more of a challenge than for us as well. But, and sorry, I missed it. What the first question was?
The optimum speed for measurement means what
Speed of measurement. Oh, sorry.
Or recommended speed.
Yeah. So most of the, you know, there's a minimum speed range for a couple of things, but we're typically doing on network highways, you know, 90, 100 kilometres an hour, whatever the limitation is of this, whatever system we have, that, you know, the data rates, if it, you know, say the LCMS, we can't do 120, we might step it down to 100. So yeah, we'll go with the traffic flow basically.
Thank you. Now we come to the last topic, that is road inspection data. The importance of data quality and repeatability for asset management by Dr. John Lauren. Okay, please give the mic there.
आप वहाँ माइक दीजिए वहाँ पे।
My question
Okay.
is, yeah, can I ask one?
Yeah, you can.
Yeah, my question to
Next
Dr.
question.
John is ki you have a product which is being used by a system integrators to manufacture equipment which is actually used for surveys, right? So there is another layer of software above your software. So that software sometimes is giving different system integrators are using different softwares. So the results are actually coming different when we do the repeatability test or reproducibility test. So is there any role of metrics to make this uniform, or it's not in your scope?
Yeah, you can have differences from one system to another. Some integrators do their own processing, but really they have to put for example, cracking is measured in different ways. The definitions for cracks are different from one country to another, one province to another, one state to another. So they have to be able to adapt the results to what the client expects. So it's normal that the integrator has to add a layer of processing. Also, when you drive, you always have issues where the odometer is not perfect. You have to start and stop. You have to stretch results and put them in to match the databases of the customers for the different roads and sections. So all that is work that has to be done, and invariably you can have differences in results. Also, the algorithms that we provide, there's parameters to them. So they will usually adapt some of the parameters to the conditions of the roads that they're the best to get the best results. So if someone doesn't know how to adjust parameters correctly, they can maybe not get as good results as someone who has a lot of experience in choosing proper parameters. So all these things will influence. And the thing is we cannot fix them because in some cases, some parameters will work better than others, and they'll be good for one country and not good for another. There's different ways of measuring rutting and so on. So we like to let people use. So this is it. You know, you can give me a scalpel, that doesn't make me a surgeon. So we give them an instrument, but these people, they are experts, and if they know how to use it and use it well, they will get good results. If they don't, they will get less good results.
Next speaker. Next.
Good afternoon, John. Dr. John and esteemed delegates and speakers. So my question is very specific. Whether raveling index is generally pavement condition assessment, my question is whether there is any new initiatives related, there is some use of artificial intelligence in raveling index across the globe.
We use AI for several different distresses. We use it to detect sealed cracking, to detect man-made objects like gutters, storm drains, manholes, also patching and pumping when there's sand coming out. So typically it's used when for certain of the distresses, not all of them, but for some of them, yes, it's useful. Yeah.
Thank you so much.
Yes, the last question. There are two more. Yeah, we can agree to. One, Diji.
Thank you. Hi, John. Hugh Benbow from ARB Systems, Global Support Manager. I just wanted to follow up on Dr. Munjal's question there before, and just seeking some clarity on some of the settings for the cracking processing. They're facing challenges here in India with differences between different integrators, and they're trying to clarify in their own minds what is the best way forward for them to approach this. I would like to seek your input and some of your thoughts perhaps on whether you believe that in the real world, if the application of the same sensors and the same processing settings into your API, will that produce identical results across different sensor sets?
Yeah, it should, yeah.
Thank
If you have the same version of the software, you have the same parameters, you will get the same results. Yeah.
Hi, John. Hi, John.
Yes.
The numerical algorithms which are presented, are these machine learning algorithms or are you using just the numerical algorithms? The algorithms which you presented, have you used machine learning? Are they machine learning algorithms or numerical algorithms?
Your question is not clear. Please repeat it again.
Oh, okay.
My second question is,
Yeah,
what are the constraints? What are the constraints and assumptions made in the predictive models that we presented?
For machine learning, you said what we use?
The first question is regarding the algorithms which you have used. Are these numerical algorithms or machine learning based algorithms?
Actually, he's talking about numerical algorithm or the machine algorithm, AI system. So
Yeah, okay. I thought you were talking about AI. So I actually made a presentation just on that subject at the ERPUG meeting. If you look at the ERPUG website, you will see there's a presentation on the use of AI with the LCMS. But I will answer the question. We use it for like for patching, for seal cracking, for pumping where sand comes from inside the cracks. There's also for things like man-made objects, which is like storm drains and also manholes and things like that. So, of course, you don't want to use AI for cracking because cracking is something you need to measure with accuracy. And AI doesn't give you very accurate measurements. Rutting also is not a good...
So have you used regression models? Have you used regression models for the numerical?
Oh, regression models. No, it's typically neural networks. Okay. I don't know which model we use, but
my second question is.
So you can. I'll request that you can interact in the lunch session if you're available for the lunch. So you can interact there in person, and whatever the doubts are there, he'll be able to clarify there. So I think this was the last question. We are running out of time. So thank you. Thank you. Would you like? Okay, that was the last question. Okay. Please give the mic there.
Thank you, sir. I will keep my question short. So coming to the PCI, you are aware there are 19 distresses with 3 different extents. I just want to know, the LCMS have some limitations and they collect close to 12 or 13. So in this PCI model, then how do I integrate the remaining distresses, or how do I identify the false positive? So we are doing it currently manually. So being an automated system, what's your take on this to ignore the false positives collected by the LCMS?
So it's PCI. There's some of them are missing. So the PCI it's a really complicated method. So we approximate as best we can the different. We approximate as best we can the different levels of severity. We ask different people what they think about this level because there's no precise definition of what the different severity levels are. And some of those 19 are don't influence much the results. So like weathering and things like that. So we focus on the most important ones and trying to get the severity levels as consistent as possible with different people. And the results actually are pretty good in terms of the classification and repeatability of this. So, but it's a relatively new feature, so I don't have a lot of examples from people outside who have been doing testing with this. But hopefully it will help.
Okay, thank you.
So this is the last question. Thank you very much. Now we are coming to the last segment of this session. That is the concluding part. So I'll start with the first topic, World Bank's engagement in India, road safety initiatives and success stories by Cecilia. So as far as the road safety is concerned, gentlemen and ladies, we must understand the very fact that our country accounts almost 30% of the fatality globally, and this is our country is the highest. So this really raises a lot of concern about the road safety in our country, and this point was also echoed by the Honourable Minister yesterday, and we need to do something seriously. And as the topic was discussed very aptly in very deliberate manner, of course there was time constraints, but still there were a lot of constraints. And I must acknowledge the very fact of the World Bank. World Bank is engaged in a big way in our country, right from the construction and everything, then also into the road safety. So they are also, collaborating with the national government, this central government, and in various other civil societies. So this is quite interesting that World Bank is showing a lot of interest in road safety as well. And so it is our also responsibility at every level with all the stakeholders that we should consider this aspect very seriously. And in fact, the most important thing, along with the policy interventions, legislations, capacity building, data management, collaboration with various stakeholders, codal guidelines, along with that, the most important things, what I feel that the enforcement is the very essence of our road safety, because whatever we do, and if you don't enforce the things seriously, so naturally we are not going to make much of difference. So this is all about. So thank you, Cecilia, for covering this topic in great detail. Thank you very much. Now coming to the next topic, a big round of applause to Mrs. Cecilia for that. Now coming to the next topic, Korean experience of value engineering in road projects by Mr. Jumo Seong. In fact, value engineering, not only the road works, it is applicable everywhere. And as far as our country is concerned, it is more important in the sense that we have got a lot of stake in road constructions because our country is very huge, and we don't have that much sufficient fund to meet the requirement of the countries. So naturally, this important topic, the value engineering, becomes very, very important in the sense that because it emphasizes towards the cost optimizations. So that is one thing. If you see, every penny saved is a gain for the country. So in that sense, this cost optimization, without affecting the quality and the safety of the road construction, we have to go for it. And it was something new for us. And we are not very much serious on this aspect as far as we engineers are concerned. Especially, we can see the value engineering at the time of DPR preparation. So that is a big challenge for us. So all the stakeholders who are involved into the DPR preparation, because that is the root of the cost optimization. If you look at that level, so definitely we can make a lot of difference in cost optimizations, and also we can add to the value engineering in our road construction. So that is one thing, the takeaway we have from this value engineering. Thank you so much, Mr. Jumo. It was very, very good and apt topic for us, and a big round of applause to Mr. Jumo for the same. The third topic regarding operation and maintenance of road tunnels by Mr. Meisha Kitayama. In fact, he has tried to show many case studies and how we can go for the road maintenance post-constructions. So that is very important because we don't know much, or we don't have that wherewithal to go for the road maintenance in a very systematic way. So we are still in evolving stage. So the insight which you have given for us So it will be really, big gain for us, big advantage to us, so that we can really think of, going for that detailed study. We can collect the data as far as the line is concerned, the geotechnical is concerned, about the rock mass is concerned. So there are so many things we can collect the data from the topic which he has discussed about, and we can then plan the maintenance as well as the safety aspect post construction of the road tunnels in our country. And also it is very important because India is contributing in a big way as far as tunnel construction is concerned, especially in the city areas, in metro areas, which is hugely populated. So there the sense of maintenance is very, very important, because there is a lot of dynamics comes into play as far as the operationality of the tunnels are concerned. So in that way, I think this topic was very, very beneficial for all of the engineers. And so big takeaways from this topic. So thank you so much, Mr. Kitayama. Thank you so much. And big round of applause to Mr. Kitayama for the same. Now, the remaining two topics, I will hand over this to my co-chair. He will throw some light and he will sum up on these two topics. So, Dr. Ravindra Kumar.
Thank you, sir. You might be knowing that now India is transitioning towards the mandatory condition assessment of the road with the network survey vehicles. And in that context, calibration and validations is important practice. And of course, it's ARRB and NTRO is going to the next generation payment data collection technology. So that's going to be very useful, pragmatic shift from the basic road asset management and the Australian experience with IRA validation with reference to data, references, devices, repeatability and validation. That is the key for the accuracy level. And of course, we keep on interacting with NTRO. Recently, we have, being in the CSIR, we have signed the agreement with the NTRO. So we'll keep in touch with the NTRO to access the data sets, what they are having, and we'll try to get some lesson learned from them. And of course, that will be going to helpful how best we are going to do the calibration and validation. That is more important for the network survey vehicles. So thank you, Mr. Richard, for giving the insight and giving us the best practices platform for the Australian perspective. And of course, the accuracy with high precision is the key. So advanced data collection with the high precisions will be coming feature of the India road network assessment. So thank you. Give him the big applause. Now coming to the road inspection data for the repeatability of the road asset management by the Dr. John Laurent. He has given the insight about the minimum serviceability level, how it, once we give the maintenance aspect, then how we increase the life of the payment. It increased from the 15 years to 30 years. So important of LCMS, that is important, especially now we are going for the major data collection to the AI-based data support system. So your data and accuracy, how best already many of the speakers, many of the audience also asked about the questions about the authenticity of the data, numerical validations or machine learning models. So of course this is going to be mind-changing perspective from the traditional data collection to the AI-based data modeling, where you are making the 96% agreement with the manual one, which you claim in one of the slides. That is very interesting. And you have developed the raveling index, roughness index, and of course NCHRP report 914. So that all gives the idea how we are going to take the India most forward with your experiences, with the LCMS techniques and with your experiences in the AI and AI-based data processing. So thank you for giving us insight. So let's give him the big applause. So thank you very much. So I hope we should close this.
Now this session is coming to close, and it was very exciting session because it gave a lot of exposure to international practices. So in that way, it was quite exciting and interesting. Thank you very much to all my presenters and co-chairs and lastly the audience. They kept a lot of interest in this, and thank you so much for giving a very patient hearing. Thank you so much. Thank you.
Thank you so much. Requesting everybody to please stay back with us for a few more minutes. And thank you so much, the chairman of the session, Shri Jitendra Prasad ji, and the co-chair of the session, Shri Ravindra Kumar ji. Thank you so much. Now, would like to request the chair of the session, Shri Jitendra Prasad ji, is going to felicitate our presenter. So, requesting Ms. Cecilia Fabian Kadeha, transport specialist, and currently serving on the ICRH7 committee, to please come forward and receive the memento. Next, would like to request to step forward Mr. Jun Mo Seong, KEC long-term expert to NHAI Korea Expressway Corporation, KEC. Next, would like to request to step forward Mr. Michiya Kitayama, Director Representative in India, Inexco India Private Limited. Thank you so much, Shri Jitendra Prasad, sir. Now, would like to request our respected co-chair of the session to please come forward, and he's going to felicitate Mr. Richard Wex, National Technical Leader, Infrastructure Measurement, NTRO. Next, I'd like to request Dr. John Laurent from Canada to please step ahead. And next, to felicitate our respected chairman of the session and the co-chairman of the session, would like to request Madam Sashmita Nai, Odisha's first lady chief engineer, Works Department, Government of Odisha. Let's welcome Madam with a big round of applause. And requesting our respected chairman of the session, Shri Jitendra Prasad, sir. Sir, thank you so much for all your time, all your valuable words. Thank you, sir. Next memento is our respected co-chair of the session, Shri Ravindra Kumar ji. Thank you so much, sir, for all the time. Thank you so much, Shashmita Naik, madam. And once again, thank you so much, Chairman of the session, Shri Jitendra Prasad ji, co-chair of the session, Shri Ravindra Kumar ji, along with all our respected international presenters. Thank you so much. So we are winding up the session 8 here. And the next session is technical session number 10, and which will be going to happen around 2:45. So requesting everyone, it's time for the lunch break. Go and have lunch, and please come back by 2:45. Thank you.
Hello.
Additional Director General. Additional Director General. ठीक है मैम और यहाँ सर किनका नाम बोला आपने अरुंधति मेहर कौन पहले अनुराधा मेहर अनुराधा मेहर as superintending engineer superintending engineer superintending engineer क्या है तो बोलिए क्या चेंज करना है मैम presenters के नाम दे दो presenters के नाम आपको यहाँ से दिए गए हैं हरीश बहुगुणा now I invite all presenters of session to come on the stage हरीश बहुगुणा ये कौन सा नंबर पे है मैम इसको बस ये उस सेशन का इसमें हरीश बहुगुणा ठीक है श्वेताब सिंह अच्छा वो मैंने देख लिया मैंने कल बोल दिया था संदीप सिंह हाँ को करना G2 कमेटी श्री संदीप सिंह हाँ श्री लालमणि सिंह
Sure. Sure. Very good afternoon to all the ladies and gentlemen. Once again, welcome back. And here we are going to begin with technical session 10. That is for presentation on road, tunnel and underground structures in highway. So first of all, let me take the honor and let me welcome the chairman of the session, Shri R.P. Indoria ji, former Director General, Road Development in Special Service, Ministry of Road, Transport and Highway. Let's give a big hand and let's welcome the chairman of the session, Shri R.P. Indoria ji. Namaskar, sir. Welcome. Next, would like to welcome on the dais our co-chairman of the session, Shri Rahul Gupta, Additional Director General, North and Secretary General, IRC. Let's give a big hand and let's welcome sir. Namaskar, sir. Welcome. Now, I'd like to welcome on stage to welcome our chairman and co-chairman, Superintending Engineer, Mrs. Anuradha Meherji. Let's welcome her. Anuradha Meher, Superintending Engineer, Works Department, Government of Odisha. First, we are going to welcome our chairperson of this session, Shri R.P. Indoria ji. Once again, sir, बहुत-बहुत स्वागत है. Thank you so much, ma'am. Now, I would like to call all our respected presenters to the dais. So, first of all, let's welcome on the dais Dr. Harish Bagunia, Director General, Geological Survey of India. Let's give a big hand and let's welcome sir on stage. Once again, requesting Anuradha Meher, madam. She's going to welcome Dr. Harish Bagunia ji with the flower bouquet. Would like to call our next presenter on stage, Shri Shwetav Singh, Co-Governor, G2 Committee. Let's give a big hand and let's welcome Shri Shwetav Singh ji on stage. Can we have on stage our next presenter, Shri Sandeep Singh, Head Strategic Business and Tunnel Infra, JSL. Welcome, sir. Would like to welcome our next presenter on stage, Shri Lalmani Singh, SE Border Road Organization. Let's give a big hand and let's welcome sir. Welcome, sir. Would like to welcome on stage our next presenter, Shri Saurabh Shekhar ji, SA Infra. Can we have our next presenter, Shri Saurabh Shekhar ji from SA Infra? All right, would like to welcome our next presenter on stage. So he is going to join us online. So he is Professor Arnoldix, past President ITA, AITES. So would like to welcome him online also. Now, requesting the chairman of the session, Shri R.P. Indoria ji, to begin with the session with his remarks.
A very good afternoon to all present. This is a very, very important session, and this is for the first time IRC has taken an initiative to have discussions and deliberations on a very sensitive subject like this. You know, space is becoming a constraint, especially in urban situation, and also in tough terrain like when you have hills or there are other problems, you want to cross a river. Underground structures are becoming more and more important. So it is very good initiative by IRC to focus on underground structures. And we have very eminent speakers who will be speaking on these subjects. And one gentleman, he has been kind enough to join us from Australia. And because of the time gap, I think it's time to go to bed, but we'll still bother him. I first invite Mr. Arnold to start his presentation. And Mr. Alden will request him to finish it in 10 minutes. Mr. Arnold, please welcome him.
Yeah, just to inform everyone that Arnold has been closely associated with India, especially during the Silkera Tunnel rescue operation. He volunteered to come to the rescue site. He stayed there and worked alongside with all the rescue teams, guiding them, motivating them, and especially my colleagues from BRO. They may be well aware about that the BRO officers, they work in close tandem with Arnold, and which has ultimately resulted for the successful rescue operation, where all the 41 workers were successfully rescued without any injury or casualty. So, and thereafter, Arnold developed a keen interest in Indian tunneling practices, and he is actively participating in the activities of H10 committee. And time and again, he is advising how to improve our standards. And now his presentation is basically on the wisdom from other road tunnel incidents. He is primarily a safety expert and giving advice to across the globe regarding the safety. And at present, he is having a very important assignment with the International Atomic Energy Commission, Geneva, where he is being mandated to carry out the safety audit of the nuclear waste disposal sites.
Hello. 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 1, 2, 3. Hello. Hello. 1, 2, 3, 4. Hello. 1, 2, 3, 4. 1, 2, 3, 4. Hello.
Hi, Rahul.
Yeah. Things have been sorted out. Just have a patient for your voice has started coming in. And now the things are. Yeah.
Okay.
I think within 1 minute or 2 minutes maximum.
Yep. Okay.
And sorry for keeping you waiting.
No, I'm sorry I'm not there. You know I wanted to be. So, yeah. Okay, no problem.
Okay, now you are. Yeah, sure.
Hello. 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 1, 2, 3, 4. Hello. There's too many platforms. Hello. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hello. 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 My voice is clear. Okay, so you can hear me now. So if you can hear me, can someone do the slides for me and we don't have to worry about the video then? Is that possible? So just message me. I can take parallel messages on my WhatsApp and just confirm you can hear me. And then if you run the PowerPoint from your end, we don't have to worry about the video. How does that sound? Can someone confirm you've got my first slide up, and then I'm happy to talk. And hello everyone, I'm sorry that I'm not there. I have good reason not to be there. I wanted to be there, and unfortunately I was unable, but I'm there in spirit, albeit just my voice. Look, presentation, I'm being told presentation is being displayed, so can someone confirm I can just start doing my presentation? Yep, okay, so I'm assuming that the first slide is up, and a very big welcome to you all, Swagatam. I'm, as I say, apologies I'm not there. My presentation is my presentation is dealing with something which I know will come to India shortly, and that is that in time you will have some difficulties with your road tunnels, not because there's any problem, but because statistically bad things happen. If we can go to the next slide, please, which has three key documents on it. In my view, there's 3 documents that you might choose to have a look at, and the reason that I'd suggest you look at them is because Europe got caught out at the turn of the century. And what happened was the Europeans thought that their tunnels were perfect because they hadn't had any big accidents. And so they became very interested in building more tunnels, but they weren't concentrating on actually operating what they had so well. And the 3 documents that I'd like you to consider are the EU Road Tunnel Safety Directive, the COSOF publication on safety officers, and the report on the Burnley Tunnel incident in Australia. We can go to the next slide. And unless I get a message, I'm thinking that presentation being displayed. If someone could just message me and confirm we're now up to the slide, which is Directive 2004/54 of the European Commission. So what happened in Europe was there was a series of catastrophic, unprecedented tunnel accidents. And these accidents actually brought several countries to their knees because the tunnel accidents were so big and the states were relying so much on the tunnels that when the disasters struck, the tunnels were closed for years, not weeks, not months, but years. And so Europe responded by putting in place the European Directive on tunnel safety. If I go to the next slide, this is the slide with the red document. So it's a slide with guidelines for tunnel safety officers. What was produced is a management structure. So this is not an engineering matter, this is a management matter where each of the key tunnels in Europe was appointed one single identifiable person, a named person, who would be responsible for tunnel safety advice. So if it was the emergency services, if it was for refurbishment, if it was for an exercise, if there was an incident, the tunnel safety officer was the named individual that people would go to. And information about that person is contained in this document, Guidelines for Tunnel Safety Officers. If I go to the next slide, which is entitled Expert Report, the Fatal Burnley Tunnel Crash, the reason I'm referring to this is because it's the only document available publicly in the world. So the only document available publicly in the world, and I think we're on slide 4 at the moment, entitled Expert Report. It's the white slide. This report that I wrote, this is the only report that you'll be able to find in the public domain that goes through second by second, literally second by second, what occurs in a tunnel disaster and how the operators of the tunnel have to respond and how human beings respond in a disaster. Just go, and so you can find that easily on the internet or contact me and I can send you a copy. Next slide. So as I said, Europe suffered terribly at the turn of the century. Next slide. The next slide. What happened was there was a crash in the Mont Blanc Tunnel, in the Town Tunnel, and in the Gothard Tunnel in the space of just a few months. So up until the turn of the century, the European and the European road authorities were busy telling everybody in the world how clever they were because they hadn't been having any big crashes. And then all of a sudden, they had 3. And for those of you who practice advanced mathematics and are used to dealing with non-normal distribution events, so rare high consequence events, what we find in maths is that there are clusters of events. Bad things happen in groups. And so this is what Europe saw at the turn of the century. I'll go to the next slide. So in the next slide, I've just highlighted an article that appeared in Roots Road, again, available publicly. And what this article did was compare each of the 3 tunnels in terms of their features, like how long they were, how many tunnels they had, what sort of emergency features they had, and the number of deaths that occurred in the catastrophic incidences. So you can find that on the internet. Now, what we discovered at the turn of the century in Europe was that although they had a lot of good features in the tunnels, they were consistently, if we can go just two more slides ahead, so 1 slide and then 2 slides, so click. I'm just looking, go next slide. Yep, and next slide. Yeah, so what we saw in Europe was that everything was running really well, as I said, until suddenly it wasn't. So this is real footage from the turn of the century. You see single tube, bidirectional traffic similar to what we see in many parts of India now. And the tunnel has good lighting, it has cross passages, and the Europeans were saying how wonderful it was. And it was working very well. That's a picture just showing you how it is, some areas you can pull off. But then, when disaster struck, what was discovered, and this is the Gotthard tunnel fire, what was discovered was that the smoke wasn't controlled properly. What was discovered was that the people didn't evacuate how they were thought they would evacuate. What was discovered was the control rooms didn't work the way they were meant to work. And in fact, the Europeans at the turn of the century discovered, despite the beautiful words and the fact that nothing had gone wrong, they were having disasters. And the disasters like this, where you see the buses burnt out, there's been the fires, you see the smoke, but the main thing that they discovered was how fragile human beings were and how quickly they were killed. And so in this video, in a moment, you'll see the bodies of people. This is just walking along. There's a body on the left. You'll see there, another body on the right, just there. And you'll notice that there's no damage in the tunnel itself. The trucks, the vehicles aren't damaged. The deadly part of this is the smoke, people dead in their vehicles. And this was a huge shock for the Europeans because they'd, as I say, been very content and very happy because they didn't have a history of big disasters. And not only did they have the big disasters, but the fires were so severe, even though they hadn't had them before, that the tunnels couldn't operate for years. And that's why they introduced the European directive. We go to the next slide, please. Next slide. And next slide. And so when an analysis was conducted of these three events, there was the Mont Blanc tunnel fire, and that was around 12-kilometre long tunnel, bi-directional, so one tunnel, people going in each direction. It used quite a sophisticated ventilation system, and actually 303 vehicles, including nearly 160 trucks, were involved in this disaster. Next slide. Go to the next slide, please. Hello. Next slide. Whoever's on the next, yep, that's it, thank you. And so the impact of this was very severe. The temperatures of the fire were over 1,000 degrees, and the fire burned for more than 50 hours, and the emergency services could effectively do nothing. So next slide. Okay, and next slide. So then the town tunnel disaster occurred just only a matter of weeks later, and in this disaster, smaller tunnel, just a little more than 6 kilometres long. It was a mixture of trucks and normal cars, and there was a queue inside, so the traffic was stopped, there was some works being done, and then one vehicle crashed into another, and again, major catastrophic fire. Next slide, please. And so the lessons learned here were about managing traffic in tunnels when they're operating normally, that the emergency infrastructure in the tunnel not only has to be there, but you actually have to manage it and use it correctly. And so it was, again, a big shock for the Europeans. We'll go to the next slide. Next slide. And next slide. And the Gotthard, which is the one I showed you before with the video, that particular thing, that one just, again, shocked Europe because as I say, this is like there's three of them, all in a very close proximity to other. And if we go to the next slide, so go to the next slide. What we saw there with the Goddard fire was catastrophic damage to the road tunnels. So there were questions raised about the design of the tunnels and their fitness for if there was a fire. The cross passages and smoke control didn't work. The ventilation control didn't work. It was, again, a combination of factors, a combination which the Europeans hadn't seen before. Go to the next slide. And then the next slide. So the Europeans responded by this European directive, and what they discovered and what they implemented was it's not just the physical design and engineering of the tunnels, but probably equally, if not more importantly, is how we manage the tunnels we've got, how we actually make sure that the tunnels we've got are maintained properly, and perhaps even more importantly, operated correctly. Because in each of those three disasters in Europe, the unprecedented disasters, they weren't operated well. And so the European Parliament imposed some minimum overarching management structures on the tunnel operations within the trans-European network. Go to the next slide. And this is the EU directive. And I'm not going to go through the directive. I'm just wanting to explain how it happened. And I know about this because I was there. So I was actually advising on one of those three tunnel disasters, and I also provided input into the directive. So my perspective on these is not as an academic, it's actually as somebody who was involved in this history as it evolved in Europe at the turn of the century. So we'll go to the next slide. So one of the things that the European Union has required is that there is a named person who actually coordinates training and emergency exercises, understanding any accidents that do happen, making sure that they understand how maintenance and other works are done. And it's not just something that slips between the management roles. So it's a person with accountability who actually has to say, yes, this is my advice in relation to safety. Next slide, please. And that implementation of the EU directive has had a huge impact, not just in the EU trans-European road tunnels, but generally in Europe, and it's also impacted other countries where other countries, although they might not follow exactly what the Europeans have done, they've taken the lead and they accept that it's not just about building tunnels, it's about operating them safely, maintaining them safely, and refurbishing them safely as well. So we'll go to the next slide. And so they put it into legislation, and we'll just go to the next slide. And the directive goes for all of the tunnels that link all the European tunnels, so that's fine. Next slide. Go next slide. Yep. And for them, a tunnel is any tunnel over 500 metres long. And we'll go to the next slide. Now let me show you what this looks like. I'm now going to show you from a real incident in Australia in which I was involved in the initial design of this tunnel, and I was later involved as the coroner's investigator into the disaster I'm going to show you. Now, this has never been shown before, and I'm only showing you this because I feel very closely connected to India, and I feel it's important to share this with you. So this has never been seen before. So next slide. So before we did the operation of our tunnel, the Burnley Tunnel in Melbourne, we conducted full-scale exercises, testing all of the equipment to make sure we understood how it worked. And in this case, we were doing hot smoke tests to make sure we understood how the smoke worked. And in this particular tunnel, we have a duct that you can sort of see in the ceiling, which extracts smoke in an emergency. That's an unusual feature of this tunnel. Next slide. And the tunnel itself is private infrastructure. It's part of a toll road network, and it has 24-hour operators. It has emergency exercises every year. And the year before the disaster I'm about to show you, the exercise that was conducted was almost exactly the same as the disaster that occurred. And so it's very relevant to show how a safety culture in a tunnel can have a good outcome for the operations. Next slide. The particular incident I'm going to show you involved trucks and vehicles. It killed 3 people. We had to safely evacuate over 400 people whom, if hadn't been evacuated safely, could easily have died. There were 250 people in the tunnel when the explosions took place, and there were 150 vehicles in the tunnel when the incident took place. Go to the next slide. And the tunnel itself had 3 lanes, all going in the same direction, with the ventilation system blowing in the one direction. It had CCTV with digital image processing, as well as linear heat detection. Has a deluge system with 5,500 litres per minute discharge. It has manual operation for the fire suppression system. It has evacuation into a parallel tube, and it has special elevated emergency egress pathways. Next slide. And the zones for the water-based suppression system are 30 metres long. It also has smoke extraction in the roof. It has ducts that then lead to the outside to take the poisonous gases out. Has cross passages. As I say, it's a fairly modern tunnel. Next slide. And the operators of this tunnel are able to see and control all of the tunnel from a single control room. It doesn't have multiple control rooms, it just has one. Next slide. And it has a whole lot of things that can be activated, such as lane closures, changing the speeds, emergency signage to cross passages, and things like that. Next slide. Now, this is the real incident. So if you just click on that, this is, we're looking through a tunnel. Whoever's operating the PowerPoint, can you do one more click? So what we're looking at, here we go. So we're now seeing, see the truck. So very quickly, a truck wanted to change lanes. You see people running out from the zone where the crash has occurred. We have immediate explosions. We have an immediate fire of about 20 megawatts. We very quickly have the 3 people were killed, and what you're now witnessing is the deluge zone or the deluge system being fired. We just play that video again. There's a lot in that, and I just want you to see it. And so whoever's operating the PowerPoint, can you play that video again? So don't change slides, just make that video play again. And this time when you watch this video, just see how quickly it all goes so wrong, and how quickly a normal operating tunnel turns into a place where, in this case, hundreds of people could die very, very quickly. And you see a person who hasn't been killed just running up the road there, and there comes the sprinklers. So now if we go to the next slide. So I'm just going to step you through this so that you understand what an operator has to do.
because this is amazing. This is where we're really now focusing on why I'm so passionate about attention to detail in operations. So 300 seconds before the incident, there's a car broken down and a tow truck's called. Okay, no big deal. Next slide. Oh, I can't. Hang on, I'm not sure. If you've got the slide that's 104 seconds, the CCTV detects a truck that's broken down. The computer sends an alarm to an operator, and then the CCT image is emergency portrayed to the operator. So then the next slide. The next slide should be headed 55 seconds to 0 seconds. Slide 55 seconds to 0 seconds. The operators do a lane closure to reduce traffic in the left lane, and drivers, we can see on the CCTV that the drivers begin to slow, but traffic is still moving at around 60 kilometres an hour. Then next slide. So the next slide, in this is at the, this is actually a picture of what it looks like. You can see the congestion in the right two lanes with all the vehicles lined up there, but the left lane's pretty, not so many vehicles. We go to the next slide, which is 0 seconds. So 0 seconds, truck in the left lane attempts to change lanes to avoid the stopped truck. Several cars are hit, so it's all in the space of less than a second. There's explosions as the vehicles that are hit, their petrol tanks get blown up and things like that. And the fire size is immediately at around 10 to 20 megawatts. Then the next slide. This next slide is a picture showing the trucks now all moving across into other vehicles just before the vehicles are crashed into. Then the next slide. The next slide is the one with the blue lines on it, and you should be able to see an explosion in the foreground. That explosion is a vehicle going under that truck, and so that's the very first of the fire loads with the vehicle exploding. And on the left you can see now multiple vehicles that are sort of caught in behind the truck that you can see in the left lane. Next slide. So at around 1 second, so the slide should be reading 1 second, in the control room, only 1 second after that catastrophic set of crashes, a red button is pressed, and that calls the fire brigade. There's no radio communications needed between the tunnel and the fire brigade. Pushing the red button means the fire brigade are on their way. Next slide. The next slide should be headed 10 seconds. At 10 seconds, there's no visibility now in the tunnel, downwind of where the crash occurred, none, 0. The smoke has built up so quickly that anybody who's caught there will almost surely die. And upwind of where the incident has happened, the visibility is being maintained by the ventilation system. So go to the next slide. The next slide, which is headed 10 seconds plus, at around 10 seconds, people can be seen escaping from the incident vehicles, heading back in towards fresh air. Those are the ones that aren't killed. And there's no one helping anyone in the area where the big crash has occurred. Even though the people have got bloody injuries, this is very much a self-rescue zone, and those people that haven't been killed are in a state of shock in the initial area where the crash occurs. But in the areas further away from where the crash occurs, people are helping one another. Next picture, next slide. The next slide should show, you can see the vehicles on fire exploding on the left, and you can see a person running across the road. In that car that's squashed in front of that truck, where the person is a lady with a baby, and also she has a baby in her tummy, so a pregnant lady, and she survives as well. Next slide. 48 seconds Within 48 seconds, this control room has closed the tunnel, stopping more people coming in the tunnel. Next slide. At 96 seconds, the emergency smoke extraction system is operated. The zone where the crash has occurred has been positively identified. Emergency smoke extraction has been implemented, and longitudinal emergency flow has been initiated. My friends, we're talking 96 seconds for the control room to actually activate the emergency systems that were put in years before. If the operators didn't know what they were doing or the systems didn't work, we would not be looking at pictures like this. If it didn't work or it wasn't operated correctly, hundreds of people would have died. Next slide, please. Here's a picture now. This is a picture showing a man running past the explosions. And if it wasn't for the emergency ventilation system operating at this point, he would have died because the toxic smoke and the rate of smoke generation was enormous. Now, next slide. So the next slide, we're at 96 seconds plus. The CCTV cameras are now recording improved visibility downwind of the fire as the smoke extraction system re-establishes smoke control. And we can now again see the road surface because the smoke is being controlled by the ventilation system. At 106 seconds, so next slide, 106 seconds, so less than 2 minutes, we've now got the deluge system, which is the fire suppression system being operated. The operator has identified the location of the fire, has activated the correct deluge zones, and has decided to set off 2 zones of fire suppression. I'll go to the next slide. In this slide, you should be able to see the explosions and fireball on the left, the stopped vehicle and crashed vehicle on the right, but you can now see from the roof water. So that water is the very first zone of the fire suppression zone coming on at less than 2 minutes since ignition. And with the fire size already somewhere between 10 and 20 megawatts, the fire suppression system is now activated. Next slide. In this next slide, there are 3 pictures, and what they show is the sequential operation of the fire suppression system across the zone where the explosions and fireball are happening. So the left picture, picture 28, is the first part of the zone going on. Picture 29 is showing the next zone coming on, and picture 30 is showing the suppression system now operating right across this explosion and fatality zone. And you'll see it's very aggressive in the way it's dealing with the fire. Next picture, next slide. So the next slide is totally black. And the reason for that is that's what it was like downwind of the fire. If you were stuck downwind of the fire, if the ventilation system, if you weren't able to get to a cross passage, if you weren't able to get out of that tunnel, just like in the video I showed you earlier, you would be dead. Because that's what happens in a tunnel when you have a big fire. It is black, it is toxic, there is no way out. So timing is essential if we're going to take advantage of the emergency systems in our tunnels, the emergency systems we spend so much money putting in, and which the Europeans, well, they learnt for us. We have to make sure we can use them in an emergency. Next slide. So at 116 seconds, so this is the next slide, 116 seconds since the explosions, the emergency evacuation signage and messaging has been initiated. Next slide. At 140 seconds, so just over 2 minutes later, the radio and TV stations are already contacting the government to find out what's happening at the tunnel fire. So the media are onto this faster than you can imagine. So, and this is typical what I find around the world. The media are there probably quicker than anyone else. Next slide. At 282 seconds, so we're only talking now a few minutes, the fire brigade is on site. So slide 282 seconds, fire brigade is on site. And the next slide, at 5 to 6 minutes, so the slide headed 5 to 6 minutes, the fire brigade are within 120 metres of the fire. They're on foot, they've got their breathing apparatus on, and they're now extinguishing the fire with their hydrants and high-rise packs. So the suppression system in the tunnel, combined with the ventilation system and the other emergency management arrangements, have allowed the emergency services to get right into that tunnel and get that fire under control quickly. Next slide. At 10 minutes, so at 10 minutes, the deluge, so the fire suppression system and ventilation system have been identified as absolutely critical in avoiding further deaths. And if we go to the next slide, what we see, and this is the one with the graph, what we see is the way in which the suppression system and emergency systems were utilised meant that our fire did not grow like other fires have in other disasters around the world. So it taught us that with a properly designed and operated and maintained tunnel, it really does make a difference. And if we go to the next slide, 6 hours after the incident, the tunnel was being cleared and the tunnel integrity was being inspected. Go to the next slide. At 4 or 5 days, the repairs were completed. So new paving, some barrier replaced, some cables fixed up. It was recommissioned and reopened. So next slide, in terms of performance, by focusing on the operations, by maintaining what we'd installed, by building it in accordance with a decent design, unlike Europe, our tunnel was operational within just a few days, and the huge economic consequences of losing that tunnel, we didn't suffer. Actually, it was back operating really quickly. There weren't any burns other than the people who were killed. The deluge system, the fire suppression system worked, the ventilation worked, the smoke extraction worked, the fire brigade worked, the control centre worked. We all worked together as one fantastic team because we had practiced, because we had learnt the lessons from the Europeans at the turn of the century, and we were concentrating on how we operate that tunnel. Next slide. Since this issue, this is the slide entitled Issues. Since that, we've identified some other things. We realise the media are a big issue and we need to be prepared for them. We need to be prepared to deal with hundreds of people in a tunnel event so that we can look after them. Otherwise, we have people running everywhere. We had issues with the communication system, and the media portrayed it as a catastrophe, even though actually, in my view, it was excellent. It was an excellent result because we were prepared and we did our job properly as professional people. Next slide. I don't think it... there were some fines introduced if you behave badly in the tunnel. The speed limits were lowered a little, and that was about it in terms of changes moving forward. Next slide. Just want to acknowledge where the materials come from. I've just some of that material is borrowed from my colleagues, and but most of it is in my coroner's report. So, look, I realise I've gone a little over time. My message is very clear. Please, please, please don't think that because you haven't had a disaster, you're not going to have one. Do spend time making sure that the tunnels you've designed and so carefully built are maintained and operated carefully, and do be ready for an event and prepared to respond to an event fast, because if you can respond to it fast, there's a very big chance that the number of people who are killed will be very small, or none, hopefully, and also the tunnel that you've spent so much resources building,
huge resources. Instead of building a hospital, you build a tunnel, you protect it so that you don't lose it. And so I think that's really important as well. So thank you, everyone. I'm sorry I'm not there. I wished I was. Thank you very much for your time.
That was a very interesting presentation by Mr. Arnold. He really went into, what is required to be done, directives to be decided, and the finer details of operating a tunnel with all the safety features. Very interesting presentation indeed. With that, I will now invite Dr. Harish Barguna, Deputy Director General, Geological Survey of India. Sir, 10 minutes, please.
So which one? Yes. I can change it from here. Yes. And you can also change it from. Very good afternoon, everyone. And I hope that the fine. It's all right. I'll go with this. Yeah. There's some echo going on. Yeah, once again, very good afternoon, everyone. And I hope that the chair doesn't cut more on our time as well. 2 decades ago, there was a very popular novel on the Brazilian capital, Rio de Janeiro, Blame It on Rio. And in Geological Survey of India, the most popular document I often come to read is Blame It on Geo. Because in India, whatever happens to a tunnel, the first thing is, and easiest thing is, to blame it on geology. Nothing else has gone wrong except for the geology. Right, Arnold had shared some of the incidences in the tunnels, but they were in Europe and Australia, and you have seen that how they have tackled, what was their approach. But in India, it would have been easiest, blame it on geo. But I think now onwards, there will be some steps taken by MORTH because they are routing all the DPRs to Geological Survey of India for appraisal. Am I audible now? Yeah, fine. So they are routing all the DPRs to Geological Survey of India for appraisal, and whatever observations these stakeholders may be getting on their DPRs, it may leave some of them flabbergasted that what all are these comments. So my endeavor today will be to be covering all the aspects pertaining to the geological geotechnical investigations with respect to the tunnels and underground structures on the highways, and also will try to give you a gamut of the geological investigations that are required to be undertaken in case of underground structures on the highways. Now, as a prelude, I want to share with you that it's not that only a century or 2 centuries ago mankind started building the tunnels. And if you look at the history of the tunnel construction, it has gone pari passu with the evolution of human civilization on the earth. So it's not that recently we have started excavating tunnels and now we are meeting with the geological surprises, so how to tackle with them. So this is what I was trying to speak. 1600 BC, mankind knew how to construct tunnel for different purposes. These are some of the international examples, and India was not far behind. These are Indian examples, the famous carriage system. And all of these are still working fantastically. So this is what I want to highlight, that the knowledge of tunnel excavation dates centuries back with the mankind. And with the advent of technology, particularly the Alfred Nobel when he discovered, and the way the blasting techniques have evolved, the tunneling has seen a vast change, sea change in terms of excavation and their design. And 20th century, more and more technologies have evolved, right from the, now the automated tunneling has come, the TBM has come, mechanical ways, non-destructive technologies, they all are known to us. So what I just want to cover here is that these road tunnels have come up as a key component in the modern day transportation networks. And they definitely have the advantage of reducing distances, etc., and the other advantages that I have listed. They can be classified based on, I think this all you know, just I'll be passing with these slides. Depending upon the construction methodology and the use dimensions, they have been classified differently. And this is just a quick recap of what all the system network of underground structures that are affiliated, attached with the a tunnel or a tunnel connected with the highways. Just the ancillary safety and emergency features, how they are connected, integrated with the tunnel and underground structures. And this is one aspect that we often forget to give importance to, is the importance of portal areas. Our investigations are very meager here. The analysis is almost lacking. But these portal areas have these advantages, as you can capture from the photographs. Now, this all is known to almost everyone that polyphase deformation Himalayan rocks have undergone 3 to 4 phases. And it's very important that the selection of the tunnel alignment is done in light with the orientation of the major discontinuities and the weakness features. And accurate recording of geological data is very important, and that is possible only because when we are undertaking the geological mapping and assessment on a larger scale, say 5,000 to 10,000 scale. And with that, delineation of nature and type of overburden, type of rocks, the details of discontinuities, shear zones, fractures and fault zones, etc. That is very, very crucial for a quality investigation and preparation of quality DPR. And another important aspect is we do give some exploratory holes, but without giving any, importance or keeping in view of the very purpose of giving those subsurface exploratory drill holes. We rather try to fulfill the number of drill holes that are required to be done, but the location, the depth, the orientation of the drill holes, that is very, very important. That is often being overlooked in many cases. And in case of shafts, this is very important. When you are excavating for the drilling for the shafts, ensure that it is reaching to the bottom level of the shaft. And in case of tunnels and rifts, it is reaching up to the invert level or even 1 to 2 meters below the invert level. Otherwise, it's of no use. It's of no use. We have seen, Rahulji has also referred many DPRs, the cover above the tunnel is say 800 meter and your drill hole is 80 meter. Tunnel is at 800 meter below the surface. So what is the use of that information? You do have a drill hole, you have spent money, but the information is of no use, particularly in case of Himalayas. Now this is the whole schema of geological investigation that need to be done. Please take cognizance of these. The stakeholders are here. So they can take note of these, that what is meant by geological data collection, surface geological mapping, the geological materials. You see, one more thing I want to discuss here is, many maps would be showing simply as overburden and rock contact. But in engineering geology in particular, the type of and nature of overburden should also be specified. I mean, the overburden can be a riverborne material, or a laterite cover, or a glacial dump material, and the geomechanical properties, the shear parameters, the deformation characteristics of different kinds of overburdens will be different. So it's merely not indicating the overburden rock contact, but to specify the nature and characteristics of the overburden as well. The subsurface geological data should be accomplished by drill holes and rifts wherever possible. And It should also contain the details on the rock quality designate and the permeability characteristics of both the overburden and rock. And at this stage itself, if you are carrying out some estimates of uniaxial compressive strength, the RQD, and all these can be done indirectly with the application of Deary-Miller method, simply with the blow of geological hammer. No testing is required at this stage. And with that, you can go ahead with the characterization of the rock mass. So that will give you a preliminary idea about what is the tentative class of the rock mass. This can be done easily right at the time of investigation if the investigation is done properly. Now this comes to the testing phase. These are the different tests, lab and in situ for the rock and soil. I'll not read out all these things, but these are the mandatory tests that need to be conducted. And what is the importance of these tests is that will help you in evolving the rock mass classification for that particular project, which is very important. And along the tunnel alignment, if you are giving the rock mass classification, that will help you in building the BOQ at the end. And these are the, as per the Bureau of Indian Standard Codes, I have mentioned the code numbers as well. Now, after this, portal areas I was mentioning, and inside the tunnel cavity also, kinematic checks for identifying the potential modes of failure. The structurally controlled and stress-induced failures, they need to be identified right at the time of the DPR preparation. And all these combined together will be a basis for evolving the design support measures inside the tunnel. It will help you in decision on the excavation methodology, whether you want to go with DBM or TBM, mechanical, non-mechanical, destructive, and selectively also. It's not that all through you are going with the DBM. You can go with, with certain UCS range values, say 50 to 90 MPa of the rock mass. You can go ahead with the road header as well, the mechanical means. So where the areas are sensitive, drill blast activity is not permitted by the government provisions, then you can go ahead with the non-destructive methods. And there, these characteristics, these parameters will be of immense use for you, as I have written, non-invasive methods. And then you can decide upon the support system that is required for a tunnel for that particular structure. And finally, the instrumentation and monitoring, the type, number, location, everything that you can decide. And all this can come out with a proper set of geological investigations that I have listed. Now here, some of the challenges that we have noted, recorded through some of the DPRs that we have recently appraised, I have listed down. Yes, there are, the biggest challenge is the client has submitted a report with a geological map on maybe quarter-inch is to a mile, 250,000 scale. It shows sometimes entire North India or entire Deccan Trap and just your 2-kilometer tunnel alignment on that map. So you see what judgment versus assessment on the geological conditions you can have from those kind of maps. And secondly, the biggest mistake that we have noted is, despite that all the 50,000 geological maps, 50,000 scale geological maps have been published by Geological Survey of India, which are available for free download from the Geological Survey of India web portal, people are not utilizing them. In addition to that, we have also completed national landslide susceptibility mapping on 50,000 scale, and for entire 4.3 lakh square kilometer of area that is affected by the landslides in India, we have the maps for free download. Nobody is using. I think we have to incur costing on them, and suddenly the people will start using them. Right, so these are some of the gap areas, and subsurface exploration, as I mentioned, very scanty. One of the area we were, appraising Rahulji, we were together. Out of the total tunnel length of 12 kilometer, the cumulative drilling was in, say, around 1.5 kilometer length of the tunnel area. And that too was restricted to the either portal site. So what geological appraisal, what geological information you will be getting along 12-kilometer long tunnel. But the client will submit a DPR projecting, extrapolating the geological information which he has noticed right at the portal area, say 5 kilometer inside the tunnel, and which in Himalaya everybody will appreciate is going to produce a disaster. So, and there is no coherence between the maps that they have produced and the sections that they have submitted along the tunnel alignment. So map is saying something else, section is speaking something else. And also there is no match, there is no attempt to validate, to correlate the discontinuity data that they have collected, what they are showing in the map and the analysis part. So attempts should be made to correlate the physical geomechanical properties of the rock soil vis-a-vis the rock mass classification that the client who is preparing the DPR, they should make an attempt to this. And there is, we have often found that geophysical explorations have been used to the minimum, which can be maximized. And secondly, kinematic checks at the portal area I have also mentioned, and stabilization of the slope above the portal areas, that should be taken seriously. Now, there are, of course, challenges. We do understand that, and we take due cognizance of those. And the challenges arise mainly because of the inaccessibility, the high altitude area, the snow cover area, reserve forest area. I mean, these are the challenges. Tiger reserve forest in Sri Salem left bank canal tunnel. It was in the tiger reserve area, so no exploration was permitted. So no information was available, but section was prepared. And you have to conjecture the geological condition inside the tunnel. And should there be any failure, blame it on geo, simply. Right, so limitations in geophysical methods, of course, you cannot have geophysical exploration penetrating down to 500 meters or 800 meters below the rock cover, surface cover. And this is one of the challenges that we have identified, that skill level of the manpower, whether it is regarding the geological mapping, choice of the samples, sample collection, data interpretation and analysis that has been identified by us. Then, of course, this has been discussed in detail at MORTH, which mode of contract we should go, the rate contract or the BOQ or the turnkey L1 level that we are now practicing. The poor quality of DPR is leading to variations in the projected and encountered geological conditions, and that also leads to time and cost overruns. And here I want to make an appeal to MORTH, or maybe through IRC they can integrate this thing in the guidelines, that the projects may be asked to, developers may be asked to invest at least 1 to 3% of the project cost on the investigations. Please do that. If sufficient amount of investigation you are investing money in, that will lead to a quality DPR, and quality DPR will save you on many accounts, as I am saying. And again, from GSI and in personal capacity also, I want to tell MORTH that GSI will never encourage any EGO or AGO. I mean, you don't investigate properly, you submit any kind of DPR and go ahead with the construction. Anything happens, blame it on GEO and declare it as AGO or EGO, and then the time and cost overruns are justified as an alibi to shield our lack of quality DPR. Now, with these words, I also want to highlight here that this also presents an opportunity for all of us that to go with the quality investigation, use the modern tools and technologies such as 3D logger, photo logger, drone mapping, and integrate all the AI, ML, for data processing, analysis, and modeling. And at the last, I just want to appeal, make use of these IRC guidelines and the Bureau of Indian Standards guidelines. Thank you so much.
Thank you, Dr. Bahuguna. That was very enlightening and interesting presentation. Usually, geology is considered very monotonous kind of a thing, but you made it interesting. Thank you very much for that. It was a good effort. Now, can I invite Shri Swetab Singh to make his presentation?
Shweta will be making a presentation where Dr. Bahuguna has left. So he will be showcasing how the deep learning can be utilized for predicting the ground behavior.
हाँ this one, ये वाला, second वाला, second.
सेकंड बोला एक सेकंड इस पे थोड़ा सा सर ये इशू रहेगा इसमें आप
ठीक है, कोई दिक्कत नहीं, थोड़ा सा इसका स्केल में डाउन कर देता हूँ.
दो उंगली से ऐसे नहीं जाएगा
ये पेज डाउन से नहीं जाएगा.
हाँ इससे भी जाएगा
ओके,
डाउन से
थैंक यू. Good afternoon, everyone. First of all, my gratitude to the chair and sorry. Sorry. Good afternoon, everyone. First of all, my gratitude to the chair and co-chair of this session. And I extend my thankfulness to all of you to have been present here for this presentation and this session. So the topic that I'm trying to bring forth, carrying it forward from the previous presentation, is predicting the ground behavior with a deep learning fusion pipeline for NATM excavation. So this is something very abstract as a topic to be discussed at this stage, but something that seems very abstract at this stage in the age of this technology and the boom of AI would see the, by any stretch of imagination, this would be a reality in next 6 months to 1 year time zone. So, we are not peeking too much into the future right now, but yes, as the development stands today, so I would like to draw your attention towards this and how these modern computing techniques can help solve the problems that the previous presenter, honorable presenter, has just addressed due to lack of extensive geotechnical and geological investigations. So I'll take this presentation forward. So as we have been discussing for decades on the principles of geotechnical engineering, so the primary source of risk in underground construction is the uncertainty of geological conditions. So this uncertainty of geological conditions is something which arises out of our limitation in dealing with huge set of data. Fortunately, for last 2 decades in India, we have been doing a lot of tunneling in the Himalayan region. We have been dealing with a lot of rock masses in terms of slope stability and developing the road infrastructure, railway infrastructure. So every project that we do or get indulged in is actually extraction of a lot of data, or what I should say is the currency for the tools of AI and machine learning in this age. And this is where the origination of this idea is, where we have been working, and the abstractness of the processes. As far as the traditional approach is concerned, it remains the same, that the geotechnical investigation and the geological data is collected, overlaid over the digital terrain models or the ground survey data, what we call the Landsat imageries these days. And then we do a geological reference modeling in predicting the ground behavior, for predicting the ground behavior. And while the underground excavation or exploration is done physically, the models are updated based upon the face logs. So this has been the traditional approach. But with the new approach that is augmented by AI and ML, or what we call as the deep learning, what we are trying to do here is, or to project here is, to harness the generative power of AI. So till now, we have been dealing with a lot of AI tools and models, and you might have come across a lot of AI tools because this is something that's happening across the globe, and more so in India, since the users of AI and the consumption of AI and ML tools has increased manifold in this country as well. What we come across in terms of engineering at this stage especially engineering pertaining to infrastructure, is the representative use of these tools. But today we are trying to present and bring out the idea of using the generative power of this tool. And how we are trying to do that, of course, that's a very um, descriptive subject to address in this forum. But we will try to look into some glimpses and try to converge somewhere. So I'll take this presentation forward from here then. So the solution that we think, of course, there can be many competing solutions in this age, is a 3D fusion convolutional neural networks. So we treat the entire project area as a 3D volume, similar to a medical CT scan, and feed it to a model that understands 3D space. So, of course, I don't want to fall in the pit hole of making an oversimplification here, but essentially to make an explanation, this is what the simplest way we can put forth right now. And mind you, this is something that we are trying to build upon projects, live projects right now within India in the Himalayan geology. And if I say that we have achieved an accuracy which is commercially or academically derivable, I won't say that, but yes, we are looking at an accuracy of 70 to 80% with the verification on the ground at this stage. So anyways, so what we have tried to do is that we have tried to build this whole architecture into two streams. One is the mapping and other is the logging. And then comes the fusion layers and then the 3D CNN networks. So, I mean, of course, not getting into the detail of it, I'll take it, I'll go to a more simpler process that we are trying to adopt. So, what we can do here is, what we have tried to do here is to simplify things. We have broken down the whole process into 5 stages, where the step 1 for the fusion, where the digital terrain model and feature super resolution is integrated. Then the stage 2 and 3, as I just mentioned, the geological mapping, the geological structure, which has been covered in detail by the previous speaker. And then the stage 4 is the predictive digital phase logs. So this is the most important phase. And then it gets fused with the conventional NATM or geomechanical classification for ground behavior and support prediction. Sorry, I'll just take some water. So this is something that we are doing very regularly across the spectrum. That is the voxelization, or what we call as the digital terrain models. So we have this is not something that's very different from what's happening across the world. Using the Landsat images, the LiDAR data, and the drone data to develop a digital terrain model stacked with the lithological information that can be derived. But often there is a pitfall of loss of data and errors occurring in these processes. So, as I just mentioned, so I'll come to the hyperspectral data a little later, but we will restrict right now to the satellite, drone, and LiDAR data that actually captures the ground data, that is the surface data. And generally, we are looking at the super resolution CNN. So what essentially CNN would be is, it's an artificial neural network, precisely, which captures the images and converts it into text or meaningful interpretation or meaningful labels. To make it very simplified. So some of these techniques we have been utilizing in doing the data void filling, or rather, I should say what we call as the the super resolution. The data that has been lost during the capturing or picking up on the ground is developed using the CNN networks. But there is often chance, there is a very good chance that, of course, that we are seeing that happens, that in these complex details often get lost. Generally in areas of continued discontinuity and inconsistency in the ground, there is always a chance of data loss to the tune of 30 to 40%. And that is where the pitfall is. And this is where the real power of AI comes into picture when we go on to the generative super resolution. So these resolutions have been developed from one of the project sites in northern India. So what it does is it actually fills in the gap in the data through the generative power of AI. And so it actually, it learns, it develops its own labels. So now we are talking about what we call as the synthetic data, learning through synthetic data. So what we are looking at is two sets of algorithms competing against each other to come up with results which are generative and new for usage and for filling in the voids with accuracy. Then, I don't know whether it's very clear or not, but I'll try to show. So, some of the models which are used across the spectrum, which is the UNet and the residual net and the VGG. So these are the conventional models in the CNN domain or the CNN architecture that are used upon these DTMs. And generally, the accuracy at which the lithological mapping is done, or rather the data void is filled, is still, I won't say more than 80%, but the generative power of GANs, or what we call as the competing algorithms, we see that this is going to improve. So essentially what we are trying to do here is through these lithological mapping, data trained mapping, we are trying to figure out the geological structures, which includes the boundaries between the different rocks, sandstone, shale, granite, etc. So what we are trying to do here is we are trying to create different layers, and then we try to fuse them through a fusion model, which would actually help us develop the geomechanical classification and ground behavior types. So now the cornerstone of the whole process is the mineralogical mapping using the hyperspectral CNNs. Post 2018, ISRO has launched a satellite which actually develops these hyperspectral maps, HISIS maps, what we call them, which gives us an accurate prediction or close to an accurate prediction to the scale or a resolution of 0.5 to 1 meters of the ground stratification, which clubbed with the ground data that we have been discussing about would actually give a very accurate prediction of the geological reference model and develop the digital face logs even before the exploration and excavation is done. This is where we are actually working right now. And this could be opening of frontiers for the geological sciences beyond imagination, especially given the inaccessibility of a lot of locations in the Himalayan region where investigation is not possible, and the generative power of AI can be used to make accurate predictions. And when we're talking about accuracy, we're talking about an accuracy in the range of 97 to 98%, or even more than that, I don't know. So this is the mineralogical map. What you can see on the right side on this slide is one of the sample HISIS images that have been developed or has been taken out of ISRO's satellite, and that was launched in 2018. Nowadays, whatever HISIS images we are getting, they are even better than this and more detailed than this. But of course, the sheer volume of data requires a huge computational power along with AI ML algorithms to uncode them and use them for meaningful purposes. As I have already covered this part of the presentation earlier, that the model training is something that actually keeps improving the accuracy of the whole architecture. So given the huge volume of data that we are dealing with, and the labels that have been generated over the past 2 decades by the dint of observation and excavation that has already been done on the projects that have been completed. This is where this data comes in very handy in actually creating a better accuracy. So we are talking about the standard results, verifiable results. So as I have already addressed the GAN networks that can do the prediction part, bring out the accuracy and give the generative models to develop the digital face logs, the terrain maps with geological labels on it, geostructural labels, and of course, we have already covered this, and the fusion architecture whose output would be to supplement the modern excavation techniques in tunneling, that is NATM, through geomechanical classification or any kind of classification system that we want to build around projects that suits the requirement of the project and the local geology. Through a predictive 3D model. So what we are looking here is at the cross-section of a tunnel for which a predictive model, or what we say a digital face log, which has been predicted based upon all these labels and through the fusion CNN networks has been done. And this has been developed even before the excavation has been done or exploration has been done on the project site. This is one of the data visualization. So this is a data captured from one of the tunnels in Northeast for railways. So what you see on the left side, so these are all digital images, and the CNN networks are working upon these digital images to capture the labels or the representations, like what you see on the right side, the watermarks, the corrosion, the spalling, cracking on the lining, which can be augmented or used for the operation and maintenance purposes as well. So the key benefits are, of course, the increased safety, the reduced cost, enhanced accuracy, and direct application in NATM designs and geomechanical classification and predicting the ground supports. And of course, reaching the optimization. Thank you. Any questions? If there are, I would like to answer them.
Thank you very much, Mr. Singh. This was very enlightening, interesting presentation. When I started my career, we used to start excavation and then find out what is there. Sure. Anyhow, with the 70-80% accuracy of prediction of geological conditions, I'm sure will make our life much easier. Instead of working against the nature, now we will be working with the nature. Thank you very much, Mr. Singh.
Thank you, sir. Thank you.
Now, can I invite Mr. Sandeep Jindal, Mr. Sandeep Singh, I'm sorry, for his presentation on resilient underground spaces, leveraging stainless steel for safety, longevity, and sustainability. Mr. Sandeep, try to conclude in 10 minutes.
Working? Yeah. Yeah, good evening, everyone. Many special thanks to Indoria sir, Rahul Gupta sir, Bhubaneswar sir, and esteemed panelists, and the people sitting before us, this academia, industrials, and officials. Very, very good evening. At the very first stance, what Indoria sir has told, this is the time where we have to think of the space which is subsurface, because what we have done, we have traveled horizontally, traveled and going vertically. Now it's time to go deep down to sit on the top of this rapid urbanization. With this, I start the usage of stainless steel, which is green and sustainable, and how it is designed for the 120 years of life of the tunnels. Okay? Yeah. So in this, I am going to present what is the business scenario or the total tunnel length which is expected to come in down the line 5 or 10 years and other parts also. So with the paucity of time, what I will do, in coming years, we are having approximately 3,000 kilometers a tunnel, which is already proposed for the irrigation, for this railway, for this highway, and for the other purposes, which is a sectoral and this state-wise different portion is given. So before starting, I just want to discuss what is the environment of the tunnel. If we see from this, what we have done this, we have taken some reference from the European tunnel. If you see the tunnel humidity, temperature range, SO2, NO2 and H2S, these all combines and creates a very corrosive environment inside the tunnel, which actually kills the material. So in that circumstances, which kind of material we have to use, we have to be very judicious at the time of the approving, at the maybe DPR only stage only or other procedure of the time. With reference to all, in such corrosive environment, if we see which kind of material is approximate and we can expect a better life for that particular application. So in that case, stainless steel we all use. If you use utensils, if you go for this nuclear power plant, other critical application, and this rocket launcher also we are making high nitrogen steels. They all are from this stainless steel group, and they are performing and coming up to the expectation of various corrosive environment, which is very critical for the long life of this project. So I'm just going to discuss what type of issue of corrosion in tunnels and related to the accidents. If we go to this Satara-Pune highway, this is Khambatki tunnel. This MS, it is clearly written that this corroded MS channels has fall on the trucks and this cars, which is very, very dangerous. So in India, what we are doing, when we are designing any tunnels, we are also taking the extreme condition. We are not working on the only standards, this will not happen. But we also take a condition, extreme condition, this may happen, accordingly we are designing the things. So this is not the story of India only, where this corrosion is killing. In abroad also, there are some cases of this corrosion and related accidents is there. This is with some pictographic, it will become. This sir is sitting just in front of this Mumbai Coastal Road project. We have seen this water seepage. Water seepage is the natural process. It will be there in the tunnel, but we have to manage when water is coming, which kind of water is coming and where it is flowing. When it is going and touch certain portion, some components, definitely it going to impact on the life of this product. This is some of the pictographic you can see. Normally what happens, we were working with this rights for this Calcutta Metro Rehabilitation Project, where we have seen number of corrosion issues were there, say this cable hangers and other rebars were there. So what we have done, we normally request why we are calling at the time when the damage has been already done. If we have been called again before this finalization of the design, we may delay all this process. This damage will be normally can be delayed by more than 100 years, what we promises with this material. This is another, this rebars is also there. So this is, I am giving one example of this railway tunnel, where this North Frontier Railway, we have visited one tunnel and we have seen this tunnel was not even operational. After the installation of this entire cable tray and all these fixtures got corroded. It doesn't mean this corrosion was there. We have to pull it out, and when we are going to pull it out with all those fasteners, this waterproofing membrane was also damaged. This was killing the entire process and delaying the operational efficiency. See, we have identified this issue before the operations. Once this will be operation, it will be gonna very, very tough to operate and maintain. They are some of the issues. This is galvanized one. I am just running out. Why stainless steel? So any material, any iron which we are going to add 10.5% chromium, it becomes stainless steel. And how it works? If we see, it doesn't have any, this coating and all. It has already chromium oxide coating. So how it works, if you see, if any scratches will be there, the chromium inside from the oxygen, it will make a chromium oxide layer. So no repair. It is a self-repellent or this protection layer is there with this material. It will be not in the case of any material which is having coating, any type of coating. I am just taking the slides. If we see, Professor Arnold Dix has rightly mentioned all these fire issues in the tunnels, and it was well noted that if we are going to design the fire load, maybe 50 megawatt from the initial stage, we have to very particular about selecting the material, which kind of material is going to use, which is exposed to the tunnel and inside the tunnel. Maybe some fireproofing paint also will work. If you see this, material wise, this is stainless steel, carbon steel, aluminum and fiberglass. We can sustain up to more than 600, 650 degrees centigrade, where my means stainless steel, this structural strength will not lose, where this mild steel and other fiber FRP will lose at the 60 degree. FRP will not lose this initial stage. It will further augment the fire process. It will aggravate the fire. Some of the accidents has already been discussed. I just run one video. This is a recent incident where we have seen this Green River Tunnel. Entire structure, what is exposed is the secondary item, internal this rebar and all got damaged. So if you go for the repair and rehabilitation point of time, it will take a longer period to properly rehabilitate and all. So it will not only this other material which is hanging with this 200 degrees centigrade, which is actually dehampering this evacuation process also. So if we particularly talk about what all materials are going to be used in stainless steel, we started with this cable tray. Now again, this so many officials and this consultant had asked us to develop this electrical panel, rebar, fire door, dampers, and duct ventilation, railing, fire mist, rock bolts. You will see this kind of products which is already there. This is not developed. This has already been used in railway, in highways, in other tunnel or underground space like caverns and all. Like fire pipe, duct, ventilation system, dampers, electrical panel, fire doors, this enclosures, rock bolts, this wire mesh lining. I am just going to give one example of USBRL railway tunnel where everything which is exposed, maximum item is of stainless steel, and that stainless steel was used, which will give a promise up to work or sustain up to the design life of the tunnel, which is approximately more than 100 years. And what product is going to this already is there in BIS. So these are all the designs. So for Jindal Stainless, what we have done, we have not only supplied the material, we have developed entire ecosystem which can actually fabricate and supply quality material to the tunnels. So these are some processes. In tunnels, there are some curvatures. At the site, it is very tough to cut and weld. So what we have done, some technological advancement, we have done this. Some bearing system, what we have done, at site, no cutting bending is required. It can be automatically installed as per the site condition. These are some of the products which are being developed. It's not like we are just wanted to develop because the consultant and the government is also willing to have that kind of product. This lining, this girder we are trying to develop. This girder is trying to develop because we have already made stainless steel foot over bridges with this IRSM 350 grade, which is very cost effective. For that material, we are going to use this kind of girders. And why we are saying this? If you go to a stainless steel with this mild steel to a stainless steel, approximately 30% approximately weight reduction is there. So whatever cost is collected, this 30% weight reduction will actually compensate some of the portion of the increased value of the product. This is reinforcement. We have already several or various examples of using SS rebars in the various European tunnels. I will simply escape this. What I am talking, it's already there in this BIS. Now, very interesting thing, when we are there for this bullet train, this segmental, this plate or the bracket was being developed, And one case study where we found, if you use this stainless steel corrugated panel in between, so we can reduce the 3 mm thickness of this concrete to 250 mm thickness. This is being discussed with this IIT Roorkee, and we are working on this, how this 50-70 kg of the using this panel can reduce the actual width of the 300 to 250 mm, which is a huge cost saving. So we are still under working with various organizations. These are rock bolts. This NHPC have called us for one of the product they are going to use this. I'm just running the slides. Fire doors. This electrical panels in the tunnels. Signals we are developing. This is fire door and dampers. Now this is a trench cover. What we have done, seeing this, we have developed one 1.5 mm corrugated sheet with the entire 1 square meter load is hardly 22 to 30 kg. So we can use this. And per square meter approximately load bearing capacity is 250 per kg. Some of the places it has already been used. This Calcutta Metro, we are displaced this SS hangers. This earthing strip is there. Now ventilation is there. Recently, this Dwarka Expressway has got this ventilation jet fans. If you see this middle of the picture, what we have cleaned, the outer case was of this GI 0.6 mm thickness. So what I request to the officials and obviously sirs also, when we design, we only not only functional or this functional behavior or the properties, we can also have the material selection. If we that kind of product which will no and transportation it will do damage, so we should normally avoid this. If you go to the right side, this Visakhapatnam highway tunnel, it is all stainless steel with 2 mm thickness. It will give a life of at least 100 years with the material, and the functionality it will make 34 years. This is some of the cases we have used this. Jet fans, this conduits is there. In Mumbai Coastal Road project, we have seen this entry, lots of stainless steel, this entry and exit, we have used this. We have not used mild steel because of the coastal area and other things. This firefighting, this water mist system or the dilution system, we are going to use this stainless steel pipes, duct system. There are many other projects where all these materials have already been approved. In this CITCO, this tunnel is coming, where all these products is already there. So one misnomer is there that when we are going to use a stainless steel, it will be a higher cost. So definitely, when a stainless steel there, it will have some cost. How we are going to mitigate this? If you see this cable tray, we are using normally 2 mm thickness. What we have done, this corrugated panel, 1.2 mm thickness will give the suffice load which we can have with 2 mm GI thickness. So approximately 40% weight reduction with this design innovation. So this way we are going to reduce the price or the cost, overall cost. This maintenance strategy is already there, so no need to discuss. This is the very complex and the actually required process of this PR comprehensive tunnel maintenance and inspection workflow. If you have that kind of material, this the periodic maintenance will definitely going to be lesser on that part.
If you could wind it up quickly, please.
Yes, sir. Just last one, sir. Some circulars are there already where it is, it clearly mentioned that we should use a stainless steel. If you see the circular on 2018 itself, there where they have used to use SS rebar in tunnels in the coastal areas. This Ministry of Road and Transports also, in these bridges we are using this. So in Jindal, what we are doing consultancy, design support, raw material supply, value addition, and support to contractors. Some tie-up with this MIT Pune, IIT Jammu, this collaboration with this Gati Shakti. So at last, what I am going to do, I am just this message was there, Srinat Gadkari sir, we are very happy. He also recognizes the use of stainless steel. Here we can see. Volume. Can we have volume there? This is the use of stainless steel. Here we can see.
मुझे मूर्ख बनाया उसने एक पाउडर कोटिंग करके
Volume.
रख क्या लोहा देख के बोला ये रस्ट नहीं लगेगा और मैं विश्वास रखा लगा रस्टिंग हुआ तो अभी
Can we
ऐसा
have
है
volume?
कि जहाँ 30 किलोमीटर समुद्र के बाजू में है वहाँ
Use of stainless steel.
स्टेनलेस
Here we can see.
तो शिवाजी का पुतला उसने एक पाउडर कोटिंग करके रख क्या लोहा देख के बोला ये रस्ट नहीं लगेगा मैं विश्वास रखा लगा रस्टिंग हुआ तो अभी
Can we
ऐसा
have
है
volume?
कि जहाँ 30 किलोमीटर समुद्र के बाजू में है वहाँ
Use of stainless steel.
स्टेनलेस
Here we can see.
वो शिवाजी का पुतला उसने एक पाउडर कोटिंग करके रख क्या लोहा देख के बोला ये रस्ट नहीं लगेगा मैं विश्वास रखा लगा रस्टिंग हुआ तो अभी
Can we
ऐसा
have
है
volume?
कि जहाँ 30 किलोमीटर
So what sir is saying, that for the use of stainless steel in this nearby the coastal area 20-25 kilometers, we should use stainless steel. And with this all, I thank you once again, and thank you Rahul Gupta sir for giving insight and taking this tunneling industry from the Ministry of Road and Transport and supporting all of us and guiding us. Thank you once again. Yep, thank you.
Thank you very much, Mr. Singh. One could not have overemphasized the use of or advantage of using stainless steel. Can I now invite Mr. Lal Mani Singh from Border Roads Organization? He is going to talk about tunnel safety from concept to operations. Mr. Lal Mani Singh. 10 minutes, please, Mr. Singh.
Respected chair, co-chair, my friends and dais and up the dais, ladies and gentlemen. Nowadays there are so many tunnels which we are constructing. There are so many tunnels which are in the operation and so many tunnels which are in the pipeline. And in India, we have explored the surface, we have explored the overground. Now the time is for the underground. When we are doing the work in underground, the safety is the paramount because we are doing the work in an enclosed area and so many machinery, so many manpowers and so many things are within an enclosed area. So if we are not listen to the ground and we will not do the work as per the norms, so it is very difficult to survive in this type of environment. So this is the one quote. It is my firm belief that the Mother Nature is so kind, and if anything is going to happen, it will always give the indication to the people. If we listen that voice, it is very, very fortunate that we have to give that there is no incident will occur if we listen that Mother Nature. Because, for example, if we are see that there is a collapse, before a collapse will happen, there is an indication of cracks. That cracks will always happen and a small patch will always fall down. If we listen that, it will never be any collapse. And if we see that in case of their host rock there is a water, then there is a leakage is also seen. If we listen that thing, then the water ingress or the running ground condition will not happen. I will just give the presentation on this sequence. Firstly, just one brief of the BRO. It raised in 1960. This is the only organization which do the work departmentally. It is till 2015 it was under the MRTS, now it is MOD. We have completed with 9 tunnels of about 16.74 kilometer, including the Atal Tunnel Rohtang. There are 3 under construction tunnels, about 8 kilometers. And we are 13 western sector, 5 in eastern sector and 1 in Bhutan. That is about 19 tunnel in the pipeline, which is about 95.14 kilometer. This is the Uniform Cadre Execute works departmentally, ideally for challenging terrain, unfavorable climate, and difficult security situation. It has the inbuilt capability of redistribution of resources, so it is the military ethos and technical expertise which known as border organization. Tunnel safety should be in the holistic, and it should be a continuous process. It should be the system built, not it should be the any layer at the time of work or at the time of when we are going to work. It should be in the each and every steps, that is the conceptual stage, that in DPR stage or in the design stage, where is the construction stage, each and every stage should be inbuilt your safety precautions. Otherwise, the tunnel will be very dangerous. Safety must be built in, not bolted on. Means it should be the system based, it should be the process based. It should be each and every layer of your work, it should be built in. Safety provisions are based on tunnel length, traffic volume. If we are, suppose, want to avoid the collision and vehicle breakdown, your horizontal or vertical gradient should be so smooth. If you want to air quality of good one and there is any happening of the fire, we have to have a good ventilation system. Your lighting system should be such that it will be light each and every corner of the tunnel, especially in the entrance and exit. Then power supply, you should have the redundancy for the reliable power in all the system which are the critical. Tunnel safety can be ensured only, and this is only done if everyone responsible for their own safety. If everyone has their own safety, then it will also help to the other people which can be safe. All accidents are preventable if you are follow the rules and you do not take any shortcuts and always follow the rules. This safety can be ensured and no accident will take place. If you are not trained, then take a training before you work or you do not work. If you use the right tool at the right time, at the right way. If you want to save, assess the risk before approaching to work. If you are going to work anywhere, you should know what are the risks, is there. Suppose we are going to in the tunnel and it is chances that anything will fall on your head, you should have wear that hard hat. So if you want to go anywhere, you should assess the risk and then go to the. Never wear loose cloth and slippery footwear. Then don't indulge in the horseplay while the work. Always practice good housekeeping. It is a very, my own experience that during the construction of Rohtang Tunnel, there was no incident taken place because of the housekeeping was very high standard. So if you are keeping your tunnel clean, then there is a less chances of any accident or incident. Then always wear appropriate PPE. When we talk about the safety, and if it is, I am saying that it should be the system driven, it should be the process based, then it should be done at each and every place at the planning stage. When we talk about the planning stage, our tunnel should not go below any monumental structure, shear zone or fault zone, water bodies. And if it is necessary to go from there, you should give the geotechnical investigation in such a way these can be find out at the early at the your DPR preparation stage, so the things will in place. If there is a requirement of suppose within we are going from the monumental structure, your observation or the deformation should be negligible. If you are going to shear or fault zone, the things like pipe roof all are in the place so that you can go and do the work as per the requirement. And if the ground condition is such that it is the leveling or running ground or a squeezing ground or the rock which is of the your spelling or rock brush nature, you should not go. But if it is necessary, we should go. Suppose there is a rock brush, you should give the, means do the hole to release the stresses. So better it will be, we will not go from there, but if it is necessary, if it is mandatory, if you are going, then the things should be on place. And this groundwater, inadequate geological analysis can lead to unforeseen hazards, poor ground condition, turn require additional support, and specialized machinery which can be put for the geotechnical baseline report is the one thing which can you're allocating this means GBR, you can avoid the dispute over the differing site condition, and you can avoid the cost and time delay. Because if there is a dispute, it will naturally will take the time and will take also the cost. Cost optimization in planning achieved by allocating budget to risk mitigation measures that have greatest safety. If regulatory compliance, you should know the local and international standards for the regulation, because it can go your legal liability and it will lead your time and cost delay. Then risk assessment, we have to have the risk assessment for each and every whose likelihood and how it will cost and how it will go in the, so each and every part of your tunnel should be assessed, and accordingly the system should be in place and the safety strategy can be adopted. At the design stage, you should know on the basis of the horse rock, on the basis of the ground which we are seeing, whether we are going with the excavation with the drill and blast method, where we are going with the TBM method. Suppose your ground is like a uniform ground, you can go with the your TBM system. If there is a change of ground, then it is necessary to go with the drill and blast method. Then appropriate support system to be given before the excavation is started. Because if you are giving the less support system or higher support system, it will cost and it can delay also. So robot ventilation system, if you are giving the safety to the man, to the machineries even, which is working within the tunnel, then your ventilation should be in such a way that it will give the required oxygen to the man who is working there. Strategies of groundwater management. So the things will in place if there is a requirement of dewatering system, and your tunnel should be lined. Nowadays, now the ministry is looking that each and every tunnel should be the waterproof, but if it is water, means there is water, it should definitely be the lining, a waterproof lining. Adequate resources should be given in the DPR, because if you are having some time, extra time, some money, then we can take the challenges which is coming at the time of excavation. Then emergency responses and evacuation plan, as we know, anything, any means your system cannot be foolproof, so your emergency response plan should be in place. At the construction stage, there are safety of man, there are safety of machineries, there are safety of the structure. So if we are at the time of construction, so you should instruct or you should implement that every person should be wear appropriate PPE, then regular safety meeting and toolbox talks, workers to aware the ongoing risk and enforcement protocols. So this is mandatory that at the every day there should be the safety meeting, and the people should be taught about that. Structural safety and ground control. Your collapse is a primary safety goal. During excavation, immediately install ground support to stabilize the ground at the time of excavation. Regular geological mapping is required for your safe and stable tunnel. Then
Mr.
continuous
Singh,
monitoring.
if you could conclude quickly.
2 minutes, sir. Then continuous monitoring for ground and movement for lining. Then your fire and prevention. Fire is one of the gravest danger of the tunnel construction because of the confined space. So limited area. On-site fire protection include having protector and alarm should be, the rescue chamber with the fresh air should be there for any incident, and there should also be the alarm system. Emergency escape provision should also be there. Suppose in the case of any eventuality, there is a collapse, the pipe, this evacuation pipe should be installed. It is in the code, but normally people do not implement on the ground. So it is requested that these type of things to be implemented on ground. Then operation stage, the traffic operation. You know that operators may impose the speed limit, automatic incident detection that can intervene for the congestion of the traffic. Then hazardous goods which can be allowed or not allowed, that is required to be seen. Then monitoring system and tunnel control, CCTV camera, smoke detectors, linear heat detection, cables, air quality sensors. These should be in the place. Communication system which allow driver to receive emergency message, public address speaker. So these all the systems should be in tie with the SCADA system, and then fire detection and the emergency egress of the response preparedness should be there. Then all the systems which are placed in the tunnel, its maintenance is the most important thing, because when we see that these are the system, when we put there, it is working, but any eventuality will not happen daily. So after 6 months, if it is required, if it is not working, then there is no use of placing such a system. So it is very necessary to maintain that equipment, that material which are put in the tunnel. Then you are minimizing the downtime and ensuring our safety system are 100% operational when it is needed. Conclusion and way forward, building information, modeling, sensor network, continuous monitoring should be required. Then predictive analysis using data to forecast equipment failure, and for the future your tunnel design, regulatory audits, independent third party is required. Then safety culture, fostering a positive environment where workers and operators feel empowered to report the hazard, and comprehensive framework treats safety as an investment, not an expense, requires integration across all stages. So call of action is continuous improvement is not negotiable. Regular reviews and adoption of the ERP-based global best practices are essential. So it is my humble request to please, everyone is knows, but you have to implement is the ground. If you implement on the ground, the safety issue can be checked and there not any incident will happen in the tunnel. Thank you.
Thank you, Mr. Singh. Very insightful presentation. And we have high regards for Border Roads Organization because they always work in hostile conditions, physical or social. So thanks a lot to Mr. Singh and also BRO. Thank you very much. I'll now invite Mr. Saurav Shekhar to present a case study on Indora-Digori flyover. And Mr. Saurabh, if you can do it in 5-6 minutes, thank you. The other session has to start.
Yes, sir? थोड़ी बड़ी है. MB की सर 500 MB की फाइल थोड़ा टाइम तो लगेगा.
प्रेजेंटर ठीक है, प्रेजेंटर व्यू में आता है ना, इसमें नोट्स आते रहते हैं.
हाँ यही तो दिया, यहाँ पे नोट्स आएंगे लेकिन
Respected members on the dais and fellow IRC members, first of all, I'll take the gratitude to the chair and the co-chair who has given me the chance to speak on the subject. And selecting this topic for the IRC Odisha was a reason because this is a land where we have rivers and long bridges. So, ultra-high performance fiber reinforced concrete, we have been hearing for long. And this is one of the projects where a 2.5 kilometer section was constructed. And this is in the world, this is the biggest flyover with UHFRC. This is total length of 8.9 kilometer. Purpose is to decongest the Nagpur city, and it connects the congested locations of Indora Chowk, Agrasin Square, Ashok Chowk, Kamal Chowk, Mande Plot, and these places. The time with this elevated structure has reduced by 50%, and this has been used because instead of conventional concrete, it has been used for longer spans, slender sections, and superior durability. Further, it helps us to address the site constraints of multiple junctions and limited support locations, ensuring the structural efficiency and long-term performance. Since I am observing the next panel team is also there, so I'll be reducing this whole presentation. So I'll not be going for this video, and I'll continue further. So here, the 34 spans of 60 meters and 2 span of 90 meter has been used. The 60 meter U-girder with this new technology weighs somewhere around 200 tons, and 90 meters weighs somewhere around 400 tons. In contrast, when you go to the conventional, the weight is somewhere around for 60 is somewhere around 1350 tons against 850. So you can understand the load which is getting reduced, and this helps us in the economizing it, this thing. So, ingredients required for UHP FRC are cement, silica fumes, silica sand, water reducer, high strength steel fibers, and ice. And the cement, as you know, is the primary binding phase. This thing, silica fumes and microsilica fills the micro voids and reacts positively with calcium hydroxide to produce this gel, increasing the strength and reducing the porosity. The steel fibers, they are basically bridging the cracks and provide the post-cracking tensile resistance and ductility. The tensile strength is greater than 2000 MPa. Diameter of these fibers is 0.2 mm, and the length generally is 13 to 16 mm. Compared to the conventional concrete, it eliminates the aggregates, mainly uses steel fiber as the reinforcement. Steel bar is optional. Concrete cover is not compulsory. Honeycomb always impossible, and highly workable and flowable and moldable. Corrosion is not possible. It is a combination of self-compacting concrete, fiber-reinforced concrete, and high-performance concrete. So this is how the concrete technology has increased from the normal, where the characteristic strength used to be 50. Today, this ultra-high performance concrete is providing strength more than 140. The stress-strain behavior of this UHP FRC is much superior than the conventional concrete, but inferior to steel. Similarly, the flexural strength is also far superior. The strength, what we get is more than 150 MPa. In my project, it was somewhere around 180, 190. And 4 to 6 times superior strength than the normal concrete. This is a section failure, how it looks. The uniformly, you will find the steel fibers there. This is the X-ray, how it looks inside. The high workability and low water to cement ratio, high workability makes casting easy. If I show you this video, I still remember this is the way you can see. इंदौरिया साहब के एक प्रोजेक्ट पे मैं पहले एक बार गया था एंड उनके एक प्रोजेक्ट मैनेजर ने कहा मखमल की थान की तरह निकल रहा है कंक्रीट, which I cannot understand that time. Now I understand seeing this. This commonly used sections are 4 meter depth for up to 100 meter. 70 mm span तक के लिए 3 meter depth इनमें we are achieving it out. And sequencing, this is casted in factory, transported, assembled there, post-tension, launching, and deck casting. So time is, you can control the time, the quality can be controlled, and in the factory you are making. So you can think of making it in different states, different factories, and controlling the whole construction from one place. I'll move in these slides. This is how their presence is there all over the world. In India, they are doing numbers. These are a few of the projects in India where this work has been done. And as far as the costing is concerned, from the conventional, it is costlier, but in the total cost, this is cheaper. For example, for a 1 kilometer in our project, a 60-meter span, if we use this one, was costing 43.71 crore per kilometer compared to 47.7 for a conventional structure. These are a few photographs from the site which we are discussing. So this is a technology which will be there in the coming days, and I suggest we should be looking forward for more projects to do with this technology in Odisha, as here the long spans we are finding a lot common. So with this I conclude, sir.
Thank you, Mr. Saraf. This has been a very interesting and engrossing session with so many insights on underground structures. Very useful indeed for all professionals, highway professionals and structural engineers. And I will now request my co-chair to put his concluding remarks.
Thank you very much, sir. First and foremost thing, we have very engaging session, especially the presentation from Arnold, Dr. Bhaguna, Shwetab, Lalmani Singh, and Mr. Sandeep. They were unique presentations, and it is first time under the agencies of Indian Road Congress, a dedicated session has been scheduled and conducted for underground and tunneling structures. So I am grateful to my speakers and presenters for giving an enriching presentations for the benefit of the audience, and whatever they have presented, they will be taken on board by the technical committees in formulation of the standards. Thank you very much. And we have already exceeded our time, so now I'll request the next session chair to please kindly take over, sir. Thank you very much.
Sure. Thank you so much. The chairman of the session, Shri R.P. Indoria ji, and of course the co-chairman of the session, Shri Rahul Gupta ji, requesting everybody to please stay with us for a few more minutes. And now, I would like to request our chairman of the session to give the memento to our presenters. So, I would like to request Dr. Harish Bagunya ji to come a little bit forward. Can we have the moment, please? Expecting some clap from the audience, of course. Next, would like to request our respected chairman, sir, to felicitate Shri Shatav Singh, co-governor, G2 committee. Next, would like to request Shri Sandeep Singh ji to please step forward. Now, I request the co-chair of the session, Shri Rahul Gupta ji, to give memento to Shri Lalmani Singh ji. Next, I would like to request Shri Saurav Shekhar ji to please come forward and receive the memento from our respected co-chair, sir. And now I request Engineer Shri Gaurang Charan Sahu to please come on the stage. Chief Engineer, Retired Works Department of Orissa, to felicitate our respected Chair of the Session and Co-Chair of the Session. First, we are going to felicitate our respected Chair of the Session, Shri R.P. Indoria ji. Thank you so much, the Chair of the Session, Shri R.P. Indoria ji, along with Co-Chair of the Session, Shri Rahul Gupta ji, all the representatives. Thank you so much for your valuable time. Well, we are starting off the technical session 12. We just need 5 minutes for the setup. So requesting everybody kindly get ready. Well, the panel discussion on cost optimization on road project, that is our topic for technical session 12. We are starting in 5 minutes. Thank you. Ladies and gentlemen, we are about to begin the technical session 12 within few minutes. So requesting all the panelists to please be ready, be prepared, and please be present near the dais. We'll shortly start the technical session 12. Thank you. Sure. Namaskar and a very good evening to all the ladies and gentlemen. I would like to welcome everyone for the technical session 12 on panel discussion on cost optimization of road project. So let me take the honor and let me introduce the moderator for the session is Shri D. Sarangi, Director General, Road Development, Special Secretary retired for Ministry of Road Transport and Highway. Let's give a big hand and let's welcome Shri D. Sarangi sir on the dais. Namaskar sir, welcome. Now I would like to request Superintending Engineer, Works Department, Government of Orissa, Engineer Anuradha Meher Madam to please come up the stage And she's going to welcome our respected moderator for the evening with the flower bouquet. Thank you so much, madam. Now I would like to invite all our panelists to please come on the dais. Shri Akil Ahmed, Senior Engineer, Ministry of Road Transport and Highway. Let's give a big hand and let's welcome him. Welcome, sir. Shri Chandra Ravi Shekhar, Chief Scientist, CRRI. Can we have Shri Chandra Ravi Shekhar, Chief Scientist from our CRRI? Next panelist is Mrs. Arundhati Sharma, Superintending Engineer, PWD Maharashtra. Namaskar and welcome, madam. Next panelist is Professor Bhargav Maitra, Dean, SAIIT Kharagpur. Let's give a big hand and let's welcome sir on the dais. Next, we have Mr. Jumo Seong, KC Long-Term Expert to NHAI Korea Expressway Corporation. Namaskar, sir. Welcome. Next, we'd like to welcome our panelist, Ms. Atashi Das, Assistant Vice President, GR Infra Project Limited. Welcome, madam. Now I request Shri D. Sarangi sir, our respected moderator, to start this panel discussion with his opening remarks. Thank you.
Actually, I am having a small presentation. Please start that. Very good afternoon, good evening to all the delegates. We are quite late. Initial time schedule for the panel discussion was 2 hours, but looking at the mood and everything, probably we'll try to compress it to 1.5 hours. Cost optimization is something which bothers each of us who are in the sector, whether in service, whether rated, whether contractor, whether consultant. It is something that bothers everybody. When we joined service 35 years back, there was very little use of this term cost optimization. It was there, but very hardly used because budget was less, and to sanction a project, it was sometimes taking years. But later on, there was funds availability for highways, very enormous scale. Now we are spending around 3 lakh crores per annum. And if by virtue of optimization there is 1%, 2% savings to that, that makes a lot many things. In that context, particularly when we started with PPP projects, EPC projects, this term tried to gain a lot of weightage with contractors, with consultants. But there are many misnomers. We have a very distinguished panel list today evening, and each of them will be dwelling into different aspects of the cost optimization as we have interacted beforehand and we have decided. I will just give a brief overview, then each of the panelists will give their opinion, their views. I have restricted the time, initially thought of 15 minutes, but now I would request them to stick to 10 minutes. And after that, there will be a question and answer session of around 15 minutes. When I was asked by IRC to chair this session, and yesterday only, I thought what could be the best definition of cost optimization. I made a lot of search in Google, and this is the one which is in the screen. I hope everybody is seeing. So cost optimization refers to the process of reducing and managing expenses while maximizing value and efficiency. Of course, we should get the proper value for our money. It involves identifying areas of unnecessary expenditure, finding cost-effective alternatives, and optimizing resource allocation to achieve the desired outcomes with the least amount of expenses. All said and done, I have tried to highlight the desired outcomes. There is no compromise on the outcomes. If you say by virtue of cost optimization, you do something which is not giving us the outcomes originally intended, then it is not cost optimization, it is something else. Unfortunately, that is happening in many cases now. So it's very clear to my mind and to, I believe, everybody that there is no cost optimization by compromising the outcomes. Now, next slide, please. Next slide, please. See, these are some of the outcomes in the context of road projects. What do we want of a road? It should provide fast mobility. This must provide us safety. Somebody traveling on the road must be making a safe journey. It has a structure, whether bridge, whether culvert, whether underpass, whether pavement, protection work. Everything is a structure in some or other sense. It must have the required strength to withstand the loads, and loads over a period of time. It's the fatigue loading it must take into account. Then functionality, the users have certain requirements. The functionality requirements should be duly met with, and it has to be durable. If a road has been designed for 30 years, concrete pavement, for 30 years it must provide the services at the intended rates. The performance parameters should be continuing up to 30 years. Then there are two things which are very, very critical and widely discussed in all international forums at present. One is sustainability and other is resilience. So any project, any infrastructure that we want to build, this cannot lose sight of these two requirements, sustainability and resilience. And when you are benchmarking these outcomes, this is not over the construction period, but it is over the whole life cycle of the project. That's the most critical point. Next slide. So how to do it? One way is recycling, using locally available waste material, marginal material, with or without treatment to the maximum extent. Again, this must meet the requirements of the applicable standards of IRC, BIS, or any other standard that we are following. Leveraging technology. I'll just give a small example. 20 years back, if a bridge is damaged, we are trying to repair, rehabilitate it in the best way possible, because funds were also restricted. With the advent of these big projects, consultancy services, there is no time for anybody in the client departments to go and see if a bridge is really damaged or not. Many times I have seen consultants feel very good excuse if a bridge is slightly damaged, instead of repairing it, rehabilitating it, to go for its reconstruction. This is certainly not intended. This way we are compromising the optimization of cost. So this is just one example I gave. I think other panelists will give multiple examples. So technology is one thing that we have to leverage to reduce the cost, and of course by use of efficient management practices. So these things can bring down the cost of construction, bring down the cost of maintenance, bring down the cost of operation, and in a sense it can also bring down the vehicle operating cost, which is applicable not only for construction but for the users as well. Last slide, please. Okay. So what we have been noticing usually in many contracts towards the last maybe 5-10 years, there is an effort to redesign by using some dubious data from surveys and investigations, where when we started the EPC contract, the thrust was that it will be the contractor's design and the client will give only the broad scope. That is the intent of EPC contract, and for that matter in PPP projects as well. But later on we started giving one particular thing that the pavement design should be for a certain MSA. Why? Because we did not have the confidence that if it is left to the contractor, then it will be misutilized. Some traffic data will be produced where if it is actually 1500 commercial vehicles are going, it may be shown as 1000 or even less than that. So redesigning with dubious data from survey investigation is not cost optimization. Cost optimization is not about arbitrarily using materials. There are standards developed by IRC for certain new materials which has not been very popularly used. Nobody disallow anybody. But then when you use certain type of material, even the trial section is a fundamental requirement. In the trial section, its performance should be assured whether we are able to properly compact it or not and what other difficulties we are going to face. But many times that is not done and the material is straight used. And after all, it is the life cycle cost that is the deciding parameter. So with this opening remarks, I would request my panelists one by one, and looking into time constraints, I would request each of them to give their presentation or views. I think most of them have presentation limiting to 10 minutes time. First, I would request Sri Akil Ahmad. He is a SE in Ministry of Road Transport and Highways. He has been superintendent engineer for 11 years. He was in NHI for 15 years in capacities such as manager, DGM, and general manager. He has a very rich experience in contract management. And in fact, I have seen his potential when, before my retirement, I was in ministry as DG for our Orange Book modification. So he was directly reporting to me, and I found his knowledge and energy in bringing that to SEP. So he will be talking on MRT's guidelines on value engineering and cost optimization. Please start.
Thank you, sir. Moderator sir, and my co-panelists and respected members. Sarangi sir has set the tone for this presentation or this session, and he has put up everything which I will take action from the government side further. Okay, what government will be doing for the cost optimization. As far as cost optimization is concerned, we are facing the double problem. One way we want to reduce the cost, and second thing is we are getting so low bid. We want to increase the cost, or we want to identify what is the issue where we are lacking. So for that, government is issuing many guidelines to balance the things. What is our scope and what we are going to achieve? Honorable Prime Minister has given the vision to 2047 for development. And in line with that vision of Honorable Prime Minister, Ministry of Road Transport has also developed its 2047 vision, which include access to high-speed corridor, 100 to 150 kilometer to all citizens. India to rank among the top countries in G20, high-speed corridor density, equitable access to national highways, underdeveloped region, improve passenger convenience with world-class passenger amenities, reduction in logistic cost as share of the GDP. Considering this ambitious development program, cost optimization of road project is necessary to achieve the value for money, whatever we are spending. On the other side, cost optimization is not just about the saving money, it is about building a more sustainable, more resilient and more connected India faster. And Ministry is issuing very guidelines and working on this aspect. which include smart planning at the time of designing. We have to improvise, do the value engineering. For this, we have issued the value engineering guideline. Sustainable material, which can be sustained long-term, environmental friendly, and then efficient execution of the work by using the modern technologies, just as AI, drone, GPS implementation. Value engineering, Ministry has issued the guideline in 2024, 20 September 2024, which talked about detail this value engineering. As per that guideline, value engineering mandatory in DPR TOR. At the time of DPR, we have to make a chapter about the value engineering, in which design, material and reduction in change of scope have to be addressed. And now proactive land acquisition, because due to delay in land acquisition, cost is being increased, that is known to everybody. So this is being done, guideline has been issued for 90% land compulsory. Realistic bidding norms for low bids and everything, Ministry has issued this additional performance security circular 2025. For the low bid, we have to give the additional performance security. Alignment optimization, we have to optimize the alignment using LIDAR, satellite imagery, drone survey. All these are the part of this cost optimization. What is value engineering? How we are going to define it is the lowest life cycle cost, enhanced durability, and speed and sustainability. Performance-based bidding, as per this guideline, for value engineering guidelines, Schedule B and C, now crest thickness is not to be provided, only the detail, specific composition and to provided. Type of payment, design, speed, and MSA is to provided. DPR consultant also indicate a chapter for the value engineering potential in inception report itself. And this SFC memo and PETSC memo also, we have to provide the paragraph on value engineering as per this guideline. Then contractor has to free to adopt any technology, any value engineering alternative, and they can retain the savings. So this is the benefit it is given to the contractor. Code compliance, all material has to be complied with the IRC guideline, MORT's guideline, S2 and other guidelines. Trial section is compulsory. As per this guideline, you have to prepare a trial section if you are using a new technology. And if some proprietary item being used or some technology being, then they have to make a agreement with the technology provider who has to provide the guarantee and who has to define what they are going to give, what support they are going to provide. And AI has to review all the new technology. Innovation is also part of this, and it includes the many innovation ministries doing and allowing the innovative technologies, fly ash, pond ash, slag steel, plastic and rubber waste we are using, geosynthetic stabilization, reclaim, asphalt pavement. This is also part of sustainable material, recycling, RAP, industrial waste we are using, waste material are being used. Honorable Minister, he always talk about improving this situation to use the maximum waste material, geosynthetics. Alternate designs for pavement, perpetual pavement, bonded concrete pavement to extend the life, soil stabilization, as it is also part of 15% CBR we can design the subgrade and precast element and warm mix asphalt. These are the advanced technology proposed as per that circular. Efficient execution for reduce the cost during the execution. Project management tool are being used. NHI extensively using the drone and LIDAR is being used. And GPS in new RFP we have introduced all material and all trucks will be GPS fitted, and that report has to be provided monthly about material movement and everything. That PM Gati Shakti portal for monitoring purpose, Bhumi Rashi portal for land acquisition, and the contract document are being already standardized and they are being further revised. Land ROW issues, key challenges what we are facing, still it is there. ROW and land acquisition delay, statutory clearance that takes time, and contractor performance, low bidding also creating time, because of which they are facing the financial issues, limited capacity of some contractor to take up the project. So this is leading to the cost escalation. And then how we are overcoming the bottlenecks, PM Gati Shakti, close monitoring being done, integrated state level committee, high level committee, faster at state level to monitor the situation, additional performance security, and PIMS. Thank you.
Thank you very much. It's a very good insight what is happening in ministry at the policy level to bring in the cost optimization. In fact, the circular he referred to, there were two more circulars before that, and over a period of 2-3 years, we graduated in the process how to come up with something where there is less risk, but the propensity. But I feel still people have not taken advantage of that circular properly so far, but I think it will come in the coming days. The next panelist is Ravi Sekhar, Chief Scientist, CRRI. He has 24 years experience in traffic engineering and transportation planning. He holds a PhD from Kobe University, Japan, and working with intelligent transport system, GPS, GIS application, and AI/ML in transportation policy. And he has more than 100 papers to his credit. So he will be discussing how road geometry can contribute to cost optimization. Please.
Thank you, sir. Respected chairperson and other members. Myself already introduced by Professor Sarangi Sab, DG, ex-DG. So today I would like to give a presentation on cost optimization of road projects. Other like members are giving various other topics, but I am focusing mainly on road geometric design. So how geometric elements will influencing on cost optimization. So like as you said, road network or road or it is connected to the like one place to another place, but it is a economic development of growth, and particularly my previous presenter Akhil Ahmad sir already explained about road construction, maintenance, quality and other kind of thing. And the limited resources, for example, we have limited resources, either material or aggregates or any other thing, that is more important to how to utilize the optimization. And then one early stage of planning, because geometry design is a very early stage of planning. But you see, in engineering point of view, we will start about the desk study of map to connect the A and B, and then we'll go for the pre-feasibility and feasibility, then we'll go for the different alternative alignment, then finally we'll go for the fixation of the final alignment plan. So that's why this is a more important stage to control the optimization of the road costs. So like the main objective of, for example, you see in mathematical point of view, objective function, objective or optimization is an objective function. So for example, what kind of parameter you would like to optimize? So you question yourself whether you want to optimize the cost, you want to optimize the length, you want to optimize the infrastructure facility, you want to optimize the provided safety, what is you would like to optimize. But this presentation, I would like to clearly mention about the objective is mainly the optimization of the geometric like parameters. So you see other parameters like life cycle, all the three variables are more elements are safety, geometry, and also economic viability. And these are the three elements of the road construction or implementation. The final all are linked with the life cycle cost assessment. For example, the road have the other kind of the lifespan, and the structures also the lifespan. So you see the main principle of the optimization is the life cycle cost and right sizing and also staged widening. For example, you see many of the 2-lane to 4-lane widening of the projects, and also 4-lane to 6-lane widening of the projects. So the main parameter is the forecasting of the traffic. For example, then you estimate the LYS criteria. For example, I would like to go, so when I would like to make the infrastructure facility widening 2-lane to 4-lane, 4-lane to 6-lane. For example, sometimes what will happen, your road is, traffic is not reaching after 15 years level of service C or B. If you constructed a 6-lane divided like a bridge, it is a very expensive cost. So you have to decide what to be considered during in the construction stage, or maybe that can be done in the design planning stage. For example, if you can construct a 4-lane divided carriageway, so you can go for the bridge of the 2-lane, So after 15 years, the traffic is coming more, then you can use this bridge as the one way and you can consider it as an alternative other way for that one. So that's why a staged widening are also is one of the parameter for that one. So now what are the key parameters? The main key parameters are the like road cost optimization material, design standards, IRC provided design standard for the interurban highways and urban highways. Those guidelines to be strictly followed for the widening or maybe during the like planning and like design stage. So the main key parameter, once you completed the DPR, you submitted the drawings, the main problem is land acquisition. Most of the like urban like domaining areas, urban influencing area, urban development. So you are widening 2 lane to 4 lane. So what is the like land acquisition cost is the biggest problem. So most of the DPR projects delayed due to the land acquisition problems. So you can see from literature, so various compositions are there. So how it can be reduced the cost like design stage and topographic stage, material construction stage. They have given, so how to control your parameters during the like various stages of the road like designing, construction and planning. So, and another one is that material also important. For example, you want to take a flexible payment or rigid payment road. What is your like category, like type of the road you have to consider in the design stage. So that is also will influencing the cost optimization. So precasting and using the wrap and also the fly ash. These are the like, you can see that the reduction percentage initial cost impact 10 to 20%. So that's why you have to be very careful what kind of material you have to consider in the case of this, in the case of optimization. Now coming to, I will focus only on road geometry. Those are the parameters. You see the road geometry is the main 3 parameters. One is the horizontal element, second one is the vertical element, third one is the cross-section element. So then horizontal element is mainly defined about the horizontal curvature, and vertical element mainly defined about the vertical gradients and valley curve and like summit curves, and third one is the cross-section. What type of cross-section you have to implement? So whether it is a 2 lane, 4 lane, and if it is a terrain classification, if it is a rolling and hilly terrain. So same concept may not be applicable every kind of the terrain. So now this kind of the geometric influencing costs are more particularly, for example, if in the case of the horizontal element, curvature is if you are not followed the guidelines as per the standard of the class. For example, state highways, national highway, they have the different category of the minimum radius of curvature. So you have to follow those kind of things. If you are taken a minimum kind of things, you should not compromise the safety. This is another parameter that was discussed by Professor Pradeep Bhargava sir. So that I will not discuss here. I will mainly focus on the elements of the horizontal element. For example, in the case of selection of the optimum curvature, for example, sometimes it is very difficult to make a like optimum level of curvature. Particularly, it should be a very large radius, more land is required. If it is a short or a small kind of thing, there is a problem in the safety and other kind of things. And use of bypass strategy, particularly the road is widening, following to the urban areas, then you have to definitely take a action on bypass. There is a separate guidelines for the bypass, so you have to conduct the origin destination survey and how much traffic is deviating from the main city to the other city. So then you can focus on the bypass kind of thing and apply terrain-based approaches. These are the main important parameters. Coming to like vertical element, the main principles are the balancing, cut and fill. This is more important. Most of these softwares, now using the MX road and in-roads, various softwares, we have the facility to consider like cut and fill volume should be minimized. So if you are doing design, you can able to understand so how the balancing of the cut and fill design, and also the safe grades and also other gradients and proper summit and valley curve is required. So another one is the lane width. So lane width is fixed 3.5 meters per single lane. So like shoulder design also, when you are provided the hard shoulder, when you require the soft shoulder. For example, if you are going for the rural roads or the PMGSW road, if you are going for the hard shoulder, it is an expensive one. For example, in the case of PMGSY is following through in a mining area. So there is no guidelines in the particular category. You can decide yourself as an engineer. So in that case, you have to take another hard shoulder. That will be useful to overtaking facility of the vehicles and other mining vehicles like kind of the thing. So that is it is a parameters are where you have to consider the optimization parameter that is more important. So in the case of hill road design, it is very difficult kind of the things. So which can be required, either cut or fill. Which one is better? So cut sometimes it is very expensive. So you have to go for the downfall and fill side. So you fill the material and use the proper retaining walls, then this is a more better than the CRA done various projects in a landslide areas and a hilly terrains and how to like optimize the construction cost in the particular area. So second one is the median design. So in the case of median design, for example, sometimes wider median have the problem and small median also the problem. Then you have to optimize IRC is given, median width already is given, proper median width to be provided, and the drainage facility is more important. So that has to be taken care in the ROW. So I will go for some case studies, few case studies, with some done by CRA, some done by other literature. If you see Delhi Meerut Expressway, one expressway, so this is India's first 14-lane express highway. So this is mainly to decongest the Delhi urban traffic as well as inter-urban traffic of the Meerut road. So what is done, it is a mainly elevated kind of the corridor. So it is the land acquisition cost is minimized. So if you go using the, instead of elevated, so it is a very highly cost constructed. This is one kind of thing. Another one is Chennai bypass. So they have done integration with the existing road network. So that is optimized interchanges and also underpasses. This is a, like you have to thoroughly understand not only one single attempt, you cannot able to finalize the optimum alignment. So that's why you have to various options you have done, then only you can able to find out. Another case study, there is a NS 516B. So there is a connection from the like Pendurthi to another like border, the Orissa border. So there is a the alignment. So if it is like 2-lane to 4-lane highway, if you are using the like urban areas, so then it is very effective, cost is very high. So then construction, like consultant have been taken 4 different alignments. So bypasses, there 2 bypasses they have considered, and accordingly they have made a cost estimation. So greenfield highways are better than the like urban kind of the things. So construction cost, rail over bridges, and also the like forest clearance and also the railway clearance. This is a very highly time consuming and cost effective kind of thing. So sometimes you can go over the green road, green expressway, or bypass the green area. So that may be the better. So they have considered different alternate alignment. The main point of the alignment fixation is the cost and infrastructure facilities. So that is the kind of thing. So they made for the 4 different alternative alignment. Finally, they make for the 4. And also you should not compromise the speed also. You should not compromise the safety also. So that's why which is the most high altitude optimized alignment that is more important. Another alternative material that I will not discuss much. So use of wrap material, cold mix technology, and fly ash. CR has done lot of work in the using the waste material and fly ash and cold mix technologies. So now another option is that modern technology. So this is more important. Now earlier it is difficult to use the survey. Either in like 25 years I studied in a BTech. At the time you have used a plane table and dumpy level and theodolite kind of thing. Now you have the drone surveys, satellite data, and many other kind of the technologies are came. So building information modeling, drone surveys, and also artificial intelligence. For example, you want to have connection of A and B. So you have given some kind of optimized parameters. It will suggest the optimum route to connect the A and B. So that kind of the available technologies are there now. So you can able to focus. Sierra done one work with the border roads with a high altitude 17,000 feet road, India-China border. So there what we have done, we have collected the satellite data and also we have collected LiDAR data. We have used the Google Earth data. We have combined the data and we have provided the like a digital elevation model. You can see right side digital elevation model, and then we combined optimized alignment were designed. Like for the high altitudes. High altitudes is very complicated exercise. If you make high like gradients, it is very, cutting is very high if it is very expensive. So that's why we have done different alternative like alignment designs, and also landslide also one of the major point, whether the cut is stable or not stable. So these things have to be checked every 50 meters interval or 100 meters interval. So the CRA has done challenging work and designed an alignment and submitted. So another part of is that, for example, which parameter is more important? You have to done some kind of statistical analysis. For example, my optimization of the cost, or what is the right side parameters. My optimization is the radius of curvature. What should be the influence parameter? Do some kind of statistical analysis, then come with some kind of the optimization like parameters, then you go accordingly. I cannot able to do. You can see here construction cost versus maintenance cost. You can do some kind of optimization exercises. And curve radius versus crash rate. So you can do some kind of exercises on like optimization of the like parameters. So finally, I would like to go for the key challenges. The main key challenges are land acquisition and delays, inconsistent quality control, and environmental clearances. This is a major problem now. So robust pre-project planning and effective stakeholder management and early identification of risk and skilled manpower. And the earlier presentation also told that, but because if you have high technologies and you have the drone data, so there is no skilled manpower to develop a digital elevation model, to develop a design. So if you are not skilled design engineer, so if you are providing the satellite data, what you will do with that data? So you cannot do with a good design. So that's why skilled manpower, skilled design engineers are most important kind of things. So finally, I would like to conclude my presentation. So the main point is that early integration of safety measures reduce the life cycle cost, and value engineering and modern technologies. So already previous presenter discussed about the value engineering point of the thing. So finally, the future is that you have the advanced technology. So high-end technology. So use the optimum parameters and AI-based technologies and other kind of the parameters. So in your design, and also that can be useful to connect the proper connection of the horizontal element and vertical element. So that is my final conclusion about the geometry design. So I have used various IRC references and also ADB and World Bank reports for this presentation. Thank you all. Thanks so much.
Thank you very much. It is a very enlightening presentation. Although it had components apart from the road geometry, but the road geometry components are really very interesting because of more and more reliance on the software, MX, AutoCivil, like that. Without proper understanding of the geometrics by the designer, we are compromising many things. We are compromising cost, we are also compromising safety. So very nice presentation. Next is Mrs. Arundhati Sharma, Superintending Engineer, PWD in Maharashtra. She has more than 25 years experience in PWD, handled AD funded projects, HAM projects, maintenance of around 6,500 kilometer length of road, and good experience in precast concrete panel road, soil stabilization, white topping, etc., which is very prevalent in Maharashtra. So, Madam will be speaking about case studies of cost optimization in Maharashtra. And
good evening to all of you. Thank you to Sarangi sir for introducing me. My co-panelists here explained all the details to arrive the cost optimization considering geometric designs. Now, I'm going to explain some of the points how to arrive the cost optimization practically on field on road projects. Something like that, road projects involve large investment in terms of materials, equipment and manpower. The millions of rupees, crores of rupees we have to invest on only 1 kilometer road. So the saving in 1 kilometer in rupees will achieve a great optimization in cost of overall project. So that efficient use of resources, quality and durability, on-time delivery, and objective is achieve best value for money without compromising quality and performance. The 4 stages where we can achieve our cost optimization are at the stage of planning and design, just explained my co-panelist, construction phase, project management, and maintenance and operations. My presentations involve some of the cases which actually I have executed. The examples are related to the construction phase and maintenance and operation and project management phase. The planning and design stage, that is route alignment optimization, value engineering and use of local materials to avoid the leads and lifts which reduce the cost of the project. Design for life cycle cost, not just initial construction cost. Construction phase optimization can be achieved by efficient equipment utilization, proper planning and preventive maintenance of equipments, material management like bulk procurement, by floating the e-tendering system to get the material at very low cost. Storage control policies can be implemented. Optimized mix design also will help to reduce the cost by conducting trial mixes with use of like stabilization techniques, the waste material fly ash, GGBS, that is waste material of blast furnace slag, and the recycling of asphalt pavement, that is RAP. In most of the big projects, we remove that existing road surface that can be used, and we can achieve some of the cost reduction. Skilled workforce also will affect. Training improves productivity and reduce the rework, so the building capacity is also important. Time optimization can be achieved by detailed scheduling, like using software for project management, parallel activity execution, then resource planning, right equipment at right time. We should avoid the ideal resources on site. The risk management, that is early identification of critical activities, and to find the mitigation for that critical activities, we can achieve the cost optimization. Some of this example, the soil stabilization I have used for Bari to Sinnarghoti road. The first slide indicates the existing road condition was like that. Then we have used the soil stabilization. That machine indicates PTR machine. That machine at a time can do that pulverization, trenching, and reclamation also. So that machine is used for soil stabilization. And in last picture, we can see the compaction of reclaimed stabilized soil. Now I will brief in short the process that after reclamation, we have constructed the concrete pavement, and that finished surface we can see. Now this is road design parameters, some of the, that is we have used the paved designs, and for vertical compressive stress and for horizontal tensile stress, that IRC 58 we have used. That CBR, that dynamic cone penetration, and all tests we have conducted. Just a minute. Yeah, for soil stabilization, we have used that cement dosage as 4% for dry weight of soil, and base seal dosage as 750 ml per cubic meter of soil. That flexible strength or minimum 4.25 MPa. That rainfall at that area was 4,500 mm, and traffic intensity was 87 MSA. Now, after stabilization, in photograph we can see the trailer weighing 150 metric ton also passed without any deterioration mark to the road base after stabilization of road. Now the soil stabilization procedure, that first the uneven damaged road surface, we have to level it by using grader and roller. Then the section of FDR, that is full depth reclamation, up to 500 mm can be done, but for this project 250 mm FDR has been done and properly marked, and cement is spread by using cement spreader work. This is the rapid stabilization to be done. The PTR done about 250 mm, that is pulverization, trencher, and recycling machine used for doing this stabilization. Mixing of that pre-laid cement, 4% doses used. The thorough mix liquid stabilization, that cement plus road crust matter is then graded over that, and water sprinklers for compaction, then surface is leveled, then surface course, and earlier the advantages against the conventional methods, that construction speed is higher because the stabilized material, when we use, the no need to take material from the borrow area, so construction time reduced by 50%, no new material required, and locally available material can be used. That durability, highly durable, as per IRC code, confirms the durability of life of 12 years to minimum, and no chance of human error also. And cost and environmental concern, that economical as old material used and no removal of crust are required, which makes that fast, durable, and green construction process also. This was executed in the ADB project For that, the project cost was 72.51 crore. I'm not going in detail as time is less. And advantages against BT road, we can see the cost comparison that without stabilization, the cost comes around 200. That 250, and with stabilization it reduced to below the 2 crores.
Madam, please
Yeah,
conclude
I
in 2
just-
minutes. Madam, this side, please. In 2 minutes, please conclude.
Yes, sir, yes, I'm going. Yeah. Some of the, again, new technology advantage against traditional BT and concrete surface. The soil stabilization is a successful technique used in the development countries. There will be many representatives coming up. It's environmental friendly also. And the advantages against traditional BT surface also there. Again, I am showing one more advanced technology, that jet patcher. In Maharashtra PWD, we are using the jet patcher to fill the pothole filling. That existing surface we can see, the proper jet patching machine having the hopper that aggregate mixing with the emulsion can be done on only vehicle. So with this technology, monsoon will also no longer. This is the mechanized pothole filling at Nashik PWD. This is jet patcher mechanized pothole filling. The loading fast nahi ho raha hai. Yeah, proper marking the pothole size, clearing the loose material from air blower boom attached with jet patcher, application of the bitumen emulsion, tack coat with pressure from jet patcher. If necessary, grade 1 or grade 2 material in layers can be filled up potholes. Properly graded premixed material is applied on the potholes with pressure. Premixed material is then compacted by the plate compactor. So the traditional method, the shallow pothole, and the comparison given by jet patcher machinery, the rates are here higher, but the life cycle cost is much more higher than the conventional methods. These are the advantages against traditional methods, which that no moving parts, completely self-contained, no air pollution, high productivity, and replaces traditional patching gang with a driver and an operator. Minimum wastage material mixed only as required, strong, long, and fasting. That white topping is another one which I have used for Ahwa, Tarabad, Nampur road. Here the only project cost sanction was only 3 crore for 1 kilometer road, and the need was of concrete road, which was not possible to execute in 3 crore 1.1 kilometer. Then I have used a white topping concrete, in which the milling of the existing bituminous surface, the cleaning and profile correction with MPM layer, then laying of 50 mm thick bituminous macadam layer done, then laying of 200 mm thick M40 grade PQC concrete done, then curing of freshly laid M40 grade, and road furniture and signages done. Now we can see the only in 3 crore how we have achieved by using white topping. The project cost is below up to 2 crore only, and for the purely PQC concrete, it was beyond 3 crore. So in only 3 crore, the cost optimization we have achieved and executed 1.1 kilometer. Another one example is of micro surfacing. There's some advantage of white topping concrete. I'm not going into that, as all we are knowing. Macro surfacing, the Maharashtra State PWD executed 10,000 kilometer in hybrid annuity first phase, and for that length, after every 3 years, the macro surfacing provision has been made, which will save a lot of cost on maintenance and repairs in upcoming days. So the macro surfacing, that is the procedure. I am not going as time is less, but the application of macro surface are having lot of advantages to reduce the maintenance cost in future. The quick application with minimum traffic hold up and traffic opening in maximum 2 hours rectifies surface defects and routes including minor cracks, hungry surface due to aging and surface oxidation. Lifespan exceeds the lifespan of ordinary bituminous concrete environmental friendly, non-polluting for environment since no heating or hot paving required, no compaction required, and longer life since oxidation is required. So as earlier stated that modern technology reduces the cost in our project. So for cost optimization, the use of modern technology is very essential. And thank you very much.
Thank you, madam. Really some good case studies. We'll move to the next panelist, Professor Bhargav Maitra from IIT Kharagpur. He's a PhD from IIT Bombay, then 24 years experience in IIT Kharagpur. And his core area is traffic engineering, planning, and road safety. Sir, please stick to 10 minutes, please.
Thank you, sir. These days we are all talking about life cycle cost. And when we talk life cycle cost, it includes cost during design and development, construction, and also operation maintenance. And when we are talking about operation and maintenance, it doesn't include only the maintenance of the road surface and the pavement, but also the accident cost and the environmental cost. Notionally, these are there in IRC guideline, IRC provisions, but hardly we take care of that during the design and development stage. It doesn't come to specific project, but the cost is bared, it's a burn to the nation, because if you see the fatality, if you see the grievous injuries, the cost is going to the nation. And if it gets distributed to the road development projects, I think it is going to be enormous. So my other panelists have focused on the construction aspect, design aspect. I will concentrate only on safety aspect and what needs to be done, some of the priority areas. 7 specific areas I want to highlight for your thought process. First is, we know that the land is a constraint. It is well known, and in future also, day by day, availability of land is going to be a more challenging task. The question is, what we are developing is a compromised design, giving the genuine reason that the land is not available. But land is not available is the reality. Say for example, median is made narrow for divided road, national highways, other roads. And we are giving U-turning facility. Median is equally narrow at intersections where there is no storage lane, no provision. Yes, the reason is known, but question is that how long we will continue to develop such compromised facilities in a land constraint situation. The reality is, I was actively involved in upgradation of IRC 73, the mother code for geometric design, and that got revised after 40 years. Believe me, hardly any research has been done to support the nation to develop modernized road engineering in terms of geometric design. We have not invested. So what I appeal, that we know our reality, let's accept the larger reality, and we need to promote research how to develop safe facilities in a land constraint situation. Accept that land is not available. If you ask me what is your answer, sir, I don't have the answer. But all what I am appealing, fund projects, innovative ideas, and let the bright minds work on that. Come out with design. This country requires such design, not what is there in the ASHTO code or even in IRC guideline, because majority of them you cannot apply, simply the land is not available. So let's accept the reality and move forward. Second, provision of pedestrians and bicyclists in non-urban highways. Whenever we are talking about pedestrian and bicyclists, it's all as if our mentality goes that it's urban situation. No, sir. Look at the vast national highway, state highway. Poor people from village, they come to highway, they use highway maybe for 10 kilometers, 5 kilometers, and then again take another road. We have not been able to stop. They are not supposed to be there as per definition. But the actual operation of the highway, if you see, they are very much there. But look at our cross section. Have we ever thought about bicyclists? Have we ever thought about pedestrians? It is the shoulder, again we are giving it, keeping in mind basically the requirement of breakdown vehicle. And yes, let bicyclists use it. And they are dangerously exposed. If you look our death toll, the vulnerable road user, the pedestrian bicyclist is very high, not only in urban roads, but also for non-urban areas. So again, you know, there has to be design, has to develop in a context-specific manner how we consider that pedestrians and bicyclists, even for non-urban road, as a user, because we need to accommodate them. I'm sorry, as engineers, I am also engineers like all of you, we are not caring for them because our design provision, everything is for motor vehicles, not for pedestrian and bicyclists, but they are existing. Third, speeding is a major issue. Nearly 70%, 68% crashes, fatalities, all are happening due to speeding. And speeding we are carrying externally. Like I develop a road, I develop it just like that, without thinking about the land use, without the environment, without anything. Then leaving it to the police to manage. That means safety and handling speeding is considered external to road engineering. Where are our roads? Why our 85th percentile speed should be 80 kilometer and the posted speed limit should be 40 kilometer. It is our responsibility as engineer to say that road engineering match to the safe speed. If we are not able to do that, there is something wrong with our road engineering. Because you will say only put it a sign, leave it to police, leave it to emergency care, education, awareness. But where is the road engineering getting developed to offer a road which is like self-enforcing? If 40 kilometer is the speed limit, how I am developing a road which is 80 kilometer or 100 kilometer speed is possible? Let's rethink. It's the time to rethink. As long as we don't think and we don't re-innovate the road engineering, nothing is going to happen. We'll keep asking and depending on police and enforcement and everything. They are all required. Please don't understand, as a professional working in the road safety field for several decades, I understand that it's not only engineers. I feel bad when engineers are blamed only for, accident and everything. Not that everything is with us. Enforcement has to work, education has to work, emergency care has to work, safe vehicle has to work. But question is, we also have a role to play. Are we playing our role in a proper way? Fourth, development of service road to reduce road friction and traffic heterogeneity. We are developing road, we are developing national highway, state highway. But look at the roads in some of the populated states. I am telling you a small example. Kharagpur to Kolkata, this section, Dankuni section. When it was widened, whatever was the number of shops and other thing, in 5-10 years time, several hundreds of development have come up. Starting from restaurant, dhaba to building to everything, directly everybody is coming on highway. Yes, I know it is not a completely access control facility, but what is happening? The country is spending crores, several crores of rupees to build a highway to promote mobility. That is getting impacted because the outer lane almost is non-functional because of the high side friction. And service road cannot be developed in a discrete manner only for few hundred meters and here and there. So what I feel that we need to relook whether we need a 6-lane highway or a 4-lane highway with service road on both sides. Let service road act as a buffer. All the developments happen around service road. Service road will absorb. The mobility on the main highway will remain in a more stable manner. and it will reduce heterogeneity because local traffic will not come and directly access to highways, and it will improve the overall performance. Please consider. So a strong policy is needed here. Here we know the thing, but we need a strong policy. Not that why is always 4-laning or 6-laning or 8-laning is a better option when we are not able to provide service road. Next, school zones and market areas. Again, I am saying, I am sorry, lot of technology. Please let us apply technology advantageously, but not closing our eyes when we are designing the road. Do we care for doing any modification in road engineering when there is a roadside school? I have shown some figures here. They are all reality. They are our roads. Just next to school. Engineers never thought that. They are existing for several decades. So the question is, how the road engineering we are we doing a different road engineering? No, the same cross section, keeping in mind only the requirement of the road user, motor vehicle user, we are going throughout like a blind person without bothering what is the land use. And the result is school children are dying, pedestrians are dying, and everybody is happening. And it is then taken as an external component. I am all asking, let it be like, inside road engineering. Road engineering gets developed considering all these aspects. Again, it's a matter of policy, matter of rethinking, promoting research, and coming out with different provisions. Safe crossing facilities is a major issue. You tell me, sir, everything doesn't go by the number and the kind of economic analysis or financial analysis we do. Life is precious. Every highway is served by buses. I don't think Odisha has got any NH or SH which is not served by buses. They are served by buses. People will cross the road. What we have done? Nothing. Leave it to them. If they can take care of their safety, they will survive. If they cannot take care of safety, they will die one day on roads. So we know the reality. How long it's known to all of us that the buses will be there. So what safety measures we are taking to provide safe passage? Infrastructure is not being developed caring for the road user and all road users in an uniform and required manner. Road safety audit, yes, it is being done. I have done several thousand kilometers of road safety audit personally. I cannot say they are not doing. PWD is doing, NHI is doing, MORTH is doing. But sir, let us ask ourselves, are we doing road safety audit consistently and uniformly? We have code, everything is there, but are we doing consistently and uniformly? For all categories of road at all stages? Somewhere you are not doing design stage. Somewhere the construction audit is omitted. Somewhere you are taking constructed audit at a stage where nothing can be done, probably to look at the really design. Also, the road safety audit has been made a function of the contract. Contract is how I am executing a project. How my scope of work in terms of safety can be different depending on the mode of execution of the project. You leave it to EPC contract or some other mode, you see the scope is different, we know it. It's not the same scope. A contractor appoints an auditor. No, the auditor has to be appointed by the Road Development Authority because end of the day when country is taking the poll in terms of fatality, it is the PWD, the MOD, the NHI, they are being asked. So, whenever, whatever is the mode of contract, let the auditor be appointed by the Road Development Authority. And here I will appeal that I have seen currently the practice is not to engage academic institutes. We talk about IITs, NITs, fine. But these days, NHI, MOD, they don't give any road safety audit work to academic institutes. All goes to consultant. Sir, let us also be part of your fight. It's a big fight the nation is doing. Let IITs, NITs, academic institute be part of it. Let them be feel responsible. So I think, please, we can engage themselves in a much better way. And I appeal to all of you, let make the road safety audit uniform and consistent across all road categories and at all stages, because life is precious. If a person is dying on national highway, it is more important rather than a person dying on MDR or ODR. That is not true. Life is equally precious. So what I would conclude saying that the larger reality of Indian roads, traffic, road user, availability of land and land use must be recognized. They are all, we all understand, but recognize them. And to bring changes in road design to make roads safer for all road users. The second, research should be promoted in focused areas as per the need of the country to develop safe design elements in a land-constrained situation, make road design self-enforcing in terms of operating speed, etc. There are very, very few focused areas. We need to work together hand in hand to bring changes in the country. We need also strong policy, as I said, that in terms of audit and a few other things, and prioritize safety of all road users in the design, especially the requirement of bicyclists, pedestrians and school children. The vulnerable road user is almost 50%. And finally, the road safety audit, as I said. Thank you so much for your kind patience. Thank you so much.
Thank you very much, Professor Bhagam Maitra. It was a very, very interesting presentation. Sir, you posed much more questions than you gave answer to that. But I do expect that from being a faculty of a very reputed institute, sir, please come up with some concrete solutions. Even if some research projects need to be sanctioned by MRTH, some policy guidelines need to be issued which has to be enforced by all and sundry. Sir, please give something concretely. At least I, for one, not as the moderator or the panelist here, I will support your idea and let us see if at least one life is saved. Definitely we gain a lot of things. The next presentation is by Mr. Junmo Seong. He's from Korea Expressway Corporation and working as a long-term expert to NHI. He's having a master degree on transportation planning and engineering from University of Leeds. He has more than 20 years experience in project development, design, construction and project management. So he will be speaking about Korean experiences on cost optimization. Sir, 10 minutes please.
Thank you, sir. Good evening, everyone. This is my second presentation today. Luckily, I got the 2 chances to present today, so thank you for IRC. Actually, the topic of the first presentation was value engineering. I think it was closer to the current topic, but I'd like to share the Korean experience in cost optimization at this time. So I prepared a very short slide. So let me get started. Yeah, I think this slide shows the everything what I want to say today. Basically, the Korea Expressway Corporation was founded in 1969. At that time, we started our construction of expressway, and thereafter, and for more than 20 years, there was no interest in cost optimization. We are very busy with building new expressways as fast as possible. So, if you see this timeline, there was nothing in between the foundation day and the 1991. But from that time, the 1991, actually there was a very important turning point. The Korea faced the financial crisis in 1997. So from that time, we have started thinking about the cost optimization. So that's why our ministry started think about the value engineering. So design value engineering was started from that time, the 1997. So, but before that, there was a small thing, the cost management system, but it was nothing actually. So we can say that our cost optimization in Korea started from the 1997. And actually, the Ministry of Finance in Korea introduced the preliminary feasibility study in terms of cost reduction. Because before that, we didn't have that kind of feasibility system because we just tried to study feasibility study, but there's no system like a preliminary feasibility study because nobody was interested in that. What will be our cost? So that's why, and so the Ministry of Finance always think about the cost optimization. So we are very pushed by them. And in 2009, when I was in the field, there was a Earth information sharing system, which is about some minimizing the mass curve. Because as you know, the cost of earthworks is very huge. And it depends on the area, but because of that, we have developed our own system to share the information, Earth information, among the contractors. So usually we thought the mass curve in one construction site. Within the construction site, we try to make a plan, very efficient plan to transport the earthworks, like excavated soils and fill soils. But at the time, something was happened, like even though there is a filling site, but just next to the site, there was I forgot the name, but we had to think about the balance between the two sites. So as an employer, we pushed the contractors to use this kind of system, and so they could find out some good way to make balance with the idea of the very efficient mass curve. So it was very successful at the time, and then it was regulated in our construction-related act. So now it's still effective in Korea. So I think this is one of the very successful thing in terms of cost optimization. And 2016, our bidding system was just lowest price bidding system, but there was so many side effects of that system. So the contractors tried to increase their costs, even though they got awarded with the lowest price. So we found a lot of side negative effects of that system. So we have changed our bidding system to the comprehensive evaluation bidding system, which has a variety of criteria from the technical points to the financial points. So this is very complicated bidding system. But in 2018, we have opened our own technology market. We say in Korea, 기술 market. So where the new technology registered, and then we share the information with all the other sectors beyond the infrastructure sectors. so that the people who want to use these good technologies, they purchase the technology from our market, and then it could contribute to our cost reduction in terms of like patent issue and something like that. So it was also very successful in 2018, and we introduced BIM in 2019. Now it's very common in Korea, BIM, but many people still the question mark BIM, because BIM is very good for cost optimization, but it makes people like some annoyed to do it in the actual field. So anyways, the BIM is one of the good measures in terms of cost optimization. The last thing is smart construction. This is an ongoing trial, and we are in the middle of demonstration stage. But we have tried automation and digitalization based on that ICT, the communication technology, as well as AI technology these days. So let me explain further after this. Yeah. This slide shows that the earliest cost optimization begins, the greater the potential benefit. We can say that the most cost savings occur during planning and design, not after construction starts. That's why Korea made value engineering mandatory before tendering for all expressway projects beyond a certain amount of construction cost. Yeah, this is the key considerations for optimization by design VE. So I think the previous presenters already discussed this one, so let me skip this. Yes, this is a smart construction. Actually, KC has been nominated as a leader of this area in construction field. So as part of a national R&D program that began in 2020, KC has been leading the smart construction technology development project, aiming to improve productivity, shorten construction periods by 25%. The progress is no longer theoretical. We have already demonstrated these technologies at real expressway construction site. Last year, we held a full-scale demonstration at some area, and their visitors could see how multi-drones and UGV, unmanned ground vehicles, automatically scan the terrain and produce a high-precision 3D digital map in a mobile control center within minutes. The same digital model was then used to guide unmanned earthwork equipment. So, yes. This is unmanned earthworks. So there's no man inside. So there is a remote control of the machine. During the operation, the sensors installed on the rollers measured the compaction levels in real time, achieving one-stop quality control from planning, no verification. We also showcased AI-based safety measurement using CCTV analytics, robot dogs here. Yeah. And the drones that inspect temporary structures, and digital twin control platform capable of monitoring progress, safety, and site operations in real time. These integrated technologies illustrate what the next generation of construction management will look like. KC's goal is to ensure that these proven technologies move beyond the laboratories into the everyday practice. Okay. Yeah. This is all my presentation. Thank you so much. Yeah.
Thank you very much, Mr. Junmo. You have given a very wonderful presentation, and I know whatever things happening there, it is happening very consistently across the projects, so that we can get some measurable results. Hopefully, we'll be also doing the same thing. The sooner it is better. And the last panelist is Madam Atasi Das, Assistant Vice President, Messrs. JR Infra Projects. She is having a master degree from University of Delaware, USA, and PhD from IIT Roorkee. She specializes in payment engineering and geotechnical engineering, and her presence is felt in IRC. So, Madam will be talking about life cycle cost optimization through appropriate selection of project features, mostly pertaining to the design stage. Madam, 10 minutes, please.
Sure. Good evening, everyone. And just a small correction, sir. I'm pursuing my PhD now. It's still not complete. And so as a part of the suggestions that we have from the industry for sustainable cost optimization and also safety and also environmental friendly features, we would like to propose that for normal highways, why don't you propose our VUPs, the LVUPs, the SVUPs, all the underpasses, the vehicular underpasses as the overpasses. Let's go at grade. Let's not have high embankment, which leads to the consolidation settlement within the material of the embankment. So let's go at grade. And then for the PUPs and the AUPs, let's go with subways. It will be a lot safer feature. And I will explain you. I mean, if we are building at the approaches 8-meter embankment, 8-meter embankments, if we will have 250 mm layer each, so there will be 32 lifts. And with 32 lifts, each layer compacted with 95% compaction, and each layer having 12.5 residual settlement is inherent to each layer. So at the end of 8-meter construction, though we say that consolidation takes place or the settlement takes place within the embankment during construction only, but in today's world, when a project is finished in a time frame of 2 years, it doesn't take place actually. So a total of about 350 to 400 mm settlement, residual settlement, is built in within the embankment. So when the road is constructed, the approach slabs will settle, our gap slabs will settle, and there will be cracks in our PQC pavement, or there will be rut subgrade settlement in our flexible pavement. So why don't we go at grade? And it will help smooth travel, there won't be any roller coaster ride. The vehicle operating cost will be reduced, and that will also make happy Professor Moitro. The vehicle operating cost will reduce, and we will save Mother Earth, natural resources, the earth, which is very expensive these days. Then also there will be RE walls lesser, and that will, a recent RE wall circular has been issued that we cannot have RE walls for a height more than 10 meters and all. So RE wall quantum will also reduce. So we will satisfy. Because what is happening these days, we are introducing numerous circulars, for use of new technologies. But what is happening, and because of the rushed construction, the new technologies are not proof checked or something, they are not implemented correctly. Why it is not implemented correctly, I will come. But then we are issuing new circulars, withdrawing the new technologies and going conventional, going back to conventional RC retaining wall, no use of RE walls above 10 meter. So we shouldn't backtrack. Then the crash barriers are there, safety features. We were given crash-tested crash barriers to be used as a cost optimization initiative. But what happened? Safety got safety was sacrificed, then circulars are coming back, going back to the conventional crash barriers. So let's be pragmatic, let's be optimistic, and let's have an engineering approach when we are introducing new technologies for optimization. And for adopting the at-grade feature, we will reduce the land acquisition features also. Why? There won't be any slope failures. There will be not extensive slope protection measures. There won't be any requirement of 1.5:1 or 2:1 slope features. So we can protect our slopes also. And what will happen, the cost of construction will reduce, lower carbon emission reduced, artwork reduced, material usage, fuel consumption, all these will reduce, environmental footprint will increase. Now coming to the upcoming, so how we can do? Upcoming DPRs and project designs for plains and semi-hilly terrains, we can adopt this, which will increase the durability, it will increase the cost effectiveness, and also the environmental sustainability. Now coming to the negative impact of the mad rush to the construction cost that is happening. These days we are having very competitive bids, and to maintain the competitive bids, the initial cost of construction is like it's sacrificed. And what is happening? The maintenance cost is increasing, and that is having an effect on the life cycle cost. So how can we make the life cycle cost sustainable? Like in this way, optimization, we introduce geogrid reinforced pavement in 1, 2, 3 layers without like having a durability check on that. Then use of wrap is rampant. I mean, whatever percentage without, we have to use wrap, but with proper design. That design knowledge base, how to handle wrap management, storage of wrap, that knowledge base is still not there, still not extended. We need to educate the industry. Extensive use of geosynthetics without appropriate design has to be avoided. And now Akhil sir mentioned that use of new technologies, but we welcome new technologies. But at the grassroots level, I represent the contractor side. I know they are not ready to adopt the technologies. What is happening is that I want to use geopolymer concrete. They don't want. They want to stay conventional PQC because of the workability issue. The joint cutting will be very strict. Then high dosage wrap, they are not ready to adopt the construction stringent windows that we have to maintain for high polymer dosage. Working window is very less. For short panel concrete pavement, instead of like 4 or 5 joint cutting machines, we need 10 to 12 joint cutting machines. These are like at the execution level, they are still not ready. Ravi Shankar sir mentioned we need to optimize in planning, materials, but we are doing a lot of optimization in design and materials with consideration that design has already been optimized. And then construction methodologies, it's not altered because the grassroots level is not ready. So to mitigate the design and material optimization, there is a huge mismatch. Workmanship is not there, and what is coming? It is running on negative factor of safety. Then coming to the medians, as was mentioned by Ravi Shankar sir and also Professor Bhargav Mitra, the medians, they are like these days NHAI is going with flush median. But with flush median, what is happening that we are giving bituminous offset in BC, DBM, WMM, GSB. What is happening? Water penetration is directly attacking the interface of the bituminous layer. There is water ingress and there is slippage. There is debonding between BC and DBM. There is bond failure between DBM and the base layer also. Flush median must be avoided. When we have a curved medium, the curve sits on the WMM. So our bituminous layers are protected. But this flush median, it's not giving good signs. And even raised median is okay. And skilled manpower that I already mentioned, it's not there. Now coming to some of ma'am's point, again, skilled workforce, everyone pointed that out, and early mitigation. Early mitigation is not being possible because with the tight project schedules, the identification of the failure or the identification from the use of the new technology comes when the project is already over. The construction period is over and the maintenance team are on board. And when the maintenance team is on board, the main batching plants they have already been demobilized from site. They are not equipped with any luxury of equipment that they have to maintain in the proper way when it was present. And Professor Bhargav Mitra also mentioned that the LCC that I said, initial cost, maintenance, the vehicle operating cost is getting affected with the high embankment that I already mentioned. We must reduce the high embankment concept and come to add grade because land is not available. And a circular came out that we should control overloading to protect our pavement and other reasons. But as concessionaires, I mean, they will also say, okay, we will control overloading. How? Land is required at the toll plaza locations. I mean, when the vehicle has already traveled the entire corridor till the toll plaza, there must be some unloading point also and storage facilities also. But land is not available. So the control of overloading still needs to be taken care of. There is a certain circular, the service road circular has also came up. That it's, again, if we go at grade the service road circular, that when the structure is under construction, we are going to give a heavy the bituminous thickness, that also can also be avoided. And instead of giving wherever, like we have to build the service road, instead of going for thick bituminous pavement, why don't you run our D2 traffic, the main carriageway traffic for the time being on stabilized base, stabilized subgrade, and instead of wasting the natural resources for service road. Let's optimize the service road in other way rather than thick bituminous pavement. And the safe crossing facilities that Professor Maitra mentioned. Really, I mean, we are, as vehicle drivers, we are scarce, I mean, so that none is hurt. Least importance is given to the pedestrian and human crossing traffic. We must think of them also. And also, talking about Akhil sir's incentivization of the concessionaires on the contractors on the value engineering, they shouldn't be awarded until and unless the initial service life of 5 years have passed. Incentivization should be there, but after the initial service life. And what is coming out, the training is required to the grassroots level people and encourage them for certification courses on successful adoption and execution of new technologies. Then only they will feel encouraged to adopt. Otherwise, whatever we tell them, the new technologies at the execution level, they are not willing to do so. They are not ready to take pens. That's all from my side. Thank you, sir.
Thank you, madam. You gave a very detailed perspective from the contractor side. In fact, cost optimization is not a simple thing, and neither there is a copy-paste solution for all kind of situations that varies with respect to traffic, with respect to terrain, with respect to land use, and so many things. So I don't think the panel discussion might have come forward a very concrete ways, but definitely this has thrown upon a good many points for consideration of the entire highway fraternity. Optimization will be there, and definitely over a period of time, this kind of discourses will further shape it too in a definite way, as we have seen it has happened in Korea. But the sooner we make it, it is better. We have already overshoot our original time period, but we'll still take maximum 3 questions. And Mr. Ingule, you can have your question. First introduce yourself and tell your question and the panelist whom your question is directed.
Good evening all. My name is Prakash Ingole. I am a former Chief Engineer PWD Maharashtra. It's not a question, sir. It's one of the points which all the panelists, I think, have missed in relation to the optimization of the construction cost. When we say, we normally talk about 2 terms. One is cost overrun and another is time overrun. The time overrun is directly, the cost overrun is directly related to the time overrun, sir. So the time overrun, we see that 3 aspects are majorly contributing to that. The first one is the land acquisition. The second one is the shifting of the utilities, and the third one is the environmental clearances. So, shifting of the utilities require the coordination between the different organizations. So, from the initial stages itself, we should look into those aspects and coordinate with all the utility providers. My suggestion initially was that there should be 3 stages of construction. One is the DPR stage, second is the completion of all the utility shifting and the clearances, and the third is going for the construction. That will, to my thinking, will contribute a lot to the optimization of the cost. So thank you.
Thank you. Okay, please.
My question is, Mr. Akhil Ahmed, so now you have added one more addition. The value engineering clause now has to be put in. Okay, are there any guidelines for that? In the DPR.
Ministry has issued circular 20 September 2024 about the value engineering. Mr. Abdul Kant has issued circular. So that circular is quite detailed and everything is given. It is long circular. So you could simply follow that. And in every DPR, consultant has to provide this value engineering and for schedule also what value engineering they are adding to it. It is detailed circular. And for Chief Engineer's point, I would like to say land acquisition, all these issues, that was in my presentation. But certainly these are the challenges and this is continuing challenges. So everybody is aware of this and that has to be resolved. But due to center, state, so many issues are there. So to resolve them is not easy. So many coordination committee are there. Chief Secretary level meeting are being done monthly level. But still those issues are not being resolved. Different thinking are going on, just like now appointed date cannot be given without 90% land just to improve that. Same is going with utility shifting that has been included in the concessionaire scope so that, or contractor scope, so that they can be shifted. Time delay is not there. So these aspects are already being taken care of, and certainly it is a learning process, learning curve. Slowly we are learning and improving, improving. Thank you.
Yeah. My question is...
so this is the last question, sir.
Okay.
Okay, please.
My question is in the form of consideration to the all panelists. As Madam Das was saying at the last, that the contractors are not always ready to adopt the new technologies as it has its own cost. And of course, I also understand as a field engineer that contractors are always hesitant to execute the new technology in the field. So, the contractors, engineers and designers, they should converge somewhere to reach the optimization cost. Otherwise, there is no point. Because you see, the designer may give any design, any optimistic, any cost optimum design from his point of view, but if it is not cost optimum design from the contractor point of view, then he won't adopt it. So that convergence is very much required. And I think there is a lag in this approach.
You are very correct, sir. That's why even if now we have made it, I think the last circular, if there is any savings to the contractor, it will be retained by the contractor. There is no sharing of the savings with the ministry or the user agency. But what happens, there is lack of preparedness from the contractor side. The authority engineer many times plays the spoil shirt, does not have the confidence, neither want to go this way or that way. But hopefully over the years, because as the manufacturers, because they are the key, they are promoting their products as they go on doing it, maybe slowly we'll do it, but certainly after the circular issue, only problem is not going to solve.
See, everything has its own cost. Environment has its own cost. If you use environment-friendly technology, then definitely it is costlier. We should admit it. So there is also a point of dispute somewhere that if you adopt environment-friendly technology, then you have to pay some extra cost. Then who should bear it?
It is not about environmental friendly measures. Actually, we are discussing about the cost optimization techniques. And the cost optimization techniques, many of them are also environmental friendly. But the thing is that the method one should adopt by the contractor and with the concurrence of the consultant, authority engineer or independent engineer, so that the product can be used and it can be demonstrated at the site during the trialing itself. that it is going to perform. Of course, long-term evaluation will be always there. But in the initial stage itself, there is a lack of coordination and there is a lack of trust, so which is not helping the cause.
Thank you.
Sir, the point is that, I mean, number one is there has to be risk sharing because contractor is willing to take the risk, but the risk has to be shared also. Okay, savings may be to the contractor, but the risk sharing, risk is huge. Number 2 point, as I said, adoption of new technology. The classic example is the SMA issue in our country. We were given to construct SMA, but the suitable knowledge base or the suitable handholding was not there, which can be improved as we learn. But वही है कि the grassroots people adopting the same BC जो चलता आया है वैसे ही construct करते हैं. So the risk of adopting new technology and hand holding, that's the most important.
Sir, I was not inclined to take more questions, but yours will be last. No more questions after that. Please, sir. Be brief.
Myself, Professor Sanjay Samantray, alumnus of IIT Kharagpur. I think Professor IIT Kharagpur is sitting exactly in front of me. So, sir, actually, this is a question to you, sir, from alumnus IIT Kharagpur. Sir, exactly, your talk was really excellent. One point is hitting me, and of course it will be hit others also, that to save one life is most important. But what happened? In the morning section, I was just listening about the road accidents. In National Highway, it is 31%. State highways, it is 22%. Other roads, it is 46%. And the accident is increasing day by day. So, Indian Roads Congress must take it very seriously. And particularly, we are discussing here about your cost optimization road project. Just now we are discussing how we can relate to this. So how best you can reduce this by optimizing the cost. Is it possible? Sir, can you reply this?
As I said, there is no doubt that the country or the nation is bearing the cost. Now the question is, when you are doing DPR, we are saying conceptually you take the accident cost and we should consider life cycle cost. But there is no explicit provision how to consider the accident cost. But what I tried to say, some of the areas, of course it was 10 minutes, so I mean I could not go into much detail. But the question is that we have also something to do to make a better road engineering, to make our infrastructure design safer. So I am saying, rather than treating safety as an external aspect, you build the road and then you start thinking about crashes and enforcement and doing modification. It has to, the road design itself has to evolve. So that was my appeal. And how we can change the reality, it has to be only through our collective efforts. So we are ready. I mean, if you are happy to, work with, your institutes here or even IIT Kharagpur, let it be a collective effort.
Yes.
Because the things are that, as I said, our designs are there, but there is no adequate provision. You say highway design, it doesn't cater to the requirement of pedestrians, bicyclists, but the larger reality, in Odisha, what is happening. So how long we will, experience and absorb such deaths? It may not be directly coming to you as a project director or the project engineer, but if you look at the cost to the country, to the nation, it is huge cost, and we have to care. So when we are talking about the cost optimization, some way or other, at least conceptually, everything you cannot quantify. Everything it's not possible to quantify easily. But how to build the road engineering or make the road engineering safer, and there I identified and highlighted a few aspects. Maybe we can go much deeper, but a few aspects. And there are certain policy aspects. As I said, development of service road, making the audit uniform. We have everything, but we need to take a strong policy resolution to implement those. So others we need their help. As I say, enforcement play very big role, road user awareness, everything. But also there is an ample scope to look at the way the road engineering is being done today. That was my opinion.
Okay, thank you, sir, for the nice reply. Thank you, thank you.
Thank you, sir.
I think Professor Mitra has very nicely explained that. With this, I close this panel discussion. And before that, I thank all the panelists for their rich presentations, bringing into forth the issues that will be further debating and discussing in the coming days, so that we make cost optimization is really happening and happening without compromising the outcomes of the project. Thank you all.
Thank you so much, sir. Requesting everyone to please stay back with us for a few more minutes. And a big thank you to our respected moderator for the session, Shri D. Sarangi, sir. And now would like to request our respected moderator, Shri D. Sarangi, sir, is going to felicitate with a memento to all our panelists. So first, would like to request Shri Akil Ahmed ji. Please come forward. Thank you. Let's give a big hand, everyone. Now requesting Shri Chandra Rabi Shekhar. Thank you so much, sir. Now requesting Mrs. Arundhati Sharma, madam. Now requesting Professor Bhargav Maitra, sir. Thank you, sir. Now requesting Mr. Junmo Seong, sir. Now requesting Ms. Atashi Das, madam. Now requesting on stage Senior Chief Engineer, Works Department, Government of Odisha, Shri Hare Krishna Panda sir, to kindly grace the stage. And he is going to felicitate our moderator of the session, Shri D. Sarangi sir. Thank you so much, Hare Krishna Panda sir. And thank you so much, Shri D. Sarangi sir, along with all the panelists. Thank you so much, sir. Namaskar. Well, ending the session 12 for now. Enjoy the entertainment segment. Thank you so much.